El proceso de acreditación institucional con CONEAUPA nos ha ayudado a descubrir quiénes somos, dónde estábamos, dónde estamos hoy y todo lo que nos hace falta por hacer. Este proceso ha facilitado el entendimiento de la importancia de mantener un estrecho contacto con el sector productivo, el cual nos ha permitido alianzas estratégicas en todas nuestras áreas del sector marítimo, a través de firmas de convenio, acuerdos nacionales e internacionales que permiten intercambios, movilidad estudiantil y de docentes, investigaciones y acciones conjuntas interinstitucionales en Panamá y en todo el mundo.
Ha sido una oportunidad de conocer y entender la naturaleza UMIP a través de los factores de docencia, investigación, extensión y gestión, logrando una integración institucional, al entender al final que juntos podemos lograr muchas cosas en beneficio de los estudiantes que son nuestra razón de ser. Además, hemos podido visualizar oportunidades para el fortalecimiento del inglés, a fin de lograr una mejor formación y oportunidades de embarques de los estudiantes. Y entender que en estos procesos de mejora deben involucrarse a toda la comunidad universitaria, especialmente a nuestros estudiantes.
Igualmente, estar pendientes de las adecuaciones en la infraestructura de la institución para el equipamiento de laboratorios, talleres, simuladores, además de las áreas de acceso para estudiantes con discapacidad. Además, el desarrollo de proyectos de inversión que impacten en las competencias que deben demostrar nuestros estudiantes. Entender que cada colaborador en la UMIP tiene una responsabilidad para lograr los objetivos de la universidad. Si cada uno pone un grano de arena, lograremos grandes cosas para nuestros estudiantes.
El proceso de acreditación para UMIP ha representado una mejora en la adquisición bibliográfica de todas nuestras especialidades y el servicio de base de datos virtuales con el que antes no contábamos. También para mantener un apoyo constante hacia nuestros docentes a través de la especialización en diferentes temas para el desarrollo de profesional hacia nuestros estudiantes. Fortalecimiento de tecnologías de la información y comunicación.
Este proceso ha representado para todos nosotros en la Universidad Marítima Internacional de Panamá un gran reto. Además de eso, una escuela en lo que a evaluación y acreditación institucional se refiere. Fue un gran momento en compartir con profesionales de alto nivel de universidades estatales y particulares que en verdad fueron enriquecedoras para el conocimiento, siempre acompañados del personal de CONEAUPA que en todo momento estuvieron ahí para nosotros. Todo esto nos permite decir que nosotros en la Universidad Marítima Internacional de Panamá estamos listos para un nuevo proceso de reacreditación y todos los procesos que busquen el mejoramiento de la educación superior en Panamá.
Felicidades CONEAUPA, que sigan cosechando éxitos.
Good morning, everyone. Transmitting from the heart of the America in the bridge of the world, Panama, in the special location at the Pacific entrance of the Panama Canal, the International Maritime University of Panama host institution of the MTCC Latin America. Good morning, everyone. We present today our international virtual conference on alternative marine fuels and the challenges for Latin America. Muy buenos días a todos los presentes, a todos los que nos acompañan el día de hoy. Sean bienvenidos todos a esta conferencia internacional virtual, Combustibles marinos alternativos y los desafíos para América Latina. Now, we are going to present the agenda of our conference today, Alternative Marine Fuels and the
Hello, ladies and gentlemen. We are now present at some problems for audio, but we'll start in some few minutes coming back. Now, we are going to continue with the agenda. We present now the agenda in Spanish version. Para la conferencia tendremos expositores de nivel internacional y nivel nacional. Esta conferencia tratará temas muy importantes sobre combustibles marinos alternativos. With the agenda, we have international and national speakers. We will continue with the conference with the different topics related to the alternative marine fuels. Please continue with the agenda. The first speaker. Now we are going to the opening words. Ahora continuaremos con las palabras de bienvenida. Now we are going to present the president for the International Maritime Universities, Panama, Professor Victor Luna Barahona. Hello, dear President Barahona. Thank you for being here with us and give the opportunity to make the opening word. We are so happy now to present you in this conference. Thank you, Mr. Victor. The floor is yours.
Thank you very much. Muy buenos días, tengan todos, damas y caballeros. Para nosotros es un verdadero honor darle la más cordial bienvenida a este importante encuentro a través del cual el Centro de Cooperación de Tecnología Marítima para Latinoamérica, MTCC, por sus siglas en inglés, y la Universidad Marítima Internacional de Panamá, UMIP, damos paso a la primera conferencia internacional del centro para este año 2022. Aprovecho en primera instancia para dar un cordial saludo desde Panamá a todas las personas que esta mañana nos acompañan, organizadores, expositores, personal de coordinación y logística y, por supuesto, a los cientos de participantes que estarán uniéndose a esta conferencia, entre los cuales se suman en una interesante cantidad nuestros estudiantes y cadetes de las diferentes licenciaturas y técnicos que se ofrecen en esta Casa de Estudios Superiores. Quiero ponderar la importancia de la educación de calidad y la excelencia y, por supuesto, la capacitación continua como partes sustantivas de los requisitos para el logro de las metas y objetivos que nos trazamos. Para nosotros resulta primordial este trascendental encuentro que en esencia busca encontrar caminos viables ante la necesidad de la industria marítima de crear una especie de matrimonio, de simbiosis permanente con la sostenibilidad. Creemos fervientemente en las ideas e iniciativas que se sustentan en una visión con amplia responsabilidad social, de desarrollo sostenible, de desarrollo de energías renovables y, por supuesto, de eficiencia energética. Estamos convencidos que el mejor modelo de negocios será siempre aquel que coloca en un lugar de preponderancia a la conservación ambiental y la sostenibilidad. En esta primera conferencia internacional denominada Combustibles Marinos Alternativos y los desafíos para América Latina, se pretende generar un debate de altura respecto al valor y jerarquía de temas de relevancia para la existencia misma de la humanidad, como las opciones de combustible con bajo o nulo contenido de carbono para garantizar la transición del transporte marítimo hacia la cero emisión de gases de efecto invernadero. Adicionalmente, en este encuentro evaluaremos la seguridad de estos procesos, la regulación existente, el precio de los productos, la disponibilidad de infraestructura, las emisiones del ciclo de vida, las dificultades de la cadena de suministro y los obstáculos para puesta en marcha, entre otros. Con este fin, hemos involucrado en esta conferencia a diferentes actores en el proceso de transición energética, a fin de alcanzar lo más pronto posible los objetivos establecidos por la Organización Marítima Internacional, OMI, sobre la reducción de las emisiones de gases de efecto invernadero procedente de los buques. Este día de debate tendremos a fondo una gira alrededor de la temática trascendental para la sostenibilidad del sector marítimo, combustibles marinos alternativos y los desafíos para América Latina. En este marco conceptual podremos conversar, evaluar y analizar el uso de los combustibles marinos alternativos sostenibles, es decir, las experiencias que hemos tenido con el hidrógeno, el metanol, el amoníaco y el gas natural. Analizaremos también el desarrollo de tecnologías emergentes aplicadas a los combustibles alternativos, que iremos desmenuzando con disertaciones sobre los motores de combustión interna y su utilización con combustibles alternativos, medidas de eficiencia energética aplicadas a nuevos buques que utilizan combustibles marinos alternativos. En adición, se analizará el tema del suministro y el almacenamiento de combustibles marinos alternativos desde el punto de vista de la necesidad arraigada de la formación y la capacitación que requieren este factor para su implementación y su relación con la infraestructura y comercialización a través de un proceso educativo y desarrollo de capacidades en la gestión de la energía marítima. Luego, intentaremos profundizar en las políticas, estrategias y oportunidades para la utilización de combustibles marinos alternativos con casos de éxitos. En fin, esta será una jornada de actualización pertinente e interesante que cada uno de todos los participantes, en especial a nuestros estudiantes, deben aprovechar al máximo. Salud para todos, muchas gracias y mis deseos de éxitos en esta gran jornada del día de hoy. Saludos.
Muchas gracias, señor rector, por sus excelentes palabras de apertura a esta importante conferencia del día de hoy. Damos inicio a nuestro programa del día de hoy. To continue our programs, we are going to welcome our moderators today. Okay, the first moderator, please. Okay, the first moderator, Ervin Vargas Wilson. He is marine nautical engineer graduate from the Panama Nautical School with more than 20 years experience in the maritime industry, working as chief engineer on board ships and occupying the position of technical superintendent in shipping companies nationally and internationally. He has studied in postgraduate degree in higher education, postgraduate degree in shipbuilding and naval repair, diploma in tugboats, engineer at the Train to Trainer course on energy efficiency ship operation organized by the IMO, and other technical courses. Currently is professor at the International Maritime University of Panama and holds the position of Marine Engineer School Director of the Nautical Science Faculty and is the Technical Director of the MTCC Latin America. The second moderator, Javier Diaz. With over 10 years of experience in the maritime field, Mr. Javier Diaz graduated from the International Maritime University of Panama with degree of Nautical Engineer, Specialized Navigation and Maritime Transportation. He holds the unlimited license as chief mate with sea experience in car carriers and crude oil carriers. In addition, is specialized in ISO quality management system as auditor and trainer of ISM, ISPS, and other IMO-related courses. He completed additional studies such as postgraduate degree in higher education at UMIP, also a master's degree in maritime affairs with a specialization in maritime safety and environmental administration at the World Maritime University. Currently is professor of master's programs and the Faculty of Nautical Science of UMIP. Also is the technical officer of the MTCC Latin America. Please welcome our moderators today.
Thank you, Arisel, for your excellent presentations. Now, we are going to present our first speaker of this International Virtual Conference in the first block. The first block that we are going to present use of sustainable alternative marine fuels, experience and lesson learning from the International Association Classification Society. Now, we are going to present our first speaker, Mr. Joshua Padetti, as a senior engineer at American Bureau of Shipping Global Sustainability Center in Houston. He has been with ABS since the 2014, and his experience encompasses a wide variety of topics, including sustainability, alternative fuels, emissions, environmental compliance, ship machinery, marine piping, statutory compliance, and road development. He has a Master of Science degree in Mechanical Engineer from the University of Michigan, Ann Arbor. Mr. Joshua Padetti is going to present the topic, hydrogen as a marine fuel and the challenge of decarbonization. Thank you, Mr. Joshua, for being here with us in this conference, and we are so happy to keep you here. Now, we are going to give the floor for your presentation to the audience. Okay, Mr. Joshua, you can take the floor.
I hope I'm audible, and welcome and thank you for joining me today as we discuss the part of hydrogen and where it fits on the journey to marine decarbonization. I am Joshua Padetti, Senior Engineer, as Irvin just introduced, at the Global Sustainability Center at ABS in Houston, and your speaker for this session on hydrogen. And I hope you can see my screen and hear me well. If not, please do let me know. I am unable to see and monitor the chats. So if there is anything, Erwin, please let me know.
Yes, sir. Yes, sir. We confirm.
Thank you.
You can continue.
So let me quickly go over the agenda for today's discussion. I will be going over the International Maritime Organization's greenhouse gas reduction strategy, and then talk about hydrogen's production, emissions, storage, use in engines and fuel cells, and then wrap it up with regulations, standards, the hydrogen economy, and then give you some final key takeaways and take questions at the end. Before we begin the discussion on hydrogen, let's talk about safety. Safety is the cornerstone of everything we do here at ABS, and therefore I'd like to take a moment to cover it. Now more than ever, we're spending hours seated in front of a computer, so it's important to make sure that the environment in which you're working is set up to be ergonomically sound. This includes making sure that your feet are flat on the floor, your elbows are close to your body, you have a chair with good back support, your head, neck, and back are straight, and that you're facing forward. Now that you're in a good ergonomic position, let's get started. A quick introduction to the American Bureau of Shipping and the Sustainability Center before we jump into the topic. ABS is a maritime classification society, and I'm here with the Sustainability Center. We deal with all items related to sustainability, including alternative fuels, emerging technologies, and environmental compliance. We have 5 centers all over the world to help our clients in different regions, and my office in Houston primarily deals with all inquiries related to North and South American regions, including the Caribbean. Now moving on to the main topic. The International Maritime Organization, or IMO, continues to contribute to the global fight against climate change. And as part of the United Nations Sustainable Development Goals, the IMO is striving to take urgent action and reduce harmful emissions related to climate change. So as part of this, in 2018, the IMO adopted an initial strategy on the reduction of greenhouse gas emissions from international shipping. And they have goals, and these goals include the reduction of CO2 emissions for transport work as an average across international shipping by at least 40% by 2030 and pursuing efforts towards 70% by 2050 as compared to the 2008 statistics. Also, the total annual greenhouse gas emissions are set to be reduced by at least 50% by 2050 when you compare them to 2008. Now that we have a clear background on the drivers behind the industry's increased focus on alternative fuels, let's see where hydrogen fits in this journey towards decarbonization. So, in order to understand that, it's important to first take a look at the properties of hydrogen. And as you know, hydrogen is a very small molecule. It just has 2 atoms. It's a naturally buoyant gas, and at atmospheric pressure and normal temperatures, hydrogen is colorless, odorless, tasteless, and a non-toxic gas. Hydrogen has a wide flammability range when mixed with air or oxygen, and it has a very low boiling point where it will liquefy below -253 degrees Celsius. Hydrogen has the highest energy per content mass of all the fuels, but it has the lowest energy content by volume. And what that means is by storing compressed hydrogen on board a vessel, it would require 8 times the volume of marine gas oil or MGO, and liquefied hydrogen would require over 4 times the volume of MGO. Now that we have a basic understanding of hydrogen, let's discuss about the production processes. Hydrogen can be produced from fossil fuel sources or from seawater, and based on the data from the International Energy Agency, or IEA, in 2019, 23% of hydrogen was produced from gasification of coal, which is called brown hydrogen. Another 75%, which is the major chunk, was produced by natural gas, called gray hydrogen, and the remaining 2% was produced renewably. The term blue hydrogen describes the production of hydrogen from fossil fuels by using carbon capture, and green hydrogen describes the production of hydrogen from water with the contribution of renewable energy such as wind and solar. The term orange hydrogen is often used to describe a blend of the above two, like 50% gray and 50% green. All that said, in order to benefit from the use of zero carbon fuels such as hydrogen, we have to produce them in a minimal or no greenhouse gas emissions way on a life cycle basis. And the current production from coal and natural gas and regular electricity is simply carbon intensive. And the carbon intensity of these processes has been calculated by the IEA, and it's depicted on this chart. So it is worth noting from this chart that employing carbon capture and sequestration, we can significantly reduce the carbon footprint of the production processes and therefore get closer to the carbon neutral life cycle. However, something to keep in mind is that the use of CCUS is not widespread at the moment, but it is expected to grow significantly. So we have also performed some of our own calculations, and the results closely agree with IEA, and that is shown on the graph to the left-hand side. And we do show that if you use gray hydrogen, which is produced from natural gas, it has a 64% higher well-to-wake carbon footprint than very low sulfur fuel oil. And this defeats the whole purpose of using a zero carbon fuel. Therefore, if green hydrogen is used, then it has the greatest potential to eliminate the greenhouse gas emissions. So with that established and knowing that carbon capture can offer major benefits, now let's look at hydrogen storage and some of the regulations. So traditional methods of storing hydrogen involve compressing it to 350 to 700 bar or liquefying it to negative 253 degrees Celsius and atmospheric pressure, or sometimes a combination of these two. And these methods are effective to store large volumes of hydrogen, but they still result in low volumetric energy density and create the need for large storage volume on board the vessels, as we discussed in the beginning. They also have high energy demand, especially when you have to liquefy all of this hydrogen and you have to store it cryogenically. So additional methods of storage are currently under research and development, but pressurizing it and liquefying it is how it is done right now. So liquid hydrogen storage can maximize the stored energy density of the fuel, but it sometimes comes with other challenges. Due to the very low temperature, a large fraction of the stored energy is simply used up in refrigerating the gas to that liquid state, and you need a lot of insulation as well. Typically, the hydrogen tanks are double-walled and vacuum insulated. In any liquid tank, if the temperature rises, then the vapor pressure will also rise, and the tank must be protected from overpressurization due to boil-off gas. Again, hydrogen is not very friendly with all metals, and hydrogen embrittlement can occur, which can result in failures. So it's critically important to employ tank materials which are compatible with the chosen phase of hydrogen application. Now, let's take a look at the options for using hydrogen as marine fuel. Hydrogen can be used in internal combustion engines, and this is an active field of research right now for using pure hydrogen or hydrogen blended with conventional fuels for improved combustion. Hydrogen in itself is very reactive, therefore even small amounts of hydrogen in the cylinder can initiate a combustion process. And several engine manufacturers have currently announced plans to market engines that use hydrogen as either a single fuel or a dual fuel combustion. Therefore, these plans are, these plans are currently limited to 4-stroke engine designs primarily. Fuel cells are another great option, and hydrogen fuel cells have been used on land for many years as an emissions-free power source, and they're often used for reliable backup power generation for buildings, facilities, and a source of electric power for even spacecrafts. Most of the common fuel cell technology right now is the proton exchange member type, sometimes called PEM fuel cells, and the process there is essentially reverse electrolysis. Fuel cells, since they are modular, they can be connected in a series to scale up the power delivered, and this is a really great use. To optimize the performance of that fuel cell, the battery energy storage systems are typically used to manage the load requirements. Going on, the International Maritime Organization has two major codes that address low flashpoint fuels, and these are the IGF code and the IGC code. These were intended to guide the application of LNG as cargo and LNG as fuel on ships. Both of these codes do not directly address hydrogen, but hydrogen is covered through the alternative design arrangements section within these codes. The only other maritime resolution that directly applies to hydrogen is the MSC 427 interim recommendations for the carriage of liquid hydrogen in bulk. And these recommendations refer back to the IGC code until a full hydrogen code is developed. All that said, the takeaway here is the guidance from international maritime regulators on the topics of hydrogen is currently minimal at the time. Again, that said, there are a lot of land-based regulations which already exist regarding hydrogen, and these are referenced in the MSC interim guidelines. And they cover a lot of aspects, including storage, transportation, integration, safety, fire hazards, and all these types of stuff. And these hopefully will make the basis for the international maritime regulations for hydrogen. Also to note, risk assessments are a primary factor on how these regulations get accepted. So there needs to be risk assessments done, and this is common procedure for all IGF code low flashpoint fuels. So for hydrogen to become an economically feasible solution for maritime fuels in the long term, the global economy of hydrogen totally must scale up. And considering that green hydrogen is generated from renewable energy, it gives us the option to become independent from the oil economy. And producing green hydrogen can promote national energy security where fossil fuels are sometimes scarce. And the ability to decarbonize and eliminate emissions from a variety of land-based industries is expected to drive the growth of hydrogen in the years to come. And to support this large-scale growth, strategies and roadmaps have been developed to educate both regulators and policymakers, and they are shown here in the picture. Finally, let us review a few key takeaways from what we have discussed today. For hydrogen projects on board marine and offshore vessels, a thorough risk assessment will be necessary to address the various challenges and hazards of carrying and using hydrogen on ships. Second one is experience using hydrogen on marine vessels is slowly growing, but the uptake is expected to grow as countries continue to focus on developing widespread hydrogen economies. And when you use hydrogen produced from renewable sources such as solar or wind, it's possible to achieve zero emissions for your vessel. And growing that hydrogen economy can make everything more affordable and give it a more cost-competitive decarbonization solution. So ABS has put out many publications on hydrogen and related to hydrogen, which are showcased here in this picture. I have listed them for your reference, and you can also visit www.eagle.org to access all our publications for free. That brings me to the end of my presentation on hydrogen and the challenges of decarbonization. I will answer any questions and back to Erwin.
Wow, thank you, Mr. Joshua. Excellent presentation for everybody here, or the audience that you say. I see now one of the participants asked you about how could designers choose between hydrogen fuel cell and hydrogen combustion engines? You can answer that question, Mr. Padetti?
Sure, definitely, Erwin. This is an interesting choice, and depending on the type of engine, whether it's single fuel or dual fuel type, and the comparison of fuel cells to internal combustion engines, it mostly comes down to, say, space requirements, then power requirements, and then power generation efficiencies, and even familiarity of the crew and for bunkering and with the technology. And last but not the least, it comes down to cost. So all these need to be taken into consideration when you are trying to choose between a hydrogen fuel cell and a hydrogen combustion engine. Any other questions?
Yes, Mr. Padetti. Wow. Now the people are so interested about that topic. We have another question for you. This question is about the adoption of hydrogen as a fuel in the marine sector. When do you expect that will be happening?
Okay, I did address this a little bit in my presentation, but I'll take it. So hydrogen is probably the fuel that will be adopted last in the maritime sector. And we have discussed some of the reasons in the presentation today, but if I were to summarize them, I would say there is a need for effective fuel containment and storage systems, and the availability options for power generation, and the availability and the price of green hydrogen, which is hydrogen produced from renewable resources, is not there right now. So once they become available, I think hydrogen uptake is going to take off in the industry. And as we discussed, 75% is from natural gas and 23% is from other sources. So the green hydrogen, when it comes and when the regulations are updated to include life cycle emissions, that is going to really propel the use of hydrogen in the maritime industry. I think that answers my question, and I'm coming to a close with my time. So I'll hand it back to you, Erwin.
Wow, Mr. Joshua, we are so happy that you are here with us and we share about all your knowledge and experience of that topic of hydrogens. Now, we will want to give to you some words, because in this presentation that you explained, we have now many questions for you, but sorry about that for the participant, but we will have to continue with the presentations. We're going to continue on behalf of the MTCC Latin America. We present a virtual certificate of recognition of you as a keynote speaker at the International Virtual Conference with the topic Alternative Marine Fuels and the Challenge for Latin America. Thank you a lot,
Thank you,
Engineer Joshua. We will continue with the next. We have now give the word to the Mr. Engineer Javier Diaz with the next presentation. Mr. Javier, now you have the control.
Good morning, everyone. and welcome to our international virtual conference on marine alternative fuels. Okay, let's continue with our program, and our second moderator on the block 1 related to the participation of the IACs and discussing experience and lessons learned from the use of alternative marine fuels. Our second speaker of the day of this first block is marine engineer Stefano Morello, that will be presenting today the topic experience with LPG as fuel on merchant ships. Marine engineer Stefano Morello currently works as general manager, being at the same time principal surveyor, marine management system auditor of ISM and ISPS, as well as MLC inspector for the Class K Panama office. Engineer Stefano Morello is a graduate of the Nautical School of Panama with the title of engineer with specialization in naval machinery, and currently has approximately 23 years of experience in the maritime sector, which began with Evergreen Marine since July of 1998, when he first joined as a cadet, then performing functions on board as marine engineer and also as assistant of port engineer later. Mr. Morello had the opportunity to work at the Braswell shipyard in Panama as ship repair manager before he joined Class K in March 2006, for which he has been working for a little over 16 years, and which he has the opportunity to participate in different technical seminars given by the company, among other activities. We have the pleasure of having today on board in our conference the participation of marine engineer Stefano Morello, presenting the topic LPG as fuel on merchant ship. Our pleasure, Engineer Stefano.
Hello, everyone.
Hello.
Just let me upload my presentation. You can see it now?
Not yet.
The moment is uploading.
Okay.
Just a few seconds more. You can see it now?
Yes, sir. We are now see. You can return for the first slide.
Okay.
Yes, it's already now. Thank you.
Okay, thank you. Hello to everyone. My name is Stefano Morello. I am the general manager to Class K Panama office. For me, it's a real pleasure to be with all of you today and to talk about LPG as a marine fuel, where our experience is quite advanced in the society, but like other topics that will be presented here today, you will be able to see where we are and where we are heading in the research and use of alternative and cleaner fuels, where all society have their field of expertise. Talk about LPG as a transitory fuel. I will also be talking about other alternative fuels where our society is a pioneer, and also I will try to distinguish the difference between LPG to LNG as a fuel. Before going into the subject, I want to show you on this slide how the activities on the gas carrier have been developed through the decades, starting from the 50s, where study began in the development of rules of gas carriers, and where we have our first pressurized LPG classed with the society. On the 50s, on the 2000, where we have our first pressurized built type LNG carrier, and on 2020, where we have our first hydrogen carrier class with NK. On the right side of this slide, you will see this is the distribution of the gas carriers in our society, where the LPG have the majority of the share. Although time is quite limited, I will try to go through different points, such as LPG as a marine fuel, LPG fuel ships, LPG fuel machineries, picking from Class K records, and fuel switching to ammonia fuel. I would like to highlight that LPG is considered as a transitory fuel, a bridging fuel heading to zero-emission fuels, and there is an expectation of switching from LPG to ammonia in the future. Now, on these slides, you will be able to see this is a comparative table. We have LNG on one side, methanol in the other side, and the LPG. And this is the emission reduction to heavy fuel oil, to conventional fuel. We have that the reduction of NOx is about 90%, 30 to 50%, SOx 90 to 97%, particulate matters, and also CO2, the reduction will be about 20%. Okay, on this slide, you will be able to see the benefits of using LPG as a marine fuel in comparison to LNG. First, we have the fuel supply. Bunkering is an advantage since nowadays we have over 1,000 existing storage facilities for LPG. So wherever the vessel goes for import and export cargo, at the same time can have receive this bunkering. Also, small LPG vessels can be used as a supply for bunkering. That's why this is quite attractive. It's more easy to find this kind of product LPG. Also, for the handling is relatively more easy, taking into consideration the boiling point. Since for LPG propane, for example, the boiling temperature is approximately -42 degrees Celsius, while on NPG we are talking boiling temperatures of -160 degrees Celsius. We have also the density, where the LNG is lighter than air, while LPG is 2 times heavier than air. And also we have the methane number. For the LPG, methane number is quite a concern, but anyhow, this provides an indication of the knocking tendency of this fuel. Now, on this slide, you can see the projects, actual vessels and projects, how many vessels we are expecting to have by the end of 2022, about 29 vessels. All this will be LPG fuel ships, and actually all the very large gas carriers are expected to be LPG fuel vessels. There is a project on order, about 57 vessels by 2023, for a total of 124 vessels expecting to be have by the end of 2024, all fueled by LPGs. Roughly, on this slide, you can see some properties: LNG, LPG, methanol, and conventional oils. We will see roughly flash point, boiling temperature, ignition pressure, etc. As I mentioned before, the LPG is heavier than air, means that in case of any leak, this will go to the bottom of the engine room. Some additional factors, safety precautions, such as exhaust and gas detection system, have to be considered when using LPG as a fuel. On this slide, this is a common arrangement for a vessel intended to carry LPG as a fuel. We will have that on main deck. You will find the storage tank and service tank as well. You will have also this pump room where you have the valve and the pumps, and then you have the engine room. Always pump room, valve room will go on deck. while also as well as the storage tank and the service tank. We have two main components on this pump and valve room, the so-called LFSS and the FVT, which we will see on the next slides. We have the low flashpoint fuel supply system, which is basically the pump that increases the pressure and the temperature of this gas before it's provided to the engine. And also we have the fuel oil valve drain, that this is the one that provides the fuel, this gas to the engine, and also is for N2 purging. N2 being an inert gas, this is also an important element, since this helps to keep the system clean, free of any hazardous material that may cause some incidents. So this is also a basic concept to have this nitrogen, this inert gas, and this on this fuel valve system. For the storage tank, we have that requirements for tanks are basically same, but taking into consideration the properties of these two products, LPG and LNG, of course, there are a lot of difference in the design of this containment system. Difference on the materials, design temperatures, also on the maximum allowable relief valve setting. For this LNG, normally we can find nickel, aluminum, stainless steel as a material to be used for this containment system. While for LPG, we have this carbon, manganese, and steel suitable for this containment system. Now, this is where I was expecting to reach. This is actual projects on the NK with vessels. We have two from NYK lines, two vessels expected to be delivered in 2024. We are talking about very large gas carriers. We'll use dual fuel. We'll use both ammonia and LPG for propulsion. Unlike conventional very large gas carrier vessel will be equipped with separate tanks designated for LPG and ammonia. This is taking into consideration the trade patterns of the vessel. I would like to highlight as well that ammonia is attracting attention not only for raw material used for chemicals and fertilizers, but also is a zero fuel, zero emission when it's burned. It means that there is no any CO2 emission when this kind of ammonia is burned. So also, these vessels will be equipped with shaft generators, means that during normal sea passage, main generators, diesel engine can be disconnected. Vessel will produce its own electricity by shaft generator, making the entire voyage possible by using LPG as a fuel. This is very interesting. We'll need only a small amount of pilot fuel, of fuel only for pilot purpose. Now, this is lovely. I like this. This is a project which I really like. We have also, we have grant and approval in principle to Imabari Shipbuilding for the first 180,000 deadweight LPG dual fuel bull carriers. These are 9-hole bull carriers. The so-called Capesize will be equipped with this storage tank will be installed on the aft of the bridge. This project is expected to be released on 2024, and the capacity for this will be suitable to make a round trip between Japan and Australia. This will be the first of a kind vessel, but as I mentioned before, LPG is, let's say, so common that make the ship's operation more flexible and also is a motivation to create this kind of design. This is also an innovating matter. We are talking that this year, this is a new matter. This year on March 2022, NK grant an approval in principle to Osaka Gas for the joint project with Daihatsu Diesel for an LPG reformer of marine engine. This is the first approval in principle granted in Japan for this kind of equipment. So what is this LPG reformance? Basically, this LPG reformer vessel we shall have this LPG as a fuel, propane, butane. As I mentioned before, there is a concern for the knocking. Knocking can cause damage to the equipment, vibrations, noise. So this changed the propane convert the propane into synthetic methane, same as the kind used on LNG. By doing this, we reduce this knocking matter, and we have the equivalent operational performance observed on LNG. So basically, we are changing LPG into synthetic methane, which is similar as using on LPG, and then we are dealing with these knocking issues. Also, I would like just to mention that alternative fuels, we are talking LNG, methanol, ethanol, LPG, these lower flash point fuels comparing to traditional fuels, there is a particular attention, and we have to ensure the adequate safety precautions, since of course we have to see the risks of any fire explosion in case this leaks into the engine room. So we have that international safety requirement for low flash point fuels have been discussed at IMO levels with the release of the IGF code, which have been adopted and enforced. But however, this did not address any specific regulation for alternative fuel other than LNG. That's why NK released 2019 the guidelines that outline safety requirements for other alternative fuels besides LNG, based on the latest technology and regulation trends in order to promote the design of alternative fuel vessels. Now, this is not the topic of the fuel, but news which I am very proud and happy to announce to everybody. This is news about the hydrogen supply chain for the decarbonizing society. I will quote this news. These are just happened a few days back. The completion of the first maritime transport of liquefied hydrogen, including its loading and unloading, which have been completed in Kobe, Japan. Suizo Frontier is the world's first liquefied hydrogen carrier, which departed from Japan on December 2021, arrived to Australia, and then to Victoria, Australia, and then load in a coal terminal this hydrogen and return back to Japan on February 2022 to unload the cargo. The demonstration of the world's first liquefied hydrogen carrier, Suizo Frontier, proved that international liquefied hydrogen supply chain is possible, making a significant step toward the utilization of hydrogen as a new energy of source. We have to consider that hydrogen is available everywhere. Wherever we look on the earth, we look on the skies, on the cosmos, in the universe, this element is available, and this is a zero emission fuel. So that's why we are heading to this kind of fuel. Also, that's why the so-called transitional fuel that we have on LPG, always looking for this zero emission fuel. In addition to this, first voyage of the Suizo Frontier, which is a 1,250 cubic meter capacity, built by Kawasaki, Class NK also issued an approval in principle for the build of a 40,000 cubic meter capacity storage tanks. In addition, NK granted an approval in principle also for the cargo handling equipments and also for a dual fuel main boiler that will use hydrogen boil-off gas for fuel. This news was released just today. We have that NK have given an approval in principle for the design of a 160,000 cubic meter large liquefied hydrogen carrier equipped with 4 of the mentioned tanks, and then an approval in principle has been given already to confirm the feasibility of this vessel. In addition to the other issues approval of principle for the cargo containment system, also for the cargo handling system and for the dual boiler that will use the hydrogen boil-off gas, in case we can make the verification of the arrangement, structure, stability, power generator, distribution, and we will confirm that large-scale transportation of hydrogen will be possible. It's a fact that will happen in the future. With this one, and the Class NK will actively continue to take part of advanced initiative toward decarbonization and also to support decarbonization in the entire maritime industry by incorporating the knowledge gained through the collaboration with frontrunners into rules and guidelines. With this, I will conclude my presentation. I hope this has been interesting for you, and I appreciate everybody for your participation on this conference. Thank you very much.
Thank you so very much, Engineer Stefano Morello. Excellent presentation, excellent presentation. I think our chat is very active, and we do appreciate also our experts and specialists who have been interacting with all the participants, responding all the questions also in the chat. We understand there are a lot of questions on this new topic. So while Engineer Morello was giving his excellent presentation, also our other specialists were interacting with all participants and the questions. That is very good, actually. And the presentation from Marine Engineer Stefano Morello from Class NK. We are very thankful, Engineer Morello, and we received also we'll tell you two questions from the audience also. First one, which are the major risks in LPG as marine fuel?
Well, we have to see that all these low flashpoint fuels, in case of any leak, it will not go to the air. This is heavier than the air, so that's why if any leak of LPG, this will go to the bottom. So we have the risk of fire, explosion, also some chemical reactions, asphyxiation in case someone is exposed to high concentration of this gas. That's why on vessels built with this kind of product for fueling, additional safety precautions have to be taken. Gas detection system, protect some equipment for personal protections, as well as some exhaust gas system to remove this in case of leaking.
Okay, excellent. Second one, why LPG is considered as transition fuel?
Well, because this is not a zero emission fuel. Reduce the air pollutants, CO2, SOx, particulate matter, but it's not a zero emission fuel. We have other fuels that are zero emission fuels. We talk about hydrogen. So we are talking about ammonia. So until we reach to that technology that we can make this mass production of these products, then LPG is suitable to reduce the pollutants to the air. That's why we call it a transitory fuel, a bridging fuel until we reach to that zero emission fuels.
Excellent, excellent. Thanks a lot for your participation and for the questions. Of course, probably we'll receive more questions during the rest of the experts' presentations, but as I mentioned, the experts and specialists are interacting with the participants in the chat. So we invite all participants also to leave your questions in the chat so the experts can reply as they consider the questions appropriate or related to the conference. Thank you, Engineer Morello, and on behalf of the International Maritime University and the MTCC Latin America, we would like to present, as a token of appreciation, a certificate for your remarkable participation as one of the keynote speakers of this international virtual conference. Thanks a lot. Very happy to have you on board. And of course, we wish you looking forward to continue working together. Thank you very much. Thank you very much.
Bless you all. Thank you.
Okay, to continue with the conference in this session of the Ajax intervention, we'll give the floor to my colleague, Engineer Erwin Vargas.
Hello, thank you, Javier. We are so happy now to hear and to listen all the explanation of the different of the two first speaker of the Ajax, and this is something important that we are mentioned now because we never seen that before, and now is the opportunity to present our next speaker of this conference, Captain Antonio Prestilla Como. Currently, Captain Antonio holds the position of Business Development Manager and Head of America's Maritime Academy. Captain Antonio is a completion professional with over 25 years of demonstrated leadership experience obtaining across the maritime industry. Well-rounded seagoing expertise encompassed passenger vessels, included cruise line ships, large crude oil carriers, ro-ro vessels, and chemical tankers. Maintain a high-level credentials within the maritime industry, including qualification of merchant ship captain and marine engineer. Offering subject matter expertise with the many years of involvement leading consultant project, IMO, and industry ad hoc working group, and specialized initiatives to support the vessel operation and maritime business development. Develop and coordinator of DNB strategic and tactical planning of maritime offshore market. He is responsible for DNB global marketing and sales strategic and tactical plan for cruise ships and yachts, in coordination with center service. Now, we are going to present the topic of LNG as marine fuel, present and perspective by DNB. Hello, Captain Antonio.
Good morning, Erwin.
We are now going to share your presentation. Please take the floor. The floor is yours.
Do you want to share the PowerPoint directly?
Hello, Captain.
Yeah, do you hear me?
Yeah, I can hear you.
Okay, so do you want me to share the PowerPoint or you will do it?
Okay, now we are going to share your presentation.
Thank you.
Okay, some minutes. We are going to present now you. We get the control.
Okay, thank you. Good morning to everyone, and thank you, Erwin and MTCC, to have me and DNB. Please, you can go with the next slides. So today, what we will talk about statistics regarding the LNG fuel vessel and LNG ready vessels. How we will show you these statistics using a digital tools that has been developed by DNV with the support of different stakeholders. These digital tools is called AFI, Alternative Fuel Insight Platforms. So the Alternative Fuel Insight Platforms will allow you to identify the locations, in this case of LNG fuel vessels, but also of port locations where you can find LNG, or you can locate futures project around the globe. At the meantime, you will be able to access to statistics, various statistics regarding such market, and any terminology, any informations that will allow you to know more about the different alternative fuel solutions and the technology. These digital tools is free, is accessible to anyone, and you don't have to pay any fees, and it is constantly updated because our colleagues around the world, they research always for new projects, new vessels, and technology regarding alternative fuels. Please, next slide. Thank you, Erwin. So as I mentioned before, the AFI, so Alternative Fuel Insight, is this digital platform that will allow you to identify the statistics, to identify all the terminology and informations that will allow you to know more about such segment. Next slide, please, Erwin. Stakeholder parties, so our big one is Shell, Yara, CAT, Barcelas, CL Energy, Alfa Laval. So all those, they are supporting us to keep updated, our informations in these platforms. Next slide, please. Thank you. So let's talk a little bit about alternative fuels and technology. In this case, we will talk about LNG fuel vessels. So these statistics that is again available in AFI allow us to identify which types of technology or alternative fuel solutions we have for the different ships segment. So in this case, we will identify with the blue colors vessels installed with scrubbers, green LNGs, batteries, brown and clear skies, blue is LNG ready, and so on. So let's talk about, for example, the bulk carriers segment. As you can see, we have 1,654 bulk carriers with scrubbers, 63 fueled by LNGs. Some of these bulk carriers have a battery used perhaps for short times in navigations or for short stays in port at the moment. And LNG ready, we have 46 bulk carriers. So at the moment, there is lots of discussions about new buildings. It's important to identify the right technology, the right alternative fuel that will drive you and your segment towards the 2050 net zero goal. So although several ships are still built using and burning fuel, so HFO or MHFO or MGO, in the futures in the meantime, so they are building those ships ready to burn other alternative fuels. Alternative fuel could be LNG or methanol or ammonia. So next slide, please. So let's talk about LNG fuel vessels. In this map, what you can see all the LNG fuel ships that are around the world. So you can see that for the area where we are, so North America, Central America, and South America, we have already several LNG fueled vessels. It's clear that when we build the science LNG fuel vessels, it's important that we consider the right trading path in order to identify the port where I can find the supplies of LNG. Next slide, please. While in this map, you can see all the LNG bunkering infrastructures that are already in place in the world, or perhaps they have been planned to be built. There is a project in Panama. There are a couple of projects in Mexico as well, and there is an existing operation project in Argentina. This is what about Central America and South America? It's clear that we will have more LNG banking infrastructure in the futures. In this case, our maps will be updated accordingly. Next slide, please. Thank you. So at the moment, we have 724 LNG fuel ships between operations and in orders. As you can see, the green one are in operations, the blue one are on order, and the clear blue, is LNG ready. So, for example, on 2022, we have 282 vessels that are LNG fueled, 108 that are at the moment on order, but as you see, we have 442 vessels on orders for LNG fueled, and we have 156 is LNG ready. Means that they have all the onboard arrangement, engineering and storage that they will allow them to burn in the futures as well LNG. Next slide, Erwin. Thank you. It's great. So this is a different segment, and from this graphic, you can identify the numbers of the vessels that are fueled. Apologize. So from here, for example, we can identify that we have 34 container vessels in operations that are fueled by LNGs and 130 that are on order, and so on. So we have even fishing vessels that are fueled by LNGs, and they are project for LNG ready as well. Next slide, please. What is the area of operations? Let's consider the Americas. So in Americas, we have 97 vessels fueled by LNG. while we have 69 vessels that are on orders. On orders, always fueled by LNG. It's clear that globally, we have certain numbers of LNG fuel ships and on orders as well. Next slide. Thank you. Are the different type of engines that we have fitted on board of different vessels. At the moment, in operations, the 82% of engines is dual fuel, so MGO and HFO. Some dual fuel, some use pure gases, and someone is at 0% is unknown. So everything is clear. So we have a clear statistic that allow us to identify, the arrangement of ships that are in service right now. Next slide, please. As you can see, the MV is the classification societies with more classed vessels that are fueled by LNG. So we have around 227. DMV has a clear set of rules for LNG fuel vessels, based also on IMO requirement on the applicable code, and we have a massive amount of vessels that are on order that we will build soon and deliver soon. Next slide, please. So if you have any questions, please feel free to put on the chat, and I will reply to each one of you. In the meantime, if you, Erwin, or other colleagues have some questions, please do so. Thank you for your attention.
Thank you a lot, Captain Antonio, for your excellent presentation in that conference. We have many questions in the chat. I don't know what I can do, but we have to tell to you some questions for the audience. Now we start the session of the Q&A. Okay, Captain. The first question that the audience asked you is, which other digital tools did DNB develop pertinent to the subject of discussion?
Yes, so digitalization today is very important. Go along the decarbonizations, and will allow us to make a business in a most safest and efficient way, for sure. Another tools that, and I will share the link on the chat now, another tools that is useful, is also essential for who is using LNG, is called Fuel Boss. Is digital tools that will allow operators and the ship's crew to identify LNG bunkering facilities and make the relevant orders. So is a platforms that will allow you to identify orders, acquires and have all the relevant documentations and papers supporting your bunkering. I'm going to put the website here, so you will have a look.
Wow, thank you, Captain, because this is important also for our student, because how is the world is changed, and how the new vessel are going into operation, also the capacity building and training for the new students have to know about the new requirement, the new type of vessel in order, and how they are working. And the platform that you showed, this is also for make a research, and and something like a student apply to bring some information, and also professional, not only student, because the professional also are looking for that. But continue. Well, we have another question, and the second one that we received for the participant how does the Russia crisis impact the LNG trades? You can answer that question, Captain Antonio?
Yeah, absolutely. Unfortunately, this crisis is affecting, the world, the energies, transitions and transportations. But it's clear that often these crises are beneficial, let's say, for the maritime industry. Again, unfortunately, because of this crisis it should not be there. Absolutely. Anyway, in 2021, the total import in Europe from Russia of gas was around 155 billion cubic meters, and around 17.4 billion cubic meters was as LNG. Therefore, this gas now that was imported by Russia should be carried from somewhere else, and we are lucky that we predict that all these LNG will be carried from the States, from Qatar, but perhaps in future we will have opportunity to see in Europe, gas coming from Japan, Korea, or Australia. Or Australia. So in the futures we will see, gas going to Europe more and more from the States, Qatar, and perhaps Australia. So for sure, the gas carrier segment is a segment that we will need to keep under control, every review, and we will see new technology, new ships coming in the closest futures. Thank you, Herbie.
Thank you, Captain Antonio, to share with us all your experience, also all the presentation what are doing DMV in this specific topic of the LNG. Thank you. And now, on behalf of the MTCC Latin America, we present a virtual certificate of recognition of you as a keynote speaker at the International Virtual Conference with the themes Alternative Marine Fuels and the Challenge for Latin America. Thank you, Captain. And we will see you soon.
Thank you, Erwin, and thanks for the invitations. Good luck to all.
We will continue. Thank you, Captain. And now we are going to pass with Mr. Javier, my colleague Javier.
Thank you, Erwin. We are back. We have been really lucky to have this high level presentations. Thank you also to Captain Antonio from DNB. Our last speaker from this first block of Ajax is Marine Engineer Edilberto Peralta. With over 23 years in maritime experience, both at sea and ashore, he currently holds the position of US and Canada Accounting Manager, previously in charge of the management of regulatory and external affairs for Lloyd's Register in the Americas. He worked also as Service Delivery Manager for the Central and South America region, leading the operational team and fostered industry and customer relations in the Central and South America region. He has considerable experience in the field service from his previous placement as Operation Manager, Senior Surveyor, Senior Auditor, Trainer, and champion of several projects within the Lloyd's Register. He's graduated from the Escuela Náutica de Panama, the Panama Nautical School, and began his seafaring career as deck cadet, working the way up to ship officer on cargo ships. He received his master's degree on Panama Canal Studies and International Maritime Industry. Also, he worked as flag state inspector of Malta and trainer for Lloyd's Register and has conducted multiple internal and external trainings engagements. He's fellow also of the Nautical Institute and is active supporter of the maritime industry in Panama, as he is also active supporter of the MTCC Latin America, have been always. We are really happy, really glad to have Marine Engineer Edilberto Peralta today with us, presenting the topic, decarbonization of shipping. Could ammonia be the fuel of the future? That answer will be from Engineer Edilberto Peralta. The floor is yours, sir.
Okay. Well, thank you, Javier, for that introduction. I don't know if I have the answer to that question. That's part of the conversation we want to have here. If ammonia is going to be, yeah, I think I'm happy to have been assigned ammonia. The reason is this is, if you ask me, between hydrogen, methane, and LNG, LPG, ammonia. In my personal point of view, I think ammonia have a good chance to be part of the solution. It's going to be part of the solution, and that's part of the presentation I want to share with you right now. So let me know when you can see it. So we're gonna talk a little bit about ammonia, ammoniaco, how we say in Spanish, and we're gonna give a brief introduction, how it is produced, and what role it's playing right now in the industry. It could be, yeah, that's an answer. Yeah, I would say yes. Could be the fuel of the future, but that would depend on a lot of things that needs to happen. Right now, there is a lot of development, review, studies, analysis to make this happen. But the good thing is ammonia has been with us for almost 100 years and more than that. And we know how to deal as a cargo. We know how to deal with ammonia, bring it from port A to port B, but using ammonia as fuel on ships is a part of the challenge we have right now on this decarbonization journey we got from the IMO. So right now, 80% of the ammonia produced is exclusively for the fertilizer industry. So it says that once ammonia saved the world when we have the food crisis, now ammonia is helping us a lot to get the crops grow faster, and so we get the food production being moving in a faster way using ammonia, and that's still part of the day-to-day operation with this fuel. The thing is, today the crisis is on the climate change. It's not on food anymore, but still in some places, of course. But now the focus is more on handling the climate crisis. So the greenhouse gases emissions, CO2 emissions, and ammonia is now part of this solution. I'm a strong believer that the only way we're gonna see those ships sailing on 2030, which is part of the goals, is using all the options available and mentioned by my previous colleagues. So it's gonna be a mix of ammonia, hydrogen, LNG. Some of the fuels will be kind of a bridge or transitional fuel like LNGs and LPG, for example, that is going to help us to bring down the CO2 emissions. So when we get to a level where we have enough production of ammonia, enough production of hydrogens, battery fuel cells, then we can move on fully to zero emissions vessels on 2050. But that is going to be a significant challenge. So is basically to talk about how this is produced. There is a process called the Haber-Bosch process, which is basically responsible for nearly the world production of ammonia, as also all the derivatives like urea and ammonium nitrate. So how this process works, we are not going into details, but it's basically using extremely high pressure force to create a chemical reaction. So it works by fixing the nitrogen from the air with the hydrogen from the natural gas in order to produce ammonia. So right now we got projects. We have several projects already in progress with different stakeholders, I think including some of the main manufacturers like Wärtsilä, MAN, in order to burn ammonia directly into the ship's engine. So when we're talking about ammonia, it is important to know when we're looking at the CO2 emissions reduction of greenhouse gases, we need to refer specifically to green ammonia. So green ammonia is basically produced from the air, by electrolysis and with the water and the nitrogen we get from the air. So it's made by renewable sources in order to be called green ammonia. Because we got different ways to produce ammonia, brown ammonia, blue ammonia, but what we want to get is to use on board green ammonia in order to be really significant reduction of the greenhouse gases. So to talk a little bit about the properties of ammonia, as mentioned, it has been produced for 100 years as a fertilizer and a refrigerant as well. So it's colorless, flammable. So far, we were looking like LPG when we moved to highly toxic. So it is highly toxic and corrosive gas. So this is part of the disadvantage, and we will expand a little bit more in the next slide. The flame speed is low, so this is a measurement rate of expansion of the flame. There is some formation of NOx during the consumption. It's highly soluble in water and low flammability, and it's not easy to burn. And the latent heat of evaporation is high, meaning that no reliquefaction will be required in the use of this gas. So in order to compare some of the properties, you will see specifically the boiling, most important, the boiling transportation is not like the LNG. It's similar to the LPG, -33. The most important is the one on the right, which is the CO2 emissions, which is basically zero. So ammonia burns without the production of carbon dioxide, as mentioned during combustion. However, the low calorific value means that the fuel, the main engine is fueled by ammonia. In some way, we need to have a pilot fuel injection in order to be an option on the market. I mean, there's a lot of research right now, and I know the engine manufacturer will have more information on this topic. So ammonia on board, the toxicity and safety aspect is something we need to highlight. We got the International Gas Carrier Code, the IGC code. This code will need to be amended because today these codes prohibit the use of any cargoes identified as a toxic product, as a fuel for the ships. However, partial amendments to the section of the IGC using gases or other low flash point gases are going to be required. For those ammonia carriers, the risk of a large release to the atmosphere in the areas where we have a lot of population also needs to be considered. So there is a requirement to change the existing regulation in order to allow this ammonia as marine fuel to be a reality. The corrosivity and material selection from the chemical point of view, this is an alkali and can combine with water. It will form the ammonium hydroxide. So especially in the presence of moisture, it will react and corrode copper, zinc, and many of the alloys. So only, if I remember clear, only iron, steel, and some specific and non-ferrous alloy will be resistant to be used as a tank for this cargo. Anyway, this is something we are already handling on ammonia when we deal with this gas as a cargo. So there is a lot of experience already in place on this marine fuel. Of course, the use of ammonia as marine fuel will, in the future, will require infrastructure for bunkering and ship maintenance. And it is logical to assume that those ports that today are handling ammonia on the terminals as a cargo, they will also handle, the ammonia trade in the future. We expect that they also have the equipment and storage facilities for ammonia, so that those, in certain way, they'll become the foundation of the network of ammonia distribution as a ship fuel in the future. That's at least what we're expecting. We will have to see how the market moves. The price on this slide is not correct. The global 100 is it is correct. Sorry, I make a mistake. It's because it was the ton $800. Now it's 1,100, and it keeps rising. So the cost of ammonia is quite significant as well at this moment. It's important to mention also what are we doing with all stakeholders in the industry. We are going to show you a quick design of ammonia engine by man. So there is a lot of research right now. We have already approved in principle several projects globally. The latest one was approved in April. So we're working with the main manufacturers. There's a lot of research on ammonia as fuel for the two-stroke engines. Extensive testing is being done with a complete engine monitoring setup in order to achieve fundamental ignition properties of the ammonia and the two-stroke engine. So we're talking about pilot fuel requirements, emission, etc. So once these research results will be ready, we can validate that information we already have on paper. Okay, this is part of the arrangement of using ammonia as fuel in general. You will see in the slide, the vapor lines, the storage tanks, bunkering station, the line for vapor, the line for liquid, the service tank, and the high pressure fuel pumps, the fuel valve train, return lines, and of course the main engine that is fed by the gas. So this is just to give you an idea of some of the projects we have been working. We got several of them, but just point out one or two. So in this case, we have the Aframax tanker approval in principle, using a ammonia fuel tanks, bunker stations, using Type C tanks, and it's a JDP with Lloyd's MISCC man, and we have been doing the hazardous risk assessment report in order to make this happen, and that's part of the of the project we are working right now with ammonia. This is a summary of the HACCP workshop. So all the areas all the issues that has been identified and what recommendations are being made. Most of them are really related to the toxicity and the problems to the safety and the health of the staff. The main concern in this is something goes wrong, there's a leakage. We cannot compare that if we got right now a leaks or oil spill of bunker. So two different scenarios, and there are a lot of things on the safety aspect that we need to take into consideration. So bunker procedure, understanding toxicity safety concept, and all the the properties of the ammonia, especially for the users. So I think this point is quite important now that we're talking in a panel of university. It is important that we got all the crew members really familiar with not only with ammonia but with all other alternative fuels that are going to be in the market when these students are on the ships as a trainee cadet. So challenges of ammonia as fuel. So basically we have these columns. So bunkering is one of them. So the loading and unloading of terminal, it is available right now, as we know, as a cargo, but the bunkering structure is not developed for fuel ships in order to bunker fuel. So how are we going to address and overcome this challenge is developing bunkering procedures like we have for another fuels. We also have to consider the ammonia vapor handling, similar to what we have with BECS, handling the leak of ammonia during bunkering. What could happen, especially with the low temperature issues, the toxicity, etc. On containment, we got technology applied to LNG that can be used as a reference, but we need to work with the existing technology and how can we apply the IGC and the IGF codes. Also taking consideration any environmental control like inerting or dry air of the whole spaces around the ammonia tank. So we got also the technologies applies to the fuel and LNG as fuel. We have to develop those safety system, the supply system to be in place for that transfer to happen. Technology issues, there is not proven technology at marine fuel scale yet. They are, but it's mainly approved in principle. How we can address it, fuel cells, internal combustion engine. We need to demonstrate and validate that the current projects are going to be successful. And this is part of the reason in Lloyd Racer we are working on the first, what we call it, the first mover, and using the green corridors, working together with several stakeholders in order to move from document or paperwork to actions. So this is right now what we're doing. We are doing trials with different stakeholders in different areas in order to validate that this technology is going to work, not only ammonia, but also in the other alternative fuel mentioned. And we got also issued with challenge on the regulatory side, changes needs to be made to the IGC code, and of course changes needs to be made to the rules of the classification societies. And last but not least is going to be safety, which is the most critical, I think, dealing with ammonia. It's very toxic. It's affecting quite significantly health and safety if there is an issue. And the corrosivity of ammonia to the materials where we're going to have in storing this gas. So rules and regulations needs to be amended. Currently, we have restrictions to use a fuel less than 60 degrees. For example, in emergency generators, on gas carriers, we have the option to use the boil off, the burning on the ships. But for other gases, we need to make, I mean, there are amendments required to be made on the regulations and the rules of the classification societies. The reason is basically the use of cargo identified as toxic products is not permitted right now. So we need to work on that direction to make the changes in our rules and also the changes on the IMO convention. So what we have developed as classification society, we have a guidance notes for fuel system risk assessment and hazard identification on hydrogen and ammonia. That's the guidance used on most of the project we have right now, on most of the approval in principle we have in place. This is, sorry, I was not moving. Sorry, I was talking, but didn't move the slides. Sorry about that. Yeah, this is the guidance notes for the fuel system that was mentioned a few seconds ago. This is already in place in May 2021. And this is the one of the latest approval in principle we have awarded to the Alliance Shipbuilding Industry company, ASIC. So this is going to be the first Newcastle Max bulk carrier concept to be powered by ammonia. This picture was taken a couple of weeks ago. So what we're doing prior to grant this approval is we review the suitability and the risk of the design, including ammonia as one of the most promising alternative fuel for the marine energy transition. So the shipyard, the engine manufacturers, they are doing a deep research and they got a lot of expertise on this topic. And the idea of this is work together. It's not only the shipyard, but the designer, the manufacturer, the class society, the terminals, and the government in order to, to approve in principle this design and start taking some actions. I mean, we cannot keep waiting wait until the regulatory framework is ready. We need to start taking action now in order to test the technology and validate that it could work. So in this case, this is a 210,000 deadweight bulk carrier that is in principle going to be able to be powered by ammonia, of course, leading to a zero carbon shipping fuel. So as we can see, this is evidence that the industry working together to reach the goals and to reach that target of zero carbon fuel in the near future. Could be 2030, could be 2050. It depends on how the things are going to be moving. So in order to reduce that uncertainty, we have developed internally in Lloyd Register a tool called Zero Carbon Fuel Monitor. This is a free tool. If you Google Zero Carbon Fuel Monitor Lloyd Register, you will get access to the dashboard. And on that dashboard, you can play with different fuels. So you can put, so I want to know what is the status of ammonia today, for example. What is the status of green ammonia today? So it's going to give me 3 areas that as a reference point. So it's going to give me how ready we are with technology. It's going to give me also how ready we are on investment, on infrastructure. And the third parameter is going to be how ready we are as a community to accept that new alternative fuel. So this tool is quite very useful. A lot of companies and governments are using it around the world. It's being updated periodically with the new projects. So every time there is something new, every time there is a new development, there is a new progress on any of the alternative fuels, you will get a notification. I mean, you will get in the system and you will see how it's behaving. Okay. So you can make decisions. Okay, you can go now to to our dashboard, zero carbon fuel monitor, and you just select which fuel you are interested to know more about, and you will get the different point of readiness depending on technology, depending on the investment, or depending on the community readiness level. So with that, yeah, that would be the final slide of my presentation. Just want to thank University and the MTCC for this opportunity, and happy to keep cooperating and give you support in any way we can from Lloyd's, from the personal point of view. So thanks so much, and I will have a look at some of the questions already on the chat. So okay. NHT is ammonia. Yeah, okay, let's go. Can go ahead and go for the questions.
Okay, thanks a lot, Engineer Alberto. Always a part of all the activities from the MTCC. We're glad to have you again on board in today's conference. Yes, indeed, we have got some more questions from the audience. We're really glad that the participants have also interacting and leaving their questions, and the experts have been replying as they consider the questions pertinent to the conference. First question, Engineer, is what is the difference? A little bit elaborate more on the difference between a green and blue ammonia.
Okay. Green and blue is not about the color. We talk about this colorless. It is, when we talk about, you will listen green, you will listen brown ammonia, and you will listen blue ammonia. So we're talking about green ammonia. We are talking about ammonia that's manufactured in the Haber-Bosch process, but using renewable energy rather than hydrocarbons. It's not using LNG. So in this case, you will result in no CO2 emissions. Renewable electrical energy is used to separate the hydrogen from the water with electrolyzers and separate nitrogen from air with a separation unit. Blue ammonia is basically the ammonia produced by the traditional method, but having the CCS, or the carbon capture and storage part on it. So it captures some of the carbon dioxide generated during the process of productions instead of releasing that to enter to the atmosphere. And the brown ammonia is a conventional ammonia process being made over 100 years with the Haber-Bosch process without any carbon capture or any other environmental measure. That's basically the difference between the ammonia colors.
Okay, thanks for the answer. The second question, when you say that ammonia have a low flame speed, what is the meaning of that?
But that basically means the flame speed is measured using the rate of expansion of the flame front. It's kind of a combustive reaction. So the flame is propagate spherically a certain speed. So how rapid and how slow the flame travel from one point to other, that's the flame speed. In this case, ammonia have a low speed, of course, low flammability. I mean, there are some challenges if you want to burn ammonia. So it's not, let's put it that, it's not will be easy, and you will need some other tools to make the combustion properly in an engine. So that's basically what's a low flame speed.
Okay, thank you, Engineer Alberto. Always happy to have you on board, and also we invite the participants to leave, continue leaving their questions in our chat room, so they can be answered by the experts and specialists in today's conference. On behalf of the International Maritime University and the MTCC Latin America, we would like to present this certificate of recognition as a token of appreciation for your remarkable presentation in our conference. Thanks a lot. Thanks a lot for all your support to all our activities, Engineer Edilberto. We are happy to have you always with us.
Thanks to you, and hope to see you soon.
Hope. We'll continue with today's conference as we conclude with the presentation of Engineer Edilberto Peralta from Relay Register, the first block, and I will pass the word to my colleague, Erwin Vargas. Floor is yours, Erwin.
Thank you, our colleague Javier, for that excellent presentation of Mr. Edilberto. This is a good partner. Now we are going to give a short summary of this station one. For us at the MTCC Latin America, it's very important that we receive for the most important international association class society in this conference. For the MTCC and the International Maritime University, this first block has been a great value to be able to receive exclusive and update information of the latest that is being presented in the industry by our keynote speakers. From the class society on case study of ships that are operating using alternative marine fuels on ships. For us, it's a great honor to be able to bring together the most important class society in the same stage, to be able to bring together the most important information and exposing the current maritime issues, something that is not very frequently in this type of conference that happening, which is the broadcast free of charge for all participants worldwide. We thanks for each of our keynote speaker. There are excellent presentation, and we hope to continue working as a team, strengthening knowledge and skill with all Latin American region. Now, we are going to share for our students in the classroom what they are doing to see our conference. Please, we pass for the students.
Good morning, everyone. We're here in the International University of Panama Auditorium. We're with a group of cadets, and we've been listening and watching your presentations closely, and it's been very interesting.
Yes, the conference has been very interesting, and we shall remind you to keep everything under control. Thank you very much for this.
Wow, that is important, because this is what we are doing. We transfer all the knowledge for the students and also for all the industry that are liking to know about the alternative marine fuel and how the world is changed in this kind of topic. That is the reason that the MTCC Latin America and the International Maritime University of Panama are working. Thank you. But now we are going to continue with the next stage for the block number 2. Okay, now we are going to present the block number 2. Please, we can share now the presentation. Yeah. In the block number 2, the topic what we are discussing in this block is about the development of emerging technology applied to the alternative fuels and the training and competence required. In this kind of topic, now we are going to present our next keynote speaker. Les Gingell. This is our next speaker. Mr. Les Gingell started his career at ICO, Lycoming, manufacturer of a small gas turbine, as manager of Marine Gas Turbine Service Department, responsible for the support of esoteric yachts and ferries, the numerous advantage military and government application. In 1994, Mr. Les joined to the MAN BMW as Director of Business Development and subsequently became to the Vice President of Sales for Latin America. Sorry. In that time, he has been immediately involved in many of the world's most advanced propulsion systems and at the leading edge of the use of alternative fuels for marine propulsion. MAN BMW and the main engine have been the exclusive choice of two-stroke main engine for Jones Act ocean-going vessel for over 30 years. And for the past 10 years, all engine choice has been MAN and BMW alternative fuel engine. Now, we are going to present the topic of Mr. Gengel, internal combustion engine and their use with alternative fuels. Hello, Mr. Gengel. You can hear me?
I can hear you. Good afternoon.
Thank you. The floor is yours, Mr. Gengel. I'm so happy on all.
I have to say, you have a very professional voice. You sound like you could be on the radio all the time. So
yeah,
very good.
Thank you.
I thank you very much for the opportunity to speak with you all today. I'm not really with all those big engines behind me. I wish I was, but I'm not. But I really enjoy what I do and would like, hopefully, I just had this all queued up too. Share my presentation with you. Okay, please. Here we go. All right, we're all good?
Yes, sir, all good.
Very good, very good, very good. Thank you. I put this face page to show you one thing about this engine that's quite interesting to me is it's only those parts that you see that are yellow that are affected with alternate fuels from a basic diesel engine. So it's not a huge amount of difference from our basic diesel to use these alternate fuels. And next slide. Okay, there we go. I put this up here because sometimes it's not fully appreciated how far we have gone in terms of emission reduction. Less than 20 years ago, closer to 15, you could see a ship. Now, this is a good sized ship that's going 60, that uses 60 megawatts and goes 24 knots. Small container ship compared to today, but still, it was going fairly quick. And you see on the right side, the right bubble, the things that were coming out of that. 86 tons of CO2, 14 tons of SO2, and 30 tons of NOx on a daily basis per ship. And this was when we were using heavy fuel oil back in the day. So compared to where we are today, we have made massive improvements in a very short period of time. And this slide everybody got tired of maybe 10 years ago, but this shows you where we're going, where we were, and you see it was virtually unregulated in 2008, your SOx and NOx. And here we are today in 2022, and your sulfur content is extremely low that's allowed, or you need a scrubber. And in addition with the NOx, we have very stringent numbers we have to meet that we do in various ways. With SOx, you have a choice with MGO, marine gas oil, or a scrubber, or using dual fuel. And you may be asking, why am I talking about alternate fuels and I'm on NOx and SOx? Well, this is the reason why. Because these alternate fuels are what are going to affect, particularly the SOx. And SOx in, SOx out. It's not something you can mitigate. And then for NOx, we're good with NOx. We have the Tier 3 technologies, the selective catalytic reactor and the exhaust gas recirculation. and they work as required to meet the latest requirements. And with big engines, Tier 3 is the latest and to date the only future requirement. It doubtful it's going to go past that. And one of the reasons, because the engines are so efficient at 53%, that if you start affecting them badly, then you're going to lose that, and your CO2 will get up, as I'm sure you all know. When you fix one thing, another thing happens. So we go with that. And in fact, we do have as well with this what we call EGR, exhaust gas recirculation. We have another methodology where we use that even out of the Tier 3 area. And we retune the engine with our electronic engines, retune it so that it is absolute max efficiency, and then use the EGR, a small amount of recirculation, to bring it into Tier 2 compliance. And it's pretty substantial even with a small, big engine. We've seen 4 to 5 grams per kilowatt hour fuel consumption decrease, which, when you're talking about the amount these consume, is very impressive. These are the two methodologies. Essentially, on your left, you see the SCR, or selective catalytic reactor. And what happens is you put in urea into that dosing, which is on the top, and it goes into that big thing on the right, and that's the catalyst. And very effective, but also quite expensive if you're going to be in the ECA on a regular basis because of the urea requirement. On the right, you see your exhaust gas recirculation, which is that thing hanging off the side of the engine. It's nice because it's not large. It's much more user friendly in terms of capex. I'm sorry, OPEX, much more friendly for OPEX, but higher with CAPEX. So it's a decision, it's a fairly simple math exercise to see how much time you're going to be in the ECA and how much the urea will cost you, and then decide which methodology to take. Right now, it's about 2 to 1 for SCR, but that reason is because it's cheaper. The shipyards or the engine builders have their own SCRs, so they promote that heavily. They charge quite a bit more for an exhaust gas recirculation because they have to buy it from us. So being 2 to 1 is still, we think, quite impressive. But the customers look at it, and the OPEX is so much higher, it makes it a no-brainer. You can see here in both of these, let's take the one on the right, the high pressure SCR, the engine is on the right and the SCR is on the left, almost the same size as the engine. So you can see it's not insubstantial when you're trying to install one of these on your ship. You know, everything is about cargo capacity. And the more your engine and its associated components are, the less capacity you've got. And in particular with these fuels, as we've already seen, from MGO, you're talking 2, 3, 4 times the size required of the tanks. And that's on a good day. Then you have the very severe requirements for refrigeration. So, you know, just adds. Here's what tells you, I won't go through all this, but it shows you more or less we're about 2 to 1 SCR to EGR. And interesting things as far as which ships have more or less of a take rate. Again, I won't go through that, but I just found it very interesting. One thing I would highly recommend for anybody who is interested in emissions is this, what's called Emission Project Guide. The bottom line there shows you where to go to on the website. It is completely available with no passwords, nothing required, and it does a wonderful job of going through all the different emission opportunities, the cost, the effects. You can calculate specific things, especially with students here. It's a wonderful way to get a good idea of what's going on with emissions. Also, of great interest should be to everyone is what this is called CAS, Computerized Engine Application System. Once again, completely available on our website, does not require any passwords or anything else. I've put the address there, and you can choose an engine type, size. You can choose the IMO regulation, the fuel injection type, meaning diesel, methane, ethane, propane, methanol, and the number of cylinders and so on. And when you go through this, it'll ask you for propellers and turbochargers and all kinds of additional equipment. But anyways, you can default to the norm, and you'll get a 19-page printout of all the aspects of that engine, the emissions amounts, all the requirements for ancillary equipment, and so on. And often I get questions from engine from customers, be they consultants or ship customers, and usually just refer them to this, and they can make all their own ideas about which one they want to go with, what the properties of the fuel, how it will affect them, and so on. Wonderful source of information. Interestingly, with this new EEXI and the CII, which I'm sure you're aware of, the Carbon Intensity Index, we already have two ships, and I mentioned there it's Jones Act, which are ships that work within the contiguous U.S., that are getting their engines replaced with LNG engines. One of them is a 41-year-old Ro-Ro, and that is having the steam turbine taken out and the MEGI, we call it, gas-injected engine, put in. And the other one is a barely 20-year-old ship that has a mechanical engine and will again be going to a dual-fuel LNG engine. Okay, so that was sort of a preface to get here. And the only thing you'll note here, well, maybe you'll note more than that, but the primary thing is there isn't ammonia in here yet. I'm still waiting for that slide. But anyways, we've got to add ammonia. We will have the ammonia engine ready for delivery in 2024. So if you want to be the first on your block to have the ammonia engine, just let me know, and we'd be pleased to get you set up for that. In addition, you can see here that we haven't just started this yesterday. In fact, 2013 was the first sale of the LNG tanker and LNG engine. That was in December of 2013. I remember it well when they called me. And we had been promoting LNG engines for a decade prior to that. And you know, primarily until recently, the fuel types decided for these ships was based upon what they were hauling. You know, LNG tankers taking LNG, methanol tankers, methanol, and so on. But the first one that was sold was the one to Tote Maritime, and that was a container ship. So, okay, so much for that theory. But and we're seeing now many container ships. It was announced late last year that Maersk is taking 12 16,000 TEU container ships, so large container ships that will operate on methanol. And we expect very shortly to be an announcement of quite a few more from another customer that will be methanol. So here's the different gas types: LNG, ethane, methanol, LPG. And some of these things have already been gone through: density and volume, for instance. You see their volume, methanol is the worst. It takes a lot of volume. That's the bad news. The good news is that it can go into the existing tanks. So, okay, you will need more at the end of the day, an additional tank. I know one customer is looking at putting it in a double bottom, and that could be very interesting. And then you note the line below that, fuel gas supply system. I'm sorry, fuel gas supply system is FGSS. You see that it's 1/5 of what LNG is. So, customers are very sensitive to price. When they go and think about a ship, it usually depends on what they think they can get for a charter. So $2 million bogey just on the fuel gas supply system can make a decision. And by the way, methanol also can meet tier 3 without after treatment by using some water emulsification. So adding a little water, you can get to tier 3 NOx with methanol. Very, very good fuel. Very good fuel. Fuel price, I've seen that asked already. Price is something that you need to ask a supplier, and that they will always tell you, oh yes, it's cheap, until you say, okay, here, I'll sign, tell me. Then it's not so cheap. So we go from there. So there's a lot of information here. Mainly what you want to look at is the right side, because what we're saying here is to reduce CO2, which of course is a function of the amount of fuel used, and greenhouse gas emission. Greenhouse gas is going to start to get a lot more attention shortly. So these are the ways you can do it. And we start from top to bottom as machinery efficiency. And we have very little capability to get much better at this point. PTO, which is power takeoff, it's a very popular thing to talk about, and the take rate is very low. Twin screw, and of course that means twin engine and twin propellers. We like that because we sell those, but it doubles your price for your propulsion system. LNG, speed reduction, carbon-free fuels. And that's where we see that we're going to be going very shortly. To give you an idea here, these are 3 of the same graphs, but you can see one says 2018, the other one 2020, and the other one 2021. The first one in 18, we expected about 25% of our fleet would be dual fuel, ordering at least, by 2028. And in 2020, we expected 50%. 2021, we looked at greater than 60%. And I don't have a 2022 chart yet, but I suspect we're almost up to 70% of alternate fueled engines being ordered. I won't go through this except to offer it for your information. But what it says is we have 726 engines that are on order or delivered, and 218 in service, and many millions of hours already accrued. This is a really, really excellent chart. I take no pride of authorship, but it tells you at the end of the day what is going to happen here. And if you go from marine gas oil, I would go to the 4th column, which is required tank volume. It's very easy then to see, okay, if we say MGO was 1, with down below it liquefied natural gas 1.6, and then you start going down to, for instance, methanol 2.2. Okay, so it's twice the amount of MGO. Then ammonia is actually quite a bit higher, and then hydrogen is 4 point plus with a minus 253 degrees C requirement. For a real ship, I don't see hydrogen. I see today methanol and tomorrow ammonia. And this is something we did with DNV, which you see going from today, and you can start to see in 2040 and so on, and later you can see the uptake of ammonia. I think it's going to happen. I think you can move that over 5 years or more to where it's almost completely ammonia by 2045. I think you can move that at least 5, if not 10 years to the left. The interest level is huge. Like I said, 2024, we deliver our first one, and we have many customers who are very interested in that. And some questions have come up already, and I've wanted to deal with it a little bit. I said right up front that we were talking about diesel engines. And for those of you who know the difference between a diesel and an Otto cycle, a diesel is compression ignition. An Otto cycle is essentially what you get with a car engine modified. And diesel cycle is for using alternate fuels and for lack of methane slip and so ever is the only answer. And we will see this as time goes on. We know this. We also now have a auto cycle engine that we developed just for LNG tankers. It's gotten a good take rate, but I don't like it. So this is the important thing here. Along the top, you see the fuel types. You see MC, which was our old mechanical engine, and MEB, which was another quasi mechanical engine. And you see there the green boxes that say design. And then below that, there's just white boxes. And as you go to the right, MEC, MEGA, we'll skip MEGA, but the other ones, you see design and you see retrofit. So if you have an MEC engine, which is about the last 15 years, it's designed for fuel oil, HFO, and biofuels, but it can be retrofit. And we have done many of these already to LNG, ethane, methanol, LPG, and eventually ammonia. And same with the other engines. They're designed for whatever their particular type is. MEGIE, for instance, is ethane, but it can be retrofit to LNG, methanol, LPG, or ammonia. So we like to call these future-proof. So an engine today can be retrofit to an engine that we see will be using the fuel of the future, being ammonia, for some period of time. And that is what I had for you. So I hope I wasn't too quick, and thank you very much.
Wow, thank you. Thank you a lot, Mr. Lesgingel. Excellent presentation.
My pleasure.
Wow, we are now so lucky that listening you about your explanation about the different information of a man energy solution that are doing in the industry, because many of the people are want to know, if I have a ships, if I am owner or ship owner, and I have to change my engine because we are not compliant with the new regulation like EEI and EXI. What kind of engine we can make retrofit? If you explain to us, can you explain to us about that question?
Yeah. In many cases, you can retune the engine. Retuning the engine means that you change it so that it doesn't put out as much power. With a mechanical engine, that means usually just strictly a mechanical stop on the fuel pumps or fuel supply, and a electronic engine, you can retune it and then have an override button. So that's one way for an older engine. For the newer ME engines, then you can retrofit to the other fuels. As I mentioned, we have two currently going on, one a 41-year-old ship and another one one from 2020. So it's doable. Most don't like to actually have to literally replace an engine, but those are the solutions you have.
Wow, thank you, there, Les, and we are continue to say we are very so happy for listening what your explanation and also what man are developed in the industry, because man is one of the best engine. I was working with man, and that's a very good engine. And now, on behalf of the MTCC Latin America, we are honored to present of you a virtual certificate of recognition of you as keynote speaker at the International Virtual Conference, Alternative Marine Fuels and the Challenge for Latin America. Thank you a lot, Lesgingel, and we are continue working together with you. Thank you a lot. We are continue working together. I hope to see you in the future.
Yeah, come on up. And by the way, if anybody has additional questions, my email address is available. You're completely welcome to ask more. Very good. Thank you again. Bye-bye.
Thank you. Now we are continue with the next presentation. For us, it is an honor for me to present the next international speaker at the conference of Alternative Marine Fuels and the Challenge for Latin America, Professor Dr. Eike Olscher, who is the Director of Research Nippon Foundation Professional Chair in Marine Technology and Innovation from the World Maritime University. Professor Dr. Olsher is a naval architect and marine engineer, holding the position of Nippon Foundation Professional Chair in the Marine Technology and Innovation and the World Maritime University. He is currently the Director of Research of World Maritime University, as well as the head of Maritime Energy Management Specialization. He served as the editor-in-chief of World Maritime University Journal of Marine Affairs and book series between February 17 and February 19. Prior to joining the World Maritime University, he worked at Newcastle University and University of Strathclyde in Scotland and Istanbul Technical University on Turkey, within the field of naval architect and marine engineer. For many years, he has conducted research independently, jointly, and collaborated with other research, academic, and students all over the world, in particular from the Europe and Asia. Dr. Olsher has involved in numerous EU and funded FP5, FP6, and FP7, Horizon 2020 project and IMO project, as well as IAMU, International Association Maritime University, and regional project in Scandinavia. Now, we are going to present the next topic for Mr. Dr. Olsher, addressing maritime decarbonization through education and capacity building in maritime energy management, a success history of the World Maritime University. Hello, Dr. Olsher. You can hear us? You have the floor already now for you.
Yes, Mr. Vargas, do you hear me?
Yes, sir. We are hearing you.
Fantastic.
Very good and properly.
Yes. Let me try to share first of all. Okay. Mr. Javier, can you please share my presentation? Mr. Javier?
Yeah, we are going to share with you.
Yes. So in the meantime, let me start. Mr. Vargas, thank you very much for the invitation and all the MTCC colleagues. This time we are doing online, of course, due to the pandemic. But I'm proud to say that in 2019, March or February, I was in Panama for the inauguration of the MTCC Latin America. Some of the participants might remember. And of course, I look forward to visiting Panama in the months or in the years to come. So I'm just waiting for my presentation. I don't know, Microsoft Teams is not working. Working not properly on my side. Sorry for this. I apologize.
Don't worry, Dr. Scholl. Now we are trying to present to you your presentation. Give to us some little minutes and we are sharing with you. Don't worry, sure. And with the audience.
Sure, of course. And also I can continue while you are sharing. And when Mr. Vargas approached me and for this workshop and the event, I basically decided to provide a little bit different perspective rather than focusing on alternative fuels, because as you can see, previous participants and touch upon all these things. Yes, fantastic. Thank you very much, Mr. Javier.
Thank you, Dr. Rocha. Now the floor is yours.
Fantastic. So previous speakers already touched upon alternative fuels, LNG, hydrogen, ammonia, with all these technical details, safety concerns, environmental concerns, and so on and so forth. So that's why I do my best today to be able to provide a different perspective. And what is this perspective? In a way that what is the role of education and capacity building in this buzzword we are dealing with today is maritime decarbonization, and also what we do at the World Maritime University, WMU, and in order to respond to this. Maritime industry is probably still the first slide, Mr. Javier. First slide, please. Still on, yeah. The maritime industry is probably standing at the start of one of its greatest technological challenges as it prepares to transition to a zero and low emission industry. through the adoption of technological innovation. And some of the examples and the snapshots we already saw in the previous presentations. And it is a necessary step since it has been proven that human-made emission of greenhouse gases has begun to change our climate and is already affecting our lives in a tangible manner. Further, the climate change 21st century has also proven that global disruptions such as financial crisis, global pandemics, and international conflicts, which we are facing as of today, have affected international shipping and threatened societies more than once in this century. Strengthening our ability to mitigate these disruptions and building resilience towards them are amongst the most important challenges of this century. Looking at climate action first, we are witnessing the impact of the IMO initial GHG strategy, helping to accelerate the global momentum on greenhouse mitigation within the shipping industry. International cooperation for the mitigation of GHG remains a challenge and is a crucial element for decarbonizing the industry globally. So in this respect, fostering maritime innovation and innovation deployment requires maritime leaders with the right knowledge and skills, thereby the education and capacity building. So that's why this introduction was all about the, let's say, the justification and motivation behind my keynote speech today. Second slide, please, Mr. Javier. Yep. Now, this slide, now Mr. Vargas already highlighted and connected to some students. Some students undergraduate level are also watching us. And this slide maybe is really good for them, especially to have the full picture behind the decarbonization. What we see in this slide, there are 6 drivers for us to become energy cautious, for us to become more environmentally friendly, and for us to become more energy efficient. And these are the 6 drivers. And focus is air pollution, of course, when it comes to decarbonization. And air pollution is very much linked to the energy production and its consumption in the maritime industry, including ships. Although IMO jurisdiction is on the ship side, on international shipping, but also the supply chain and also the stakeholders, important stakeholders like port and the shipyards, was also part of the big picture. So as I highlighted, what you see in this slide are the drivers for the maritime community to manage the production and consumption of energy in a better way on board ships. Those above mentioned legislative and non-legislative motivational factors or drivers are the basis for energy management or energy efficiency. And very briefly, the first one is what we do is not good, right? When we burn the fossil fuel, we definitely produce the spectrum of air pollutants and the GHG. We have solution for the air pollutants like the sulfur oxide derivatives and the nitrogen oxide derivatives with a good engine, with a good fuel. But the problem is that we don't have a silver bullet technology to remove the GHG from our maritime operations. The second driver is, do we have any internationally binding regulation? Yes, there is MARPOL Annex 6 and Chapter 4. And also Paris Agreement, a kind of a turning point when it comes to regulatory landscape, is not directly linked to international shipping, but is indirectly linked to maritime industry. Of course, IMO responded to Paris Agreement in the form of a GHG strategy in 2018. And third driver is volatile fuel price. Fluctuating fuel oil price character can be also handled and be settled also through a good energy management practices. The fourth item is world population. Actually, it is the main driver for also all the other drivers I mentioned and I will be mentioning later on, which is an important driver, which is definitely an important dominant driver for the increased energy demand and prices, because more people means more needs. Energy resources scarcity and energy security, what we consume today in terms of fossil fuel trio, within 70 or 100 years of time, we'll be able to run out of this. so that we have to use our existing resources in an efficient way. Energy security is very much linked to what we see today, especially the disputes and the conflicts that's happening in the certain parts of the region in the world. So that's why energy security, which is very much linked to the supply and demand relation of the energy sources, and also another important driver. Last but not the least, United Nations 2030 agenda for the human being and the civilization to grow in a sustainable way, and in particular 7, clean energy for all, and the SDG 13, climate action in particular. And these are the SDGs, again, are the important SDGs, Sustainable Development Goals, for us to become more environmentally friendly, more energy cautious, or more energy efficient. So all these drivers I mentioned them very briefly have led the maritime industry to become and more energy efficient in the way ships are designed, as well as in the way seagoing vessels are operated and maintained, producing energy for maritime transport and managing its consumption in an optimal way is simply called maritime energy management. The next slide, please. And when it comes to maritime decarbonization, when it comes to, and we call it, or we treat maritime decarbonization under the umbrella of maritime energy management. And the way we see in terms of the way forward is definitely we need a holistic approach. So that holistic approach has to be there, or a holistic perspective is a necessity to understand and overcome the decarbonization challenge. And our approach at WMU, and also the approach we always promote and propose whenever basically come to this kind of occasion, is therefore a holistic and not a single dimensional approach, in such a way that we do not only focus on one aspect like human element or economics or technology. Rather, it is a multifaceted from technology to human element to regulation to economics. We call them key thematic areas. It is important to appreciate the things also in a life cycle perspective when it comes to assessing the impact. Maybe one good example, today we talk about ammonia, and today we talk about carbon capture, storage, and hydrogen. So these are all technology is there, but that technology might be expensive. So economic aspect is a very important element and the dimension. So any technology which will be decarbonization, the international shipping has to be commercially viable. And another element, okay, technology is there, but who will design them? Who will implement them? Who will operate them, right? Who will develop the policies with regards to safety aspect, with regards to environmental impact aspect of all these technologies, which will be definitely settled and handled by the human beings, future maritime leaders and future engineers. So that's why education and capacity building is also another important dimension. One more time, holistic approach is very important, and the items in this holistic approach are equally important. Of course, some more important than the others, let's say, compared to the, for example, technology and innovation is definitely one of the most important item in this holistic view. But of course, we cannot ignore the others as well. So the next slide, please, Mr. Javier. Now, what you see in this slide, and definitely the IMO themes for year 2020, year 2021, and year 2022. As you can see, 2 out of these 3 themes are very much linked to sustainability and decarbonization. So it's not a coincidence that IMO has chosen new technologies for greener shipping as maritime theme of 2022. And sustainable shipping for a sustainable planet has been selected by the IMO as the World Maritime theme for 2020. And today, international shipping is, of course, indispensable to the world, but is not sustainable due to its negative externalities. Marine litter, sewage, and the ballast water, chemicals, fouling related. So most of them are regulated by IMO, and some are at the development stage in terms of, or in the form of, international binding regulation. So amongst these, air pollution resulting from international shipping got a huge attention both in the maritime industry and the society due to its severe consequences such as human health problems and the climate change. Now the question is, how do we mitigate this, or how do we remove air pollution from the maritime operations like running a ship or performing a port or shipyard activities? And next slide, please. So now, after this a little bit long background, we came to the level of the role of higher education or education and capacity building in the maritime decarbonization. So maritime industry needs or the needs of the maritime industry are rapidly shifting towards green and ecological operation of ships and ports. Therefore, new types of education and research are in demand as of today. How do we respond to those needs as an academic institution? So WMU, World Maritime University, use a 5P approach to sustainable development and in particular to maritime decarbonization. As you can see, people, the planet, prosperity, partnership, and the peace. So these are the 5P. The integrated and balanced action on all 5 Ps is important for effective capacity building. If we achieve this, we might be able to reach the target of zero/low carbon and energy efficient maritime industry. Next slide, please. So the initiative to develop the maritime energy management stream at WMU arose from or resulted from the direct and urgent need to provide education for the reduction of GHG emissions and for the development of sustainable forms of energy in the maritime field. More specifically, MEM is the response of our university to the needs of the maritime community and the drivers mentioned in one of the previous slides. Therefore, at WMU, MEM is a new stream and the direction and a journey which has many elements running in harmony, as we call it as a postgraduate pathway. And in this pathway, education and capacity building side, we have a master program delivered in Malmö and the postgraduate diploma program delivered online through distance learning and professional development courses. Of course, this education or this main pillar on education and capacity building will be definitely or has to be supported by research, including our PhD program. So that is our postgraduate pathway to educate future maritime leaders and to build capacity to achieve maritime decarbonization or to achieve a zero/low carbon and energy efficient international shipping. And the next slide, please. So fostering maritime innovation and innovation deployment requires maritime leaders with the right knowledge and the skills. And characteristics of a future maritime leader, they have to be the one who will be implementing the policies, right? Or who will be implementing the technologies, who will be integrating the technologies on board the ships. And they are the decision makers when it comes to select the best amongst the finite number of the alternatives, like global sulfur limit compliance. Either it will be a low sulfur fuel or abatement technology or LNG. So they are the one who will be making the decision or optimal decisions, or they are the one risk analyst. So in this respect, and the WMU achieve to be able to provide, to be able to educate future maritime leaders in the 6 years since we launched the program at the WMU site. As you can see, we graduated 62 MSc alumni from our MEM program, and half of them are from Africa. So in this respect, we are very proud of building the capacity in the developing countries of the Africa continent. And more than 40 graduates in our postgraduate diploma through distance learning. And those graduates, some of them are coming from least developed countries, and also in particular, small island developing states. They are the states which will be affected the most by the climate change. So stakeholder spectrum is maritime administrations, ports, classification societies, shipping companies, shipyards, academic institutions, and so on and so forth. We have already graduates alumni working for IMO, but also when it comes to MEPC plenary sessions, we have a lot WMU alumni in the form of country delegations. So next slide, please. As I highlighted in one of my previous slide, education and capacity building or educational products of WMU is supported heavily by the research we do. And of course, spectrum is wide, but these are just the snapshots. We do research funded by the EU, European Union. And interestingly, at the moment, we have a flagship projects dealing with decarbonization of international shipping, but with a focus on ammonia and hydrogen. At the WMU side, we look into the life cycle analysis of ammonia and hydrogen. We have also another project, Swedish Traffic Administration Agency. We look into emission trading system at the EU side and its impact on the international shipping. Of course, we have PhD students and the wide spectrum of topics from energy modeling on board the ships to shipyard energy management to market-based measures and so on and so forth. And especially for the students attending and participating in this conference, I'm providing the link. We have master dissertation publicly available, so you are more than welcome to check the link and then benefit from it. Of course, we are an IMO university. We are heavily involved with the IMO activities. Last year, we were part of a project called Comprehensive Impact Assessment of the Short-Term Measures. And our basic work submitted to MEPC 76 last June. And at the moment, we have an ongoing project. We look into safety and energy efficiency profiles of domestic passenger ferries in the Philippines. We do workshops, the one you see just at the right side of the slide. And also, more importantly, we produce our results, we disseminate our results, and we basically link our research results to our curriculum so that the students at our university are basically having the latest when it comes to alternative fuel like ammonia, hydrogen, or when it comes to other aspects of the contemporary issues. So that's why our program is very much updated by the latest research we do. Next slide, please. And in addition to our educational products, we are also working with industry partners to build capacity all over the world. I will just give one example. Last year, during the pandemic, we basically developed or conducted 3 workshops all over the world, one in Myanmar, one in Kenya, and one in the Caribbean, in close collaboration with the Danish Maritime Authority. We conducted 3 workshops on global sulfur limit. What we did basically, we brought experts from the Scandinavia. The experts are very much familiar with the global sulfur limit because this region is already sulfur emission control area has been many years. So that's why they share their experience with the colleagues coming from the developing countries. It was a fantastic platform and it was a fantastic capacity building opportunity. And in order to not to consume my time much, our motto is very simple. We build capacity so that nobody is left behind. And the challenge we are facing is a global challenge. So that's why we have to collaborate. And the global cooperation is very crucial. In addition to the technologies we develop, and in addition to all the other achievements we do. Next slide, please. The way forward, this is my last slide. Definitely, the way forward is we need a holistic approach. It's not only the technology, but also the other key thematic areas. And also we have to find the right combination of the key thematic areas. For example, the set of options, the technical and operational measures and the solution working for a container ship, so that combination cannot work for bulk carriers. So that's why it's very important to understand the right combination of thematic pillars and the measures for shipping companies, for ships, for states, for the maritime administration is an important element for the right way forward. And of course, the umbrella at the very high level, definitely we need a paradigm shift. We need a mindset change. Why? Because we are already 7 billion. So, and the world population is increased exponentially. So that's why we will be definitely having more needs in the near future. So more needs means more world trade, more seaborne transportation. And today also we started to make travels because there is a cheap flight ticket. So we do this basically travel activity because the flight ticket is cheap. So that's why we need a paradigm shift. We need a mindset change and to help decarbonization. Otherwise, pressure will be always on the IMO, will be always on the maritime stakeholders, but that pressure is already too high. So that we need to help decreasing this pressure in the form of a paradigm shift in our mindset changes. Global cooperation is important, I already highlighted. Life cycle perspective within energy and the maritime supply chain is an important element. Maybe the best example of the fuel cell. The fuel cell, if the fuel cell is fueled by the hydrogen, hydrogen is already requiring an energy intensive production. So that's why we have the fuel cell, is environmentally friendly. However, when we look into the life cycle perspective and the whole supply chain, it's not that environmentally friendly at all. So last but not the least, we have technologies today. So they might not be mature, they might be expensive, but technology is already available there. But the important thing is we need to also consider investing on future maritime leaders. So WMU model and its translation into the regional local context might be also another good way forward. The last but not the least, while we are keeping all these things, we have to always keep in mind two things. To empower women in the maritime industry while building resilience for the disruptions such as COVID-19. So next slide, please, Mr. Javier. So thank you very much and gracias. Thank you. Appreciate.
Thank you for you, Dr. Rocher. That's very, very impressive that you present to us about we have to invest in the new leader of the maritime industry. Now we have the season of opening, the season of Q&A, and we receive a lot of questions here, but we're going to present the first question for you, Dr. Rocher. You present the World Maritime University as a success history in your presentation. Can you please elaborate more on the educational product of World Maritime to help achieve zero low carbon energy efficient maritime industry?
Sure. Thank you very much, Mr. Vargas. Thank you very much for this question to the participant. Already elaborated a little bit, but without taking too much of time. And IMO established World Maritime University 39 years ago to build capacity, especially for the maritime professionals coming from developing countries. So with that mandate, what we did basically, we have 7 specialization, or we call it 7 departments. And in these 7 departments, we educate people, we educate future maritime leaders. The one I'm leading, the Maritime Energy Management, and we have a master program. You have to come to Malmö, 14 months program, and then we have the scholarships supported by the donors of the university. And if you are not able to come to Malmö for 14 months, and if you are a, let's say, busy maritime professional, we have also a distance learning program, which is taking 12 months. So, and on top of this, of course, due to the research activities we are heavily involved, we might have also some vacancies. You have to check our website, and if you are more than welcome, as long as you have the let's say necessary qualification and the skills to apply. We also do a lot with the IMO, so it might be the case we might meet at some part of the world and for a capacity building activity or a kind of a visit we are doing to a maritime administration for audit purposes and so on and so forth. So definitely go to our website, please, and to be able to explore more. And also that you can directly write to me for any other further information you might be looking for. Thank you.
Thank you. Thank you a lot, Dr. Rocher. We are so happy because we are continuing improving and working together with the World Maritime University. And this is the reason that we are here and you are here, sit with us in this conference. On behalf of the MTCC Latin America and the International Maritime University, we are present a virtual certificate of recognition as a keynote speaker in the International Virtual Conference, Alternative Marine Fuels and the Challenge for Latin America. Thank you, Dr. Olcher. Thank you a lot. We say we are continue working. That's what we are told to everybody. And I hope to see you in the future because this is that good collaboration together. Thank you a lot. Thank you. We are now, would like to everybody of the MTCC Latin America to switch off the camera. We want to tell to the participant that in the afternoon, we are now to present the video presentation for all the stakeholders, what are doing in the change the world of the transition of the carbonization. Also, we want to explain to everybody that after finish the speaker, we want to share the link of the evaluation form. Immediately when you receive the link, you have to receive your certificate of participation. This is what the MTCC Latin America and the International Maritime University are doing for all the participants. Everybody have the certificate of participation in this excellent conference. That's the reason that we are to improve in the cooperation and working together. Now this is the period of we are finished. I'm going to bring lunchtime. Thank you. I hope to see you in 1300. Please, we'll come back soon. A las 13:00 regresaremos nuevamente con la conferencia. En esta conferencia, los temas que vendrán son muy importantes para cada uno de nosotros. Creo que es importante que mencionemos que después, determinado con nuestros participantes, y antes de empezar el summary o el resumen de la conferencia, pasaremos un enlace. En ese enlace va a ser de evaluación de la conferencia, donde inmediatamente ustedes llenen como participantes el enlace, recibirán un certificado de participación por parte de la Universidad Marítima Internacional de Panamá y el MTCC Latin America. Estas presentaciones que hemos llevado a cabo nos indican el trabajo en conjunto que estamos desarrollando en conjunto con la industria, con todos nuestros aliados estratégicos. Y si ven ahora mismo, estamos presentando información de última mano que ha sido compartida con ustedes. Esperemos que la siguiente parte de la conferencia, en nuestros bloques a continuación, sean de excelente agrado para cada uno de ustedes. Muchas gracias y nos vemos dentro de un momento. Welcome to the MTCC Latin America. The MTCC Latin America and the International Maritime University of Panama present the Pilot Project 1, Uptake of Ship Energy Efficient Technologies and Operation. This project aims at utilizing the IMO existing regulations on ship energy efficient technology and operation as a starting point for examining the varied and constraints faced by regional ship owner and operator when implementing or planning such provision and moving toward low carbon shipping.
The general objective of this pilot project is to strengthen the uptake of energy efficient technologies and operations by better understanding of the barriers and constraints experienced by relevant stakeholders within Latin America region. Also by making recommendations to policymakers and competent administrations on how to tackle these issues and by disseminating the outcomes of this pilot project. This pilot project 1 has been developed taking into consideration the fundamental role of all the stakeholders acting actively in the implementation of strategies for the uptake of ship energy efficiency technologies and operations. Among the stakeholders, we can mention maritime administrations, government institutions, shipyards, maritime training centers, ship owners, ship operators, ship designers, marine diesel and engine manufacturers, classification societies, marine fuel suppliers, port authorities, port operators, national policymakers, and other interested groups and maritime professionals.
This report brings the information obtained to the attention of almost 300 participants and the responsible authority of 17 Latin American countries that have been engaged and trained through direct interaction with MTCC.
Welcome to the MTCC Latin America. The MTCC Latin America and the International Maritime University of Panama present the Pilot Project 1, Uptake of Ship Energy Efficient Technologies and Operation. This project aims at utilizing the IMO existing regulations on ship energy efficient technology and operation as a starting point for examining the varied and constraints faced by regional ship owner and operator when implementing or planning such provision and moving toward low carbon shipping.
The general objective of this pilot project is to strengthen the uptake of energy-efficient technologies and operations by better understanding of the barriers and constraints experienced by relevant stakeholders within Latin America region. Also, by making recommendations to policymakers and competent administrations on how to tackle these issues, and by disseminating the outcomes of this pilot project. This pilot project 1 has been developed taking into consideration the fundamental role of all the stakeholders acting actively in the implementation of strategies for the uptake of ship energy efficiency technologies and operations. Among the stakeholders, we can mention maritime administrations, government institutions, shipyards, maritime training centers, ship owners, ship operators, ship designers, marine diesel and engine manufacturers, classification societies, marine fuel suppliers, port authorities, port operators, national policymakers, and other interested groups and maritime professionals.
This report brings the information obtained to the attention of almost 300 participants and the responsible authority of 17 Latin American countries that have been engaged and trained through direct interaction with MTCC Latin America, as well as through the regional and national workshops organized by MTCC Latin America across the participant countries. The pilot project 1 has delivered 5 capacity building workshops across the participant countries, providing training on IMO's energy efficiency regulation, energy efficient ship operation, port state control and enforcement, as well as how to implement measures to improve efficiency on shipping, ship energy efficiency management, and a full data collection methodology in accordance with MARPOL Annex 6.
6 maritime administrations in Latin America were reviewed. 3 of them already adopted the MARPOL Annex 6. Another 3 countries were in the way to adopting the MARPOL Annex 6.
With the execution of this pilot project, we obtained relevant information on the common barriers and opportunities from developing countries within Latin America.
Barriers: lack of training and technical expertise, the uncertainty of experimental new technologies and the high cost for its implementation, absence of incentives for adopting or implementing energy efficiency measures, lack of environmental awareness, state capacity, and inadequate infrastructure.
Opportunities: training and raising of technical environmental awareness at all levels, partnership and strategic alliance, research and innovation, technical regional cooperation, implementation of green policies.
The decisions that we take today will certainly affect our future in all aspects.
It is necessary to take the right action now. MTCC Latin America, working together
to promote an efficient and
sustainable shipping. This pilot project was funded by the European Union and implemented by the International Maritime Organization through the global MTCC network. Welcome to the MTCC Latin America. The MTCC Latin America and the International Maritime University of Panama present the Pilot Project 2, Fuel Oil Consumption Data Collection and Reporting. Pilot Project 2 is about the fuel oil consumption data collection and reporting. Maritime administration such as Panama, Peru, and Chile, and shipping companies such as Carnival, Mediterranean Shipping Company, Ultranav, Humboldt, and Transgases participated and provided ship operational data to verify the process of how the Maritime Administration collect the data, reported, and then to share that information to the IMO.
The purpose of this pilot project 2 is to make use and perform a detailed analysis of the fuel oil consumption data collected by the MTCC Latin America with a scope of providing useful insights on lessons learned. The real value for enhanced decision-making lies within the disaggregated data. Calculations of maritime operations with the automatic identification system data monitoring facilitate the verification process from the flag administrations. Slow steaming and just-in-time arrival information requires sufficient transparency between ship and shore. By effectively using existing technology, the overall process could be enhanced and facilitated in an effective way. Automatic identification system and NUN reports can be utilized to ensure effective regulatory implementation and fast enforcement. Experience gained through Pilot Project 2 enable us to support all parties involved in the regulatory implementation process. Regional technical cooperation is crucial for effective regulatory implementation through automation, digitalization, and optimization to offer great value to all parties involved. The decisions that we take today will certainly affect our future in all aspects.
It is necessary to take the right action now. MTCC Latin America, working together
to promote an efficient
and sustainable shipping. This pilot project was funded by the European Union and implemented by the International Maritime Organization through the global MTCC network.
To help customers ensure smooth operations and class compliance, DNV offers to do selected surveys remotely for all ship types. Surveyors based in a dedicated operational centre and in 5 global expert hubs work around the clock to solve cases without going on board. The level of assurance is the same as a traditional onboard survey. Your benefits: class compliance with no or minimal disruption to operations, no travel time or costs, no waiting time, faster inspections with the same level of assurance as onboard surveys, global access to specialized experts 24/7, documentation is available immediately after the survey. Crews can prepare for remote surveys in a few simple steps. On DNV's online portal, My Services on Veracity, you can check whether your issue could be surveyed remotely. Remote surveys can be offered for occasional surveys that fall between periodical inspections, documentation-based surveys, testing and witnessing systems during normal operations, surveys not ordered together with annual surveys. DNV's remote surveyors work in teams and consult a network of specialized technical experts to solve complex issues. Access to an overview of documentation material, rules and customer information means they see the bigger picture and solve issues quickly. To demonstrate that a problem has been fixed, the crew may be asked to carry out function testing and share the footage using a live streaming tool. Remote surveyors watch live as the crew demonstrates compliance. As soon as the case is closed, customers have immediate access to electronic certificates and class survey statements.
Most of the customers rate this remote survey service as an excellent, and what they like about it the most is the communication and follow-up from the assigned surveyor.
Remote survey is a big step forward, which allow evaluation of problems reported from vessel. This without attendance of surveyor on board and without unnecessary traveling time. For us, means lower cost.
International policy meetings like COP26 offer politicians a real opportunity to accelerate shipping's route to decarbonisation. And as John Briggs reports, Lloyd's Register is calling on world leaders to seize the initiative, to build on the sector's work over the past 10 years and act now.
Over the last decade, shipping has made huge strides towards a decarbonised future. For industry leaders, the question now is how best to build on the progress made and to quickly scale up viable solutions.
There's lots of determination, a real excitement around supporting the industry through this so-called fourth propulsion revolution. And at Lloyd's Register, what we are now really focused on is ensuring how we make that a reality before the end of this decade.
To achieve the industry's ambitious objective will require 10 years of intense action, greater cross-sector and industry collaboration, and for national governments to keep pace with the progress already made by the private sector.
What we're focusing on now is trying to ensure that governments around the world, and there's a really critical meeting and discussion point around COP26 in Glasgow later this year, that governments are also recognising how quickly the private sector is moving and collaborating, and how quickly the demand for zero-emission fuels will be coming.
The world's first maritime classification society was also the first to say zero-emission vessels needed to be commercially viable and in operation by 2030. And it's the reason behind the Castor initiative, a collaboration between 6 global partners, including Lloyd's Register, drawn from the maritime sector and beyond.
We need to solve this energy transition equation together. We need friends, we need partners, and this is why I'm extremely proud of the Castor initiative, which comprises of 6 partners.
The 6 aim to design, build and commission the world's first ammonia-fueled tanker by 2025.
World-leading car society, we have a world-leading shipyard, we have a world-leading engine maker with a world-leading ammonia producer, and we've got a world-leading port authority, all bringing an important part of the jigsaw.
The Maritime and Port Authority of Singapore is working on creating the new refuelling infrastructure.
We are working towards being a multi-fuel bunkering hub to meet future demands of the global shipping industry. Singapore is an ideal innovation lab for decarbonization because we have the elements of a global hub port, International Maritime Centre, a top bunkering hub, and the reputable Singapore Registry of Ships.
ER is very enthusiastic being a part of the Castor initiative, and ammonia as a zero-emission fuel is core to our strategy. We are also very happy to contribute making Singapore a frontrunner in zero-emission shipping.
Yara have experience of manufacturing ammonia at scale, and whilst the shipping industry has experience of carrying ammonia as a cargo, we don't yet have experience of using ammonia as a marine fuel.
Researching the possible marine engines that will use the fuel falls to MAN Energy Solutions.
So we got involved in the Castor initiative because we believe in MAN Energy Solutions that cross-industry collaboration is important to help drive decarbonization of the maritime industry.
With Samsung Heavy Industries bringing expertise on vessel design and manufacture.
Samsung Heavy Industries will always be a good partner for the journey toward decarbonization. The multi-stakeholder project like Castor initiative will be the driving force to bring in an era of energy transition.
The Castor initiative is evidence of what can be achieved, a 360-degree approach to decarbonization that could be applied across shipping's value chain. But to scale up these projects around the world and to make the innovations commercially viable, governments and policymakers now need to act.
We want to hear critical and clear, decisive investment in the land-based infrastructure, and give the private sector the confidence that the land-based infrastructure, which is more national in terms of its investment, is moving at the same pace as shipping.
So, Nick, I'm going to put you in a room at COP26 with all the policymakers. What are you going to demand of them?
I'm going to say we can make 5% of zero-emission shipping, possibly more, absolutely achievable by 2030. But the worst thing that could happen is that 5 or more % of the world's ships are capable of running on zero-emission fuels, and we arrive in key ports around the world to deliver the goods that society in the nations in that room that I'll be speaking to are reliant on, and there's no zero-emission fuels available for the ship to load. That's the scenario we need to work together on to avoid.
Toward low carbon shipping.
The general objective of this pilot project is to strengthen the uptake of energy efficient technologies and operations by better understanding of the barriers and constraints experienced by relevant stakeholders within Latin America region. Also by making recommendations to policymakers and competent administrations on how to tackle these issues, and by disseminating the outcomes of this pilot project. This pilot project 1 has been developed taking into consideration the fundamental role of all the stakeholders acting actively in the implementation of strategies for the uptake of ship energy efficiency technologies and operations. Among the stakeholders, we can mention maritime administrations, government institutions, shipyards, maritime training centers, ship owners, ship operators, ship designers, marine diesel and engine manufacturers, classification societies, marine fuel suppliers, port authorities, port operators, national policymakers, and other interested groups and maritime professionals.
This report brings the information obtained to the attention of almost 300 participants and the responsible authority of 17 Latin American countries that have been engaged and trained through direct interaction with MTCC Latin America, as well as through the regional and national workshops organized by MTCC Latin America across the participant countries. The Pilot Project 1 has delivered 5 capacity building workshops across the participant countries, providing training on IMO's energy efficiency regulation, energy efficient ship operation, port state control and enforcement, as well as how to implement measures to improve efficiency on shipping, ship energy efficiency management, and a full data collection methodology in accordance with MARPOL Annex 6.
6 maritime administrations in Latin America were reviewed. 3 of them already adopted the MARPOL Annex 6. Another 3 countries were in the way to adopting the MARPOL Annex 6.
With the execution of this pilot project, we obtained relevant information on the common barriers and opportunities from developing countries within Latin America.
Barriers: lack of training and technical expertise, the uncertainty of experimental new technologies and the high cost for its implementation, absence of incentives for adopting or implementing energy efficiency measures, lack of environmental awareness, state capacity, and inadequate infrastructure.
Opportunities: training and raising of technical environmental awareness at all levels, partnership and strategic alliance, research and innovation, technical regional cooperation, implementation of green policies.
The decisions that we take today will certainly affect our future in all aspects.
It is necessary to take the right action now. MTCC Latin America, working together
to promote an efficient
and sustainable shipping. This pilot project was funded by the European Union and implemented by the International Maritime Organization through the global MTCC network. Welcome to the MTCC Latin America. The MTCC Latin America and the International Maritime University of Panama present the Pilot Project 2, Fuel Oil Consumption Data Collection and Reporting. Pilot Project 2 is about the fuel oil consumption data collection and reporting. Maritime administration such as Panama, Peru, and Chile, and shipping companies such as Carnival, Mediterranean Shipping Company, Ultranav, Humboldt, and Transgases participated and provided ship operational data to verify the process of how the Maritime Administration collect the data, reported, and then to share that information to the IMO.
The purpose of this Pilot Project 2 is to make use and perform a detailed analysis of the fuel oil consumption data collected by the MTCC Latin America with a scope of providing useful insights on Lessons learned. The real value for enhanced decision-making lies within the disaggregated data. Calculations of maritime operations with the automatic identification system data monitoring facilitate the verification process from the flag administrations. Slow steaming and just-in-time arrival information requires sufficient transparency between ship and shore. By effectively using existing technology, the overall process could be enhanced and facilitated in an effective way. Automatic identification system and NUN reports can be utilized to ensure effective regulatory implementation and fast enforcement. Experience gained through Pilot Project 2 enable us to support all parties involved in the regulatory implementation process. Regional technical cooperation is crucial for effective regulatory implementation through automation, digitalization, and optimization to offer great value to all parties involved. The decisions that we take today will certainly affect our future in all aspects.
It is necessary to take the right action now. MTCC Latin America, working together
to promote an efficient and
sustainable shipping. This pilot project was funded by the European Union and implemented by the International Maritime Organization through the global MTCC network.
To help customers ensure smooth operations and class compliance, DNV offers to do selected surveys remotely for all ship types. Surveyors based in a dedicated operational centre and in 5 global expert hubs work around the clock to solve cases without going on board. The level of assurance is the same as a traditional onboard survey. Your benefits: class compliance with no or minimal disruption to operations, no travel time or costs, no waiting time, faster inspections with the same level of assurance as onboard surveys, global access to specialized experts 24/7. Documentation is available immediately after the survey. Crews can prepare for remote surveys in a few simple steps. On DNV's online portal, My Services on Veracity, you can check whether your issue could be surveyed remotely. Remote surveys can be offered for occasional surveys that fall between periodical inspections, documentation-based surveys, testing and witnessing systems during normal operations, surveys not ordered together with annual surveys. DNV's remote surveyors work in teams and consult a network of specialized technical experts to solve complex issues. Access to an overview of documentation material, rules, and customer information means they see the bigger picture and solve issues quickly. To demonstrate that a problem has been fixed, the crew may be asked to carry out function testing and share the footage using a live streaming tool. Remote surveyors watch live as the crew demonstrates compliance. As soon as the case is closed, customers have immediate access to electronic certificates and class survey statements.
Most of the customers rate this remote survey service as an excellent, and what they like about it the most is the communication and follow-up from the assigned surveyor.
Remote survey is a big step forward, which allow evaluation of problems reported from vessel. This without attendance of surveyor on board and without unnecessary traveling time. For us, means lower cost.
We are back. Hello, ladies and gentlemen. We are back to continue our program in this international virtual conference. Thanks to all the participants who have stayed with us for the third and fourth block of the conference. We advise all participants that it's not necessary to leave your names in the chat room. The advice is when you receive your form for evaluation, your evaluation form, then you try to complete the information as accurate as possible, so your name can be extracted from the form and also go into the certificate for the end of the conference. Okay, so you can receive your certificate with your name correctly. That is the instruction. For the participants, we still have the participation of the experts, some of the specialists in the morning session, as stay with us. So in any case you like to leave your questions, please put it in our chat room, and the experts and specialists will try to interact with you to continue and to deliver the answers to you. Okay. So now we're ready to continue to move on with the conference, and we will start the block 3, which is related to the supply and storage of alternative marine fuels and energy efficiency measures. It's also, we like to inform you that this block number 3 and block number 4, it's combined English, and later we will change to Spanish language, so we can also cover some aspects in Spanish for our participants to understand the topics that we will be discussed and analyzed during the afternoon session. Okay. Next speaker. Engineer Martin Ignacio Rosux. Engineer Martin is a naval engineer, also graduated as mechanical engineer. Currently, Mr. Martin manages his own company that deals with the implementation of marine pollution regulations, capacity building programs, development of pollution management indicators, and IMO conventions and regulations. He is also ISO 5001 lead auditor and holds a diploma in energy management. Mr. Martin also works in the development of Internet of Things softwares and devices for energy optimization of ships and complete fleets. He has worked as manager and director in various companies in Argentina and Venezuela, among which we can mention Varsat SA, which is a technology company dedicated to the development of industrial and scientific processing data technology. We are very glad to have you, Mr. Martin, on board for the afternoon session to discuss today the topic energy efficiency measures applied to new ships using alternative marine fuels. Welcome, Mr. Martin, the floor is yours.
Well, thank you so much, Javier, for the presentations. Thank you so much also to the team of MTCC for this opportunity, and mainly to put into the hands of the public measures that will apply to decarbonization, because decarbonization is a matter of all of us. It's not only related to the shipping sector, but if we cross the threshold of the 1.5 degrees Celsius, we will have irreversible effects. That's why all efforts that we can make from different sectors, including the shipping industry, will be helpful for the world and all of us. And I don't know if you can see the presentation.
Yes, sir. We can see the presentation, perfect, and hear you loud and clear. Please proceed.
Thank you so much. Okay. Well, thank you all the audience. We will start talking about the energy efficiency measures applied to new ships using alternative fuels. One of our mottos regarding to this is that energy efficiency, we know it and we consider it another alternative fuel, because really has big impacts in the decarbonization of the marine industry. Just to start very easily, we have an ICE, what is an internal combustion engine. We have air, we introduce fuel, and produce an ignition process, whatever it takes, and a combustion. From that, we get emissions, and of course, we got work. When we talk about efficiency, of course, then we want to reach the less fuel for the most work. So this problem of emissions is what we are talking today. In this process of combustion, we will have other subproducts of the combustion like water, particulate matters, black carbon, CO, nitrogen oxides, hydrocarbon, and sulfur oxides. But most of this, what we are talking today, is related to the carbon dioxide, or CO2. Because when we talk about alternative fuels, sometimes we have impact on other gases and other subproducts of the combustion. That's why probably using alternative fuels, depending on which type, we can have impacts on the sulfur oxides, in the black carbon, particulate matters, or the NOx. That's why it's important to evaluate not only how much CO2 we are reducing, but instead if we have impacts on other gases and substances. What we are going to talk today to locate ourselves is about MARPOL Annex 6, Chapter 4. All this chapter is related to CO2. Other gases are related mostly for the Chapter 3. When we talk about energy efficiency, we must know where we are and we must know where we are going to and establish a plan to reach these 2 points. For this, the IMO set a set of studies. One of these is part of the 4th IMO for greenhouse gases study, where we present here where is the energy going on a ship. For example, for normal cruising, for slow transit, maneuvering, our berth, loading or unloading a cargo. So we can start making a planning to decarbonize, for the decarbonization of a ship, knowing where the internal energy is going. If I have to put more emphasis on the normal cruising or the maneuvering or at the process of berth or anchor. But let's have an overview of what we have right now. And when we talk about decarbonization and energy efficiency, we are not going to talk about one measure better than the other. We are going to talk a lot and set of measures. What we have right now are, for example, in the left side, existing ships using fossil fuels, existing ships using low carbon fuels, and existing ships using zero carbon fuels. On the right side, we have the new buildings using fossil fuels, new buildings using low carbon and zero carbon fuels. The columns of the existing ships will apply some new regulations approved at the MEPC 76 related to the EXI, or energy efficiency for the existing ships. The right side, we have the new buildings with their phases of energy efficiency design index. And we're going to talk about here index and not indicators, because both of them, they are one-time application, except that you achieve a measured conversion of a ship. And at the bottom, we have some other aspect that is getting noticed in the maritime sector. It's the carbon capture. Carbon capture or capture the emissions to become carbon neutral. And we are going to talk about the anthropogenic emissions. And the process that we can have this carbon capture is via the carbon capture and storage, carbon capture and underground storage, or carbon capture and utilization, where we use the CO2 capture to produce other substances. Regarding the measures applied to via the IMO, we have a set of measures for the new buildings and the ships in operation. We divide these measures in two types. First of all, they are short-term measures because they are going to be applicable up to 2023, where then we have mid-term and long-term measures from the IMO. We have technical measures and operational ones. The technical measures apply to the new buildings, where we have the EEDI, or Energy Efficiency Design Index, where a new build ship, must comply with and require EEDI or a certain amount of grams of CO2 per transport work. But when the IMO set up these EEDI goals, they noticed that there are a lot of ships running around the world and operating, as that kind of ships must comply also with some regulations. So it was implemented in the MTCC 76, the EEXI, or energy efficiency for existing ships, and additional operational aspects like the CII values and the CII rating, and the enhancement of the SIMP. The SIMP is the Ship Energy Management Plan. As we talked previously, we have a starting point and where we want to know. The SIMP is the bridge, how we are going to do that. Setting goals, setting procedures, setting metrics to achieve these goals in a sustainable manner. Regarding the new buildings, we have this EEDI for the design, how we design from the energy point of view. And we will have certain goals to 2050, where the goal is to reduce 70% CO2 emissions from the shipping industry compared to 2008. But the current values for the carbon intensity target must be reduced constantly up to that point. Of course, by 2030, 2040, ships must be truly efficient, but there are a lot of measures that are not yet ready or they are quite immature. That's why we are going to talk about sometimes the TRLs or the technological readiness levels, where is how available is a new technology to be implemented. For example, kites, air lubrication of the hull, rotors based on Magnus effect, and so other measures that can reduce the energy efficiency or improve the energy efficiency of the ship. From the operational side, that the previous was related to the design, but from the operational side, we have the CII. The CII is the carbon intensity indicator. And we are not going to talk about index right now, that is one-time application in the whole life of a ship, but now the indicator has a constant improvement goals. That's why the CII, or the carbon intensity indicator, is calculated via this basic formula. We have the ship, the fuel consumption, the carbon factor of the fuel that we are using. That's why we are talking about low carbon fuels, the cargo capacity, and the distance travel, and some correction factors that we approve and implemented in the next MTCC 78 in June this year. So if we want to talk about the reduction in the fuel consumption, I will put some short points here. We can have the optimization of the operation, an improvement of the propeller, the hull, or change in some cases the bulbous bow, or optimization of the bulbous bow, weather routing, speed, hull coatings, and logistics. So to mention some of the measures that can help this fuel consumption reduction. On the carbon factor side, we have low or zero carbon fuels that all the professionals that preceded me were talking about. Then we have the cargo capacity. It's quite difficult sometimes to increase the cargo capacities if we can put some cargo in the captain's room, but it's something that we have to modify the ship. And of course, the distance travel that depends on the contract. So we cannot do much in that 2 points. And this formula creates a lot of noise internally, because some ships will be benefit from this formula and some of them not. Relating to the CII, we have an attained value and a required value. There are numerical values, but we have also a rating. It's similar, this rating, to what you have on your fridge at home, a list of colors and letters, where you have A, we have the most efficient ship, and E, we have the least efficient ship. So we have these 5 grades where we have to comply. All ships must be at least in C. And of course, all that is above C in ratings from D to E must reduce its energy reduce its energy consumption or change fuel to reduce its carbon footprint. For the cases where a ship is located in D for at least 3 years, must be set a plan and reduce in 3 years to C. If the ship is located in the E rating, it has 1 year, no more than that, to reach D, and then 3 years additional to reach C. This must be registered in the SIMP and approved, and the measures must be complied with and achievable. This is the short-term goals of the IMO, and this is a constant improvement of the energy efficiency of the ships. We have from 2023 to 2026 set goals based from the 2019 values, where it was the first IMO DCS. And we have, for example, from 2019 to 2023, we have a 5% reduction. Then we have 2% more by 2024, 2% more by 2025, and 2% more to 2026. So you can see that many of the ships must check all the ships must recheck every year this rating. And if in cases that they change the rating from C to D or D to E, must set up the measures to reach C values. From 2026 onwards, this will be revised in the MTCC 2026 with the new values according to the needs of the global warming. What we have as measures for this reduction in energy consumption on the ships. We have some operational measures like SHITA or just-in-time arrival, virtual arrival that is quite common because some contracts are linked with the fixed speed. So we cannot modify this, and we need something that can vary our parameters for the energy performance. We have optimization of the speed. Check that we are not going to talk about speed reduction, but the optimization of the speed according to the contracts and the logistics and the navigation. The optimization of the dynamic trim, optimization of the ballast, optimization of the use of the energies, optimization of the maintenance. This is quite important because you check the measures that we mentioned before. The problem is we must know that every year a ship increases from 1 to 1% its fuel consumption due to hull fouling, due to roughness, increased roughness in the hull. We have a hull in the propeller, so that's why it's not the value set in these goals, but also how we maintain our ship. Best operational practice as another operational measure, and crew training. And crew training is one of the biggest key issues of many shipping companies and operators, because some crew doesn't know about the energy efficiency measures, doesn't know about the new regulations, and they don't know how and with what they have to comply with. Of course, on the other side, we have technical measures to reduce our carbon footprint with low or zero carbon fuels, and optimization of the design, and optimization appendices, where we have here a lot of new developments that are in some advanced technical readiness level. For example, the propeller board cap fins, that is a small propeller that is attached in the hub of the propeller. We have optimized rudders. We have appendices for get a better influx of water into a propeller. And with all these measures, we can improve our energy efficiency. And on the other side, we put it separately, but in fact, it's more related to operational measures. It's other stakeholders. These other stakeholders are really tough because we will have to deal with contracts, market-based measures, and the logistics of the ports. Flexible contracts, we have a lot of clauses implemented by BIMCO or other entities, where we can have a set of clauses which allow us to reach different speed levels according to energy needs. And of course, it's a split of the benefits of this between the charterer and the ship owners. Then we have, as other stakeholders, the market-based measures, when we have here like emission trading systems where we can trade our emissions, basically in Europe, not in Latin America yet, where we said we negotiate with carbon stocks. And the logistics, of course, is one of the most important as other stakeholders to have good information and relation with the ports in order to know where a port or a place is available and not be anchored burning fuel in our ship. When we talk about energy efficiency, you will check that we are not going to talk about one or two measures. It's a set of measures. That's why energy efficiency depends on all these aspects. Other stakeholders, contracts, market-based measures, technical aspects, fuels, what type of fuel we are going to use, and operational measures for optimization of speed and virtual arrival and so on. That's why it's important to know that energy efficiency are a set of package of measures that will apply. Some mandatory regulations and additional management tools that we have related to the energy efficiency are, for example, the Regulation 26 will be amended at the MTCC 78 in a couple of months with the enhanced SIMP or SIMP 3. It's the Ship Energy Management Plan, where set the parameters and how must a ship comply with the reporting of the measures that it will take to comply with the ratings of the ship to reach a C value. So it's quite similar to the ISO 50001, where you have a PDCA cycle with plan, do, check, and act continuous improvement cycle. Then we have the regulations, the Regulation 28 related to the carbon intensity indicator. And we have a lot of certain resolutions related to this, where we have the Annex 10 to 13, with the C1 to C4 right now, with calculation methods, reference lines for the CII, the reduction factors, and the rating, how we determine the rating of a ship. And by June 2022, at the MTCC values, it will be defined some correction factors for the formula, because not all the ships are rated the same, do not all the ships operate in the same manner. Between the same types of ships are also some differences. That's why we expect that the correction factors will help to standardize this. When we talk previously to the CII formula, we talk about, there are two types of calculations, in fact. If you check out the regulation G1 of the Annex 10, we have supply-based calculation and demand-based calculation. Because demand-based calculation is about the actual cargo that you are carrying, or it's not mandatory in the IMO DCS. It's not possible to calculate it right now, except from a mandatory point of view. But we have what we have is a capacity in deadweight or gross tonnage, and this is the formula that we are using. That's why the C1 is quite confusing for the first reader, and then you will check that the application is different. But the main calculation is related to the cargo and the real transport work that we are doing. But as I mentioned, IMO DCS does not contemplate in the reporting this law, so we are going to use the cargo capacity. Some additional tools related to energy efficiency that will help us to comply with the regulations. We have the ISO 19030, where we have measurements in hull and propeller performance, and in an standardized way. So we can check between periods what is happening and how much the energy efficiency is decreasing due to the problems of hull fouling and propeller. So we can have this standardized model to help us to comply with the regulations. we have the TRL analysis to check how mature is a new measure or a game changer technology. When we talk about new fuels, ammonia, hydrogen, biofuels, and so on, but how much ready are them for the application? And indicators for decision making and prediction. This is a key issue. For example, because if you want to measure if a ship is efficient, you cannot measure how much fuel is consuming. You have to check how much is the fuel consumption related to other parameters. Because of course, if you are carrying 1,000 tons of a product, you will have a certain consumption, but if you have 15,000, you will, of course, your fuel consumption will be much higher. So you have to make the relation between how much cargo you are carrying, how is the speed, how is the consumption related to the dead weight. So we are going to talk about indicators as a manner of monitoring. And last but not least, we have a resume of how much we can reduce our fuel consumption and our carbon footprint, in fact, with certain measures. We have, for example, standardized that logistics and digitalization, you can save more than 20%, via speed reduction or optimization, vessel utilization, vessel size and alternative routes, hydrodynamics with the hull coating, air lubrication and constant cleaning, machinery with machinery improvements, weight heat recovery, engine deratings, hybridization of the ships, fuels and energy, as our colleagues talks in this seminar, LNG, LPG, methanol, ammonia, hydrogen, and harvesting energy from the surroundings, like, for example, using solar panels to reduce our consumption of the auxiliary machinery. And thus, after treatment measures, like carbon capture and storage, that is something that is quite a game changer right now. And we want to emphasize this because this measure help us to get involved other stakeholders that are not related to the energy industry. So we can have a company capturing 1,000 tons of CO2, and they capture and we pay for them for the emission that they are recovering from us. And this is quite a game changer. It's quite under a very low TRL level in some parts because it's very new, but could be another possibility to decarbonize the shipping sector. Well, Xavier, thank you so much. I hope that get a better insight of the ship energy efficiency plannings and why we need the energy efficiency in the shipping industry.
Thanks a lot, Mr. Martin. Very, very good presentation. Still the information continues to flow in the afternoon. It's good to have also the participants learning about these important issues on the maritime sector. We have got some questions from the audience also. The first one, what indicators are usually applicable for energy efficiency monitoring?
Okay. Well, related to energy indicators, it's quite important. I will show you some indicators, for example, that is on the real and on a daily basis. I don't know if you can see this slide.
No, we can see your picture.
Okay, let me check. Let me check.
Okay, now it's shared. Now it's shared. We can see it now.
This is a real example of a certain ship, in this case a tanker, where we have, for example, a lot of indicators that we are measuring. Now, this is a work that we are doing on our daily basis. Where, for example, we have the relationship between a lot of indicators. For example, the EEOI, that is the energy from operational indicator, related with this carbon intensity or annual efficiency ratio. We have how much this indicator of energy efficiency of operational indicator is related to the ship speed, or how much is related to the load index. So we can have a set of indicators, or for example here that we have how much time, how much CO2 per hour a ship is emitting, and its relation with the cargo that they are carrying. So that's why these kind of indicators help us to understand what is happening from the energy point of view in a ship, and will help us mainly to take decisions. In our case, for example, we use machine learning where we can check what happened, what has happened, and what will happen with a ship under certain conditions. That's why one of the most important things is to use indicators and mainly to set goals. Let me check here this in order to set the goals and see under what rating this ship is operating, if it's in A, C, D, or E, so we can set up the measures and act on time to comply with the regulations. If not, we will have or penalties, or a ship could be detained in some cases, but it's important to comply with the regulations. That's why you have to monitor and set up the concrete and real indicators for this. I hope that get the answer for the questionnaire.
Excellent answer. Another question: what are the main barriers to implementation of energy efficiency measures?
Okay. Well, the main barriers that arise in the shipping sector was many. Some of them we can find it out in a study that made by the World Maritime University by 2018, as I remember, where they make an inquiry to shipping owners, to charterers, to crew members, what is happening with the energy efficiency and why they do not implement the measures. And they find out that the main problem was lack of information, excess of information, lack of knowledge, lack of the regulations, and lack of training. That's why this seminar is to put in the hands on every stakeholders in the maritime sector what is happening and what can happen from the energy point of view and from the energy efficiency. But this was problem that was arising globally. And if you check one shipping company in China and you find out and compare it with a shipping company in Argentina or Brazil, they will have the same problem of lacking of information, lack of training, and lack of interest sometimes of the owners or charterer. That's why to train, as this seminar, is really vital and important.
Yes, we do agree with your conclusions and with your analysis, Mr. Martin. Has been a great presentation, and we thank you for your intervention during this afternoon to open the third block of this conference. On behalf of the International Maritime University and the MTCC Latin America, we would like to present a certificate of recognition for this amazing and remarkable presentation. I believe we all have taken a good advantage from all your knowledge and information. Thank you very much, and looking forward to participating together in the future projects. Thank you, Mr. Martin.
Thank you so much to all of you.
Great. And to move on with the program, we will present the second speaker of the afternoon, and here is where we change. We will switch to Spanish version of the conference, and the afternoon session will continue in Spanish. Okay. En esta ocasión, como les mencionaba, cambiaremos a español para continuar con nuestra presentación y la importancia de los temas que se van a tocar, de algunos aspectos nacionales y regionales con respecto a el título de este bloque. En esta ocasión presentamos al ingeniero Oscar Santibáñez, ingeniero civil mecánico, ingeniero civil industrial, ambos por la Escuela de Ingenieros de la Universidad de Chile. Cuenta con un máster en Business Administration y con un máster en Business Law. Además, posee un diplomado en Mercadeos Eléctricos de la Universidad de Santa María, en Derecho y Política de la Competencia de la Universidad de Chile y en Regulación Económica de la Universidad Adolfo Ibáñez. Actualmente es candidato a una maestría en Regulación Económica. Desde 1998 ha estado involucrado en distintos segmentos del negocio del gas natural, trabajando en transporte de gas por gasoductos, terminales de regasificación de GNL y comercialización de gas natural, desempeñándose en diferentes áreas de filiales chilenas de compañías internacionales del sector oil and gas, con operaciones en Chile, Argentina, incluyendo responsabilidades en regulación, operaciones, comercialización y desarrollo en el mercado de gas. Hasta julio de 2020 se desempeñó como director de desarrollo de gas de la estatal Empresa Nacional del Petróleo ENAP Chile, y desde agosto de 2020 tiene bajo su responsabilidad la comercialización del gas natural licuado para Centroamérica y países en el área de influencia del terminal de regasificación ubicado en Colón, Panamá, en su calidad de Liquefied Natural Gas Marketing and Origination Director de AES Panamá. Ha sido también miembro del directorio de distintas empresas en transporte de gas por gasoductos y fundador y director de la Asociación Chilena del Derecho y Regulación de la Energía, ADEREN. Nos complace presentarles en esta tarde a todos ustedes a nuestro invitado especial de AES Panamá, el doctor Oscar Santibáñez, quien nos estará presentando el título Infraestructura y comercialización del gas natural licuado en Panamá y en Latinoamérica. Bienvenido, doctor Oscar. El micrófono es todo suyo.
Muchas gracias, Javier. ¿Me escuchan bien?
Sí, lo escuchamos.
Perfecto. Buenas tardes a todos. Les voy a proyectar mi presentación. Bueno, vamos a arrancar conversando un poquito acerca de lo que es la compañía, lo que estamos haciendo y hacia dónde creemos que va este mercado y por qué estamos justamente promoviendo el uso del GNL en este mercado. Bueno, para información de todos, AES Corporation es una empresa internacional ubicada en 4 continentes que se dedica fundamentalmente a la generación eléctrica. Tiene casi 30 gigas instalados de capacidad, tanto tradicional como de generación renovable. Tiene foco actualmente en el almacenamiento de energía. En un joint venture con Siemens se ha desarrollado una compañía que se dedica justamente al almacenamiento de energía, que es lo que hoy día está más en boga. Distribuimos energía eléctrica a consumidores finales y promovemos el uso de la generación distribuida en estos mismos clientes finales. Esta es una compañía internacional, para que todos sepan dónde estamos conversando. Pertenece está en bolsa y está como una compañía Fortune 500. Bueno, en Panamá en particular, ¿qué es AES Panamá? AES Panamá es una compañía de 300 personas que fundamentalmente está enfocada en la generación eléctrica usando recursos tradicionales, como es el caso de la generación a gas acá en Colón, donde hay una planta recientemente inaugurada, ya lo vamos a ver con un poquito más de detalle, y opera otras unidades hidráulicas como Bayano y Changuinola, que producen energía hidráulica, y en el proceso de los últimos años ha estado implementando plantas solares y eólicas para dar un portfolio a nuestros clientes de suministro renovable, que en este caso ya alcanza el 67% de nuestra potencia instalada en el sistema eléctrico panameño. A raíz de la instalación de la planta de Colón en generación a gas, se instaló un terminal que lo vamos a ver ahora a continuación, pero básicamente lo que justificó la entrada de este terminal fue básicamente la incorporación de esta planta de generación eléctrica de ciclo combinado gas natural. A raíz de que esta compañía, AES, ingresó en el mercado del gas natural en la región, En el año 2003 implementó una solución de gas to power en República Dominicana que partió con un tanque de 160 metros cúbicos de capacidad de almacenamiento. Hoy estamos construyendo un segundo tanque de 120.000 metros cúbicos adicionales que se espera que esté construido en un par de años más. La instalación de este terminal permitió la generación de dos plantas de generación eléctrica propias, que es AES Andrés y DDP, que prácticamente suman 700, un poco menos 700 megas, más otras plantas de generación que están ligadas al terminal de Andrés en República Dominicana. A posteriori de la instalación de un terminal en Dominicana, se instaló una instalación patio carga de camiones de GNL, ¿sí? Un truck loading facility, que hoy día tiene una capacidad de 4 bahías de carga, que aproximadamente está cargando 10.500 cisternas al año que se distribuyen en clientes industriales, en más de los 70 clientes industriales que tenemos en ese país, ¿sí? Ya hay más de 15.000 vehículos convertidos a gas natural comprimido y se exporta GNL usando isocontenedores en los países del Caribe que son cercanos al área de influencia del terminal de Dominicana. En el año 2018, AES toma la decisión de ingresar al mercado panameño con gas natural, se gana una licitación con una distribuidora local y permite la construcción de un segundo terminal en la región, un terminal con un tanque en tierra de 180.000 metros cúbicos de almacenamiento que cuenta con una unidad de ciclo combinado de 380 megas conectada actualmente y que genera permanentemente inyectando a la red. En un par de años más va a haber una segunda unidad, que es Gatún, donde somos socios solamente en minoría, pero va a estar conectada al mismo terminal, vale decir, estamos hablando de un terminal que va a estar abasteciendo prácticamente 1.000 megawatts de aquí al 2024 al sistema eléctrico panameño. Junto con el terminal se instalaron dos bahías de carga para camiones. Actualmente estamos sirviendo a un cliente que es un generador aislado en la zona de Darién y que recibe aproximadamente 500 cisternas al año. Y desde diciembre del 2021 estamos exportando GNL por vía contenedores hacia Ecuador. Les cuento esta historia fundamentalmente para que vean cómo partió y en la posición en la que está hoy día República Dominicana y cómo ha partido y la proyección que tiene este negocio en particular en relación con el GNL y cómo estamos llevando de manera bastante más acelerada de lo que pasó en República Dominicana para alcanzar los mismos estándares de República Dominicana. Es decir, deberíamos estar apuntando a tener en un tiempo más bahías adicionales, muchos clientes industriales, estar empezando a trabajar en el tema del vehicular y desarrollar todo lo que significa el área de influencia cercana al terminal, ya sea en Costa Rica, Nicaragua, Honduras, El Salvador, Guatemala, y eventualmente, como ya lo estamos haciendo hoy día en Ecuador, y llegando a Colombia en los próximos periodos de negocios que estamos enfrentando. Lo que es claro y lo que hace diferente un poquito esto es que en el caso de Panamá, lo que existe es un joint venture, ¿sí? Que se llama Colón LNG Marketing, que es un joint venture entre la empresa petrolera francesa Total Energies y AES, que es el proveedor de infraestructura. Total nos provee el GNL en sus barcos y AES provee el servicio de recepción, almacenamiento y carga o regasificación del GNL para uso en distintas tecnologías, como es el caso de lo que vemos acá. Básicamente, las tecnologías de uso están en el centro, hay tecnologías de generación eléctrica, hay tecnologías que usan el GNL para bunkering, otros en la industria, en calderas y en transporte en motores a combustión interna, típicamente buses, camiones y vehículos livianos. Para eso, los medios que nosotros utilizamos para llegar a esos mercados, hoy día lo estamos haciendo a través de cisternas para este cliente en Darién, lo estamos haciendo para Ecuador a través de esos contenedores y posteriormente lo vamos a empezar a hacer, que es lo que vamos a conversar en esta charla, en embarcaciones de pequeña escala, en small scale, le llamamos nosotros, para abastecer mercados más alejados y eventualmente podría existir algún tipo de gasoducto que abasteciera zonas locales cercanas a Colón o a Panamá mismo. Particularmente la nueva unidad que les comenté, que es Gatún, está siendo abastecida por un gasoducto que en términos del mundo de los gasoductos muy pequeño, tiene menos de 2 kilómetros, pero es un gasoducto que nace de la planta y llega a la unidad de generación. Bueno, aquí hay mensajes que a nosotros nos interesa dejar muy claro y patente en la discusión. Lo primero es que el GNL como combustible es un combustible disponible y accesible. ¿Por qué decimos esto? Porque afortunadamente el gas natural y particularmente el GNL es un combustible que se encuentra en diversas regiones del mundo, no solamente en países geopolíticamente complejos, sino que lo podemos encontrar en Estados Unidos, lo encontramos en Australia y también en los países típicamente petroleros, como es el caso del Medio Oriente. Este mismo hecho ha producido que en la industria se empiecen a desarrollar focos tanto de licuefacción en la producción como de consumo. Como ustedes saben, los dos focos principales en esa línea son la irrupción de China como un gran consumidor de GNL. China hoy día superó al líder Japón, que por muchos años fue el principal consumidor de GNL del mundo, y en particular, lo más interesante es que Estados Unidos se transformó de ser un importador neto, eso seguramente más de alguien lo sabrá, a un exportador neto de GNL, ofertando al mercado internacional su GNL de manera abierta e indexada a los indicadores americanos. En particular, el caso de Centroamérica, y en el caso nuestro en Dominicana y en Panamá, estamos siendo abastecidos fundamentalmente con gas que viene desde las plantas de licuefacción que están ubicadas en el Golfo de México, vale decir, estamos vinculados por naturaleza geográfica directamente al mercado americano. Eso es una gran ventaja. Creo que es interesante entender que la accesibilidad del GNL en el mercado mundial es completamente abierta, hay muchos productores, hay muchos traders trabajando en este negocio y obviamente estamos todos los que estamos en el mundo de la compra con los terminales que ustedes pueden ver acá abajo. Algunos de ellos estaban, en este caso, en esta imagen, algunos estaban en construcción y ya están construidos, otros están en proyecto y están en ejecución, etc. Pero básicamente lo importante de esto es que el mercado de GNL ha crecido, se ha desarrollado tanto en oferta como en demanda y estamos viendo que este es un combustible que va a tener una consolidación, ya está teniendo una gran consolidación, pero va a ser mucho más a raíz de la crisis de Ucrania. Segundo mensaje. El GNL es un combustible limpio. Nosotros lo llamamos, no es un combustible perfecto, sin duda, es un combustible de bajo carbono, ¿sí? De bajas emisiones, pero yo creo que hay un tema que no hay que soslayar y tiene que ver con que a pesar de que las reducciones de gases de efecto invernadero del gas natural son aproximadamente en torno a entre un 25, en términos estequiométricos, 24, para ser más preciso, y de ahí hacia abajo, sí nos encontramos con una gran ventaja en los otros parámetros de los contaminantes atmosféricos con los que nos enfrentamos normalmente en la combustión, como es el caso de los óxidos de nitrógeno, de los óxidos de azufre y el material particulado. Esto es muy importante, básicamente porque a veces nos estamos centrando mucho en lo que pasa con los gases de efecto invernadero y nos olvidamos que hay gente que respira esos gases. Y estos gases son los que van a los pulmones de nuestros conciudadanos y que están respirando combustibles o gases de combustión que son nocivos y producen efectos en la salud. Esta es una gran ventaja de lo que hizo, por ejemplo, la Organización Marítima Internacional con el proyecto de restringir el uso de azufre en las emisiones. Esto hizo muy bien a la industria y demostró que es posible alcanzar un acuerdo y no solamente mirar una dimensión de los contaminantes, sino hay que mirarla en forma integral y completa. El tercer mensaje que les queremos pasar es que el GNL es un combustible dúctil. El GNL es un combustible que increíblemente permite ser usado en los más increíbles usos, desde un auto pequeño en un taxi hasta una gran generadora eléctrica. Puede ser utilizado en una caldera, sirve para hacer frío, sirve para producir calor, como buen combustible, es muy dúctil y eso nosotros creemos que es una gran ventaja y creemos además que es lo que nosotros consideramos más potente, es que basta con tener este combustible disponible en un punto para que inmediatamente empiecen a aparecer intereses para explorar estas tecnologías en cada uno de estos ámbitos con los que le estamos comentando. O sea, generación eléctrica, transporte por carretera, industria y obviamente, que es lo que nos convoca, el bunkering en la industria marítima. Un elemento que quizás a veces se olvida un poquito es que el GNL es un combustible seguro y que está aprobado, y eso nos interesa marcar 3 puntos acá. Lo primero es decir que respecto de los combustibles tradicionales, el gas natural licuado es un combustible equivalente en términos energéticos, y aquí lo podemos ver en su densidad energética en tanto en gramos como en litros. Como pueden ver acá, estas unidades son bastante extrañas, son watt-hora por gramo o watt-hora por litro, pero refleja una comparación muy cierta de lo que sucede con el gas natural en sus dos versiones, comprimido, gaseoso y licuado, respecto de lo que pasa con los combustibles tradicionales. En el caso de otros energéticos, incluimos acá las baterías y el hidrógeno. Ustedes pueden ver que hay una diferencia importante, y esta diferencia importante tiene que ver con la densidad energética con la cual estos combustibles son producidos. Son maravillosos combustibles, sin duda, pero tienen un problema de densidad energética, que es lo que los hace complejos de resolver para tecnológicamente aplicarlos en soluciones de industria pesada. El otro elemento que también no hay que soslayar tiene que ver con las condiciones de almacenamiento. En particular, el hidrógeno líquido debe ser almacenado a menos 256 grados, que es realmente una complicación metalúrgica respecto de los materiales requeridos para usar este tipo de combustible en condición líquida. Es criogenia pura. Y en el caso del hidrógeno gaseoso, ustedes lo pueden ver en un ejemplo muy claro. El Toyota Mirai, que se vende normalmente en Estados Unidos, es un vehículo que cuenta con 3 tanques de 700 bares, 700 atmósferas bajo el asiento. Lo cual significa que es una situación compleja, que no es ideal y que obviamente en el uso tradicional, frente al riesgo que ocasiona el uso de este tipo de combustible, nos muestra que todavía queda bastante por desarrollar y comprobar que efectivamente esto es seguro. No dudamos que lo es, no creemos que Toyota hace un buen trabajo en esas botellas de almacenamiento de hidrógeno gaseoso, pero indudablemente 700 bares es una presión muy alta para todos los efectos. Un punto que no está aquí destacado tiene que ver con el Lowest Production Limit que tiene el gas respecto al hidrógeno, y para que se hagan una idea, el gas se maneja entre 5 y 15% de concentración versus el hidrógeno, que está situado aproximadamente entre 5 y 75%. O sea, vale decir, el hidrógeno es 5 veces más explosivo, lo cual nosotros lo sabemos por la historia del Zeppelin, pero cuando uno lo comenta, hace mucho más sentido entender por qué la complicación del hidrógeno, al ser una molécula tan pequeña, tan densamente cargada energéticamente, tiene este riesgo de explosividad que yo creo que no hay que obviar. Un tema que quizás es interesante para ustedes que están en el negocio marítimo tiene que ver con lo efectivo que es este combustible. Y esto hace una relación, es un muy buen gráfico que muestra la relación entre la densidad energética en volumen versus la densidad energética en masa. Y lo que vemos acá es la razón por la cual los combustibles que conocemos hoy día triunfaron, y tienen que ver con que su relación es muy favorable para almacenar una cantidad de energía en un volumen, un metro cúbico de un estanque, de un barco, de un camión o de lo que sea. Esto es lo que hizo en el fondo que estos combustibles fueran líderes en el mundo por los últimos 100 años. El desafío que tenemos hoy día es cómo hacemos que los nuevos combustibles, ya sea el hidrógeno, el propio GNL e incluso el gas natural comprimido, puedan alcanzar una condición que les permita subir en esta escala. Porque lo que estamos viendo aquí, que si bien son altamente energéticos, pero tienen, en términos de masa, son bastante poco útiles al llevar esa energía a un tanque de almacenamiento. Esto, a mi gusto, es lo que muestra en el fondo por qué algunos combustibles son preferidos respecto de otros en las distintas industrias, y en particular hemos visto cómo algunas navieras han descartado, por ejemplo, el hidrógeno justamente por este efecto, porque les provoca la necesidad de ocupar espacio que se destina al negocio, a la carga, en llevar un combustible que podría ser distinto y que obviamente tiene estas complicaciones. Un punto importante que hay que considerar es que el GNL es un combustible competitivo. Aquí le estoy marcando una realidad de los últimos precios. Obviamente aquí no está lo que ha pasado en el periodo reciente, obviamente, que es una locura. Seguramente en un par de meses más, a lo mejor en más tiempo, vamos a ver cómo estos precios cambian. La tendencia es al alza, y la tendencia al alza fundamentalmente por efectos de la guerra en Ucrania, por efectos de la sobredemanda que va a provocar en el mercado del GNL la entrada de nuevos terminales en Alemania principalmente, y esto podría provocar un desequilibrio entre oferta y demanda y podría llevar lo que está pasando hoy día a los precios un poco al alza. Pero lo interesante de este gráfico es mostrar cómo la entrada de Estados Unidos al mercado del GNL produjo esta baja de precios. O sea, cuando hay más oferta, como es el caso de los americanos, que es la línea roja en el Henry Hub, el indexador americano por excelencia, cómo eso arrastró finalmente lo que ha terminado pasando en este último periodo. Esto que ustedes ven acá, básicamente el efecto Fukushima, ¿sí? Y lo que es interesante ver es cómo el precio del GNL se vuelve competitivo. Para que tengan una referencia de precio, hoy día el GNL es altamente competitivo contra el diésel, el GLP, estoy hablando de 20, 30 en países importadores, obviamente, no en países productores, 20 o 30% por debajo de los precios normales de estos combustibles estándar. Y respecto de los petróleos marítimos o los petróleos pesados en general, la competencia es bastante pareja entre el GNL y los combustibles marinos. Esto es interesante. Vemos cómo el GNL es el combustible de transición. Esto es un forecast que presentó DNV en 2019 y que muestra cómo ellos visualizan, esta caída obviamente es por el tema de la IMO 2020, pero ellos visualizan el crecimiento del GNL como parte del el cambio en la matriz energética en la industria marítima internacional. A nuestro juicio, esta es la razón principal por la cual a nosotros nos moviliza desarrollar este mercado en la región y ofrecer nuestro producto a los consumidores que estén en la zona. ¿Qué estamos haciendo actualmente? Bueno, terminada la instalación de la planta de generación eléctrica y el tanque completo del terminal, se construyó una facilidad de carga de camiones, como ustedes pueden ver ahí, son dos bahías que están operativas desde enero del 2021 y ya estamos entregando a este cliente de generación del orden de 2 cisternas diarias a 500 kilómetros en round trip para que dimensionen un poquito cómo es la logística del GNL, que no es muy distinta a lo que ustedes pueden ver, por ejemplo, en el caso del oxígeno hospitalario, que se mueve en cisternas criogénicas para descargar en tanques ubicados en el destino, donde son vaporizados y posteriormente inyectados a redes para consumo local. Lo que estamos en proceso, bueno, les comentaba la exportación a Ecuador. Esta es una planta de un distribuidor nuestro que está aquí en Panamá, que está próxima en estos días, entra en servicio. Esta es la primera planta industrial en Panamá y posteriormente vamos a estar informando esta noticia que es la implementación de GNE, de gas natural comprimido en una prueba piloto de una flota de transporte público acá en Panamá. ¿Qué es lo que creemos que viene? Bueno, aquí empieza lo interesante para ustedes. Creemos que deberíamos empezar a apuntar a explorar el uso del GNL en naves menores como los remolcadores y otro tipo de naves de servicio. Ustedes pueden ver aquí el proceso de desarrollo y entrar en servicio del primer remolcador a GNL que se produjo en Turquía. Están en operaciones y varios otros más de la misma clase. Como pueden ver acá, este es un remolcador que tiene al frente una cisterna criogénica que lleva GNL y que la carga por la vía tradicional como si estuviera cargando cualquier combustible como diésel. Sabemos que de esto hay ventajas económicas y medioambientales, pero lo que nos interesa es verificar si es que esta utilidad de simpleza de uso de la carga del combustible opera en los remolcadores que son necesarios para operar, por ejemplo, en el canal de Panamá, atendiendo puertos o atendiendo ya sea los servicios propios del canal. El canal de Panamá está justamente ahora en una licitación de remolcadores y nos parece que sería prudente que exista una competencia entre todos los energéticos disponibles, diésel, eléctrico, GNL, GLP. Estamos obviamente dispuestos a avanzar y probar y si es necesario hacer un demostrativo que nos permita mostrar que esto efectivamente funciona. ¿Qué es lo que viene ahora? Bueno, básicamente estamos en proceso de usar el terminal que tenemos. El terminal que ustedes pueden ver acá arriba es un terminal con un tanque de 180.000 metros de capacidad de almacenamiento y capaz de recibir un barco como este de la misma capacidad de descarga. Sin embargo, el terminal está creado desde el origen, desde el diseño original, para recibir hasta pequeños barcos de 3.000 metros cúbicos. Este es un barco de 7.500, pero puede recibir hasta barcos, el más pequeño, de 3.000 metros cúbicos, que nos permitiría prestar servicios de bunkering con GNL en la zona. ¿Por qué? Y la razón es muy simple. Esta es una industria que se está desarrollando. Creemos que el combustible, como les expliqué antes, es un combustible correcto para el uso que se está produciendo. Se puede cargar por vía de camión a barco, se puede usar barcaza o se puede usar directamente pequeños metaneros para hacer el servicio. Obviamente estamos a las puertas del Canal de Panamá. Por el Canal de Panamá circulan más de 12.000 naves al año. Algunas de ellas van a requerir este servicio y nosotros queremos estar apoyando a la autoridad del canal en validar lo que ellos llaman la ruta verde, básicamente darle al Canal de Panamá la condición de preeminencia en el manejo de la carga por la región y del tránsito por la región, y particularmente en la reducción de emisiones para la industria marítima. Como ustedes saben, lo que está pasando en el mercado es que el GNL es un combustible que está siendo cada vez más utilizado. Lo que prevén los especialistas es que van a venir a raíz de la IMO 2020 y producto del impulso de la Initial Strategy de la Organización Marítima Internacional, van a venir, están viniendo nuevas construcciones de barcos a GNL, y esos barcos van a requerir ser abastecidos con el combustible, y ese abastecimiento estamos nosotros disponibles a darlo en Panamá en los próximos meses. En tal sentido, les quería comentar que estamos próximos a dar inicio a las obras propiamente tal. En este momento el contratista está movilizándose en la zona y empezando la construcción inicial de lo que nosotros llamamos el Shiploading Facility. Básicamente es una instalación que permite revertir el sentido normal del flujo desde el jetty hacia el tanque, ahora invirtiendo el flujo desde el tanque hacia el jetty para cargar barcos pequeños. Esto debería estar operativo el cuarto cuatrimestre del 2023, del próximo año. O sea, estamos prácticamente a 18 meses, 20 meses de tener esto operativo, con una capacidad de bombeo que va a ir de entre 500 metros cúbicos de GNL por hora hasta 2.500, lo cual permite cargar tanto barcos pequeños como barcos grandes de GNL, y lo que visualizamos de esto es que esto va a generar un cambio en la condición de la oferta de combustibles marítimos en la región, de GNL para las navieras que estén interesadas en tomarlo en esta región. Y finalmente comentarles quizá un mensaje que a veces cuesta un poquito digerir, y es que nosotros entendemos que el GNL es un combustible limpio, pero no es un combustible carbono cero. Sin embargo, a través de esta medida, que es la compensación de las emisiones que produce el combustible en el tiempo desde que se produce hasta que se combustiona, efectivamente se toman esas emisiones, se compensan por la vía de tercera parte con un certificado que permite que a quien compre un combustible net zero, green LNG o como le queramos llamar, compensado en definitiva, puede estar apostando a tener efectivamente una condición de carbono neutral de manera directa y sin tener que esperar a que surjan los combustibles nuevos en el mercado. Básicamente es eso. Espero no haberlos aburrido mucho y los dejo. Quedo disponible a su consulta.
Muchísimas gracias por la excelente presentación, doctor Oscar. Excelente intervención, y nos ilustra sobre todo lo que está sucediendo a nivel nacional y regional en cuanto a la utilización del gas natural licuado y todos los proyectos a corto y mediano plazo. Hemos recibido también algunas preguntas por parte de nuestra audiencia, los cuales queremos dirigirle a usted. Por ejemplo, la primera pregunta sería: ¿cómo afecta la situación de precios actual por el conflicto en Ucrania?
Sí, como les comenté antes, el conflicto en Ucrania lo que ha pasado es que ha producido un efecto de sobredemanda, particularmente en algunos países europeos, que gatillaron unos precios que no se habían visto nunca en la historia del GNL, esa es la verdad. Sin embargo, ya esto se está ido calmando. Esperamos que en los próximos meses la calma vuelva a la industria, y particularmente ya se han declarado la construcción de algunos terminales en Alemania, en particular algunos terminales flotantes, básicamente de recepción de GNL, lo cual permitiría efectivamente que la oferta y la demanda vuelvan a un equilibrio como el que teníamos hasta hace algunos meses atrás, y por lo tanto deberíamos estar alcanzando una condición de pricing razonable, que es lo que hemos visto en los últimos años.
Ok, excelente, doctor Oscar, muy bien. La segunda y última pregunta sería, ¿cómo se compatibiliza la opción de hidrógeno verde en transporte marítimo con el gas natural licuado como combustible de transición?
A ver, nosotros creemos que efectivamente cuando los problemas del hidrógeno, y digo los problemas tecnológicos fundamentalmente, de altas presiones, de densidad energética, de costo de producción. Hoy día, por ejemplo, la referencia que tenemos más retail del costo del hidrógeno está en Estados Unidos. En California hay hidrogeneras que están operando, sirviendo estos Toyota que yo comentaba en la charla. Pero el costo del hidrógeno puesto en un auto, en un Toyota Mirai, cuesta, no sé, $100 el millón de BTU. Y el gas, en precios normales, en Japón, que era el gran comprador, o China, debe estar costando en torno a la misma escala, o sea, vale decir, en un auto debe estar costando $18. Entonces la diferencia son 5 veces. Entonces, en la medida en que el hidrógeno verde logre consolidarse como producto y resuelva todos estos desafíos tecnológicos que enfrenta, efectivamente el hidrógeno verde va a ser un combustible. No tenemos ninguna duda de eso. Lo que pasa es que la pregunta es cómo lo hago hoy día para ser carbono neutral y cuánto puede durar esta transición. La transición puede durar 5 años, 20 años, no lo sabemos. Los combustibles tradicionales, los marine gasoil y la gasolina que usamos en nuestros autos, lleva 100 años operando. Y por eso insistimos, la transición no es un periodo que esté definido por reglas, no está escrito en piedra. Puede durar mucho o poco, depende de los desarrollos tecnológicos, de la innovación y de cuán masificado sea efectivamente el mercado. Si el mercado no es grande, es muy difícil. Ya el GNL lo ha vivido, ¿eh? Para serles bien transparente. El GNL ha vivido ese periodo de incorporación a los mercados y la entrada es compleja. Es complejo cambiar camiones a gas, es complejo cambiar carboneras a gas, es complejo cambiar calderas de petróleo pesado a gas, porque hay historia, hay experiencia, hay técnicos especialistas, y uno se empieza a complicar encontrando soluciones que resuelvan estos problemas. Y eso toma tiempo. Al hidrógeno, sin duda, el hidrógeno va a estar, pero va a pasar un tiempo. Y en eso hay que ser muy realista.
Excelente, excelente, doctor Oscar. Para nosotros ha sido definitivamente que de mucho aprendizaje y muy significativo todo el aporte que usted nos ha brindado, por lo que le agradecemos muchísimo por su participación, conocimientos brindados, y en nombre de la Universidad Marítima Internacional de Panamá y el MTCC Latinoamérica queremos presentarle este certificado. Conferencistas de esta tarde, por su excelente intervención y por el apoyo, y decirnos que sí a esta conferencia desde el primer momento que contactamos con AES Panamá, y esperamos pues seguir trabajando en colaboración en nuestros futuros proyectos y conferencias. Muchas gracias, doctor Oscar.
Encantado, Javier, a todos, y a las personas que escribieron en el chat, les voy a contestar directamente en el chat las preguntas que dejaron ahí para que no tengan dudas. Muchas gracias.
Excelente. Saludos, doctor. Muy bien. Continuando con nuestro programa de la conferencia, en el tercer bloque, le voy a dar la palabra a mi colega, el ingeniero Ervin Vargas, para que pueda continuar. Adelante.
Muchas gracias, Javier, por permitirme el paso. Bien, a continuación presentaremos a nuestro siguiente expositor, que es un placer y un orgullo poder contar con un expositor a nivel internacional, como lo es el capitán Jorge de la Fuente Manrique, en representación de Directemar Chile. Vamos a presentar una pequeña biografía del capitán. En el año 2002 ingresa a la Escuela Naval Arturo Prat de Chile, egresando con el grado de Guardia Marina en diciembre de 2005. En el año 2010 obtiene el título de Ingeniero de Administración Marítima, otorgado por la Academia Politécnica Naval de la Armada de Chile. Posee el título de Ingeniero Naval en menciones en Arquitectura Naval y Máquinas Marinas. otorgado por la Universidad Austral de Chile. Ha efectuado diferentes cursos como inspector del estado de abanderamiento, curso avanzado MARPOL, curso de Código Internacional para los buques que operan en aguas polares, curso de inspector del estado rector del puerto. De igual manera se desempeñó como oficial del Departamento de Seguridad y Operaciones Marítimas de la Capitanía de Puerto de Valparaíso. Jefe del Departamento de Inspecciones Marítimas de Estado de Abanderamiento de la Gobernación Marítima de Talcahuano. En el 2018 a la fecha se desempeñó como jefe del Departamento de Inspecciones Marítimas de la Gobernación Marítima de Puerto Montt. 2020 y 2021 integra el grupo de trabajo de la Organización Marítima Internacional para el desarrollo de directrices para la reducción de la intensidad de carbono. De igual manera, integra el grupo de la OMI, del Steering Committee, para la evaluación del impacto de los estados de las medidas de corto plazo para reducir los gases de efecto invernadero. Actualmente ha escrito varios documentos sobre temas técnicos, para los diferentes comités y subcomités de la OMI. Participó en los programas de eficiencia energética de la OMI, como podemos mencionar, UMIP, y también algunos como expositor de las conferencias internacionales que ha desarrollado el MTCC Latin America. Y actualmente asesora al Ministerio de Relaciones Exteriores de Chile en materias de eficiencia energética de los buques. Para nosotros es un placer poder presentarles al capitán Jorge de la Fuente Manríquez con el título Estrategia Nacional de Chile sobre el hidrógeno verde.
Bueno, Erwin, muchas gracias por la presentación. Sin duda que para mí también es un placer poder participar nuevamente en una conferencia organizada por ustedes que sin duda que aportan a la cooperación técnica nacional, internacional, latinoamericana y de todos quienes participamos constantemente en esto. Así que te agradezco mucho las palabras, agradezco también la organización, que he visto las presentaciones durante todo el día y han sido excelentes. Sin duda que dejan mucho que aprender todavía y permiten ver a cada país y a cada participante hacia dónde va nuestro futuro, hacia dónde va el transporte marítimo y, como decimos los marinos, hacia dónde llama la cadena. Así que te agradezco mucho esas palabras y voy a continuar con mi exposición.
Sí, gracias a usted, capitán. Así que, ¿puede compartir pantalla?
¿Se ve la presentación?
Correctamente, está compartiendo pantalla, así que el piso de la presentación es de usted. A la orden.
Muchas gracias, muchas gracias. Bueno, muy buenas tardes a todos. En Chile son un poco pasadas las 15 horas del día, ya media tarde. La presentación que voy a hacer a continuación tiene que ver con la estrategia nacional de mi país, de Chile, relacionada con el hidrógeno verde. Cómo Chile está planificando el futuro del hidrógeno verde y cómo proyecta este futuro en base a las exportaciones y también al uso de este combustible del futuro, este combustible por los próximos 25 o 30 años. Para esto voy a desarrollar la presentación en base a la siguiente agenda. Son 4 puntos básicamente. Primero voy a hablar por qué existe una estrategia en Chile relacionada con el hidrógeno verde, cuál es el fin de esto, por qué hoy día el hidrógeno verde es tan importante, por qué el momento y el protagonismo del hidrógeno verde es considerado como algo de ahora y no de varios años más, sino que tiene que ser ahora para nuestro país. Cómo se implementará y finalmente algunas conclusiones relacionadas con los mismos temas. Bueno, pero para iniciar yo tengo que comentarles que nuestro país tiene una estrategia de hidrógeno verde que ha sido desarrollada dentro de los últimos años, pero que tiene que ver mucho con el compromiso que adquirió nuestro país con la disminución de los gases de efecto invernadero. Sin duda, el cambio climático es algo que nos está afectando a todos. Yo creo que ningún país tiene duda de eso y hay países, por supuesto, que tienen impactos mucho más altos y así se ha analizado en los últimos años, pero el compromiso es generalizado. O sea, todos los países están en esta línea, las universidades que estudian constantemente este tema también van en esta línea. Y Chile, por supuesto, que dentro de sus compromisos se incluye la disminución y ojalá lograr frenar el cambio climático mediante la disminución de gases de efecto invernadero. De manera de hacer o de cumplir esta estrategia, de cumplir este objetivo, Chile ha definido un desarrollo sostenible en el tiempo que permita desarrollar este combustible, desarrollar esta energía o desarrollar esta fuente de energía de manera sostenible y sustentable. Para poder argumentar bien lo que les estoy comentando, tengo que mencionar primero que el calentamiento global, de acuerdo a las últimas estimaciones hechas por distintos científicos, está alcanzando niveles que antes no había tenido. Hay un calentamiento global muy acelerado que si no se frena o no se mitiga ahora, o en los próximos 5 años o 10 años, definitivamente nos va a llevar a alcanzar niveles de temperaturas que no hemos visto antes y que por supuesto que perjudicarán mucho las economías del país, y no solamente las economías, sino que la vida en general. De esta manera, podemos entender que existen varios escenarios en los cuales se considera la disminución de emisiones. Por ejemplo, podemos ver que si no se toman medidas o no se reducen las emisiones antes del 2030, definitivamente podríamos alcanzar los 2 grados Celsius de calentamiento global que afectaría enormemente al mundo. Pero también existen escenarios más positivos o más favorables. Es tanto así que se estima que si las emisiones globales de CO2 llegan a cero el año 2055, podríamos llegar o alcanzar esta necesidad o este máximo de 1,5 grados Celsius de calentamiento global, que es aproximadamente hacia donde va la tendencia mundial. Además, es importante conocer y saber que las emisiones globales de gases de efecto invernadero son distintas por sector, siendo el sector energético, que incluye el transporte, vivienda, otros tipos comerciales, etcétera, supera el 70% de la producción de gases de efecto invernadero. Por otra parte, también tenemos la agricultura, por ejemplo, con un 18%, y bueno, y cada factor energético del mundo se puede ver reflejado en este gráfico. Por lo tanto, entendemos que la energía hoy día, siendo el factor más relevante o el que abarca la mayor torta de producción de gases de efecto invernadero, es el que hay que enfrentar. Y una forma de hacerlo es mediante el hidrógeno verde. Este desarrollo sostenible que les comenté un par de diapositivas antes de esta, se va a basar básicamente para nuestro país en la utilización de 3 tipos de energía, pero siempre considerando que son energías verdes. La primera, y que está bastante desarrollada en el norte de nuestro país, es la energía solar, mediante estos campos fotovoltaicos que hoy día abastecen principalmente de energía a la industria de la gran minería, que es nuestro factor principal económico en el país. Por otra parte, se han desarrollado bastantes campos eólicos con la instalación de estos aerogeneradores en el sur del país, bueno, y también a lo largo de toda nuestra angosta y larga faja de tierra. Es tanto así que los proyectos hoy día están apuntando a la instalación y el aprovechamiento de vientos desde el sur o de la zona de Magallanes, que nosotros denominamos, y que está ubicada en el sur austral de nuestro país. Y por otra parte, yo creo que en una menor medida, pero no por eso menos estudiada, hoy día se está trabajando bastante en el estudio y desarrollo de la energía mareomotriz y su utilización para el abastecimiento de las distintas industrias. Ya, esto yo lo comento porque, sin duda, siendo un país eminentemente marítimo, con más de 4.000 kilómetros de costa, no es raro que se desarrolle este tipo de energía y este tipo de tecnología. ¿Ya? Así que está bastante de moda, por decirlo de alguna forma, está siendo bien estudiada a nivel educacional, universidades y otras industrias que están aprovechando estos conocimientos. ¿Qué es lo que pasa hoy día? Bueno, hoy día sin duda que el hidrógeno no es algo nuevo. El hidrógeno usado como combustible es un tipo de combustible que proviene o se genera a través de combustibles fósiles. Por lo tanto, hoy día el hidrógeno que existe se le denomina de alguna forma hidrógeno gris, porque sin duda que el hidrógeno como tal, al momento de la combustión, no genera gases de efecto invernadero. Su generación o su separación o la electrólisis principalmente sí lo genera. ¿Por qué? Porque se usan combustibles fósiles para poder abastecer aquellas industrias que producen hidrógeno. De manera que hoy día el hidrógeno que conocemos corresponde más bien a un hidrógeno gris. Esto es lo que se debe yo creo que la tendencia va a limitarlo. Si queremos disminuir los gases de efecto invernadero, frenar el cambio climático, necesitamos, entre otras cosas, utilizar menos combustibles fósiles. De manera que hoy día la base de generación del hidrógeno verde es mediante energías eléctricas renovables. Y para eso están estas que les mencionaba, la energía fotovoltaica, la energía eólica y por supuesto que la mareomotriz. Entre otras. Yo estas tres las menciono porque son las que conocemos que por lo menos en Chile ya han tenido bastante desarrollo y que se usan actualmente. Para poder establecer esta estrategia y entender hacia dónde podemos llevarla, fue necesario analizar el potencial de la descarbonización mediante el hidrógeno verde. O sea, entendiendo que el hidrógeno verde es un factor fundamental para la descarbonización, podemos analizar que existe un potencial tremendamente elevado o grande mediante su generación, partiendo por supuesto por energía eléctrica limpia, con la generación de este hidrógeno verde en base a electrólisis, podemos abastecer y suministrar energía y combustible a distintos tipos de industria, incluida por supuesto el transporte, que es lo que podríamos asociar con nuestro buque, con nuestro común y constante transporte marítimo. A mí me pareció muy interesante la exposición que hizo mi compatriota anteriormente, porque sin duda que lo que él comentaba tiene total razón en cuanto a que falta mucho todavía por desarrollar en cuanto a tecnologías de hidrógeno verde, pero sin duda que la tendencia va para allá. O sea, hoy día la OMI lo está discutiendo bastante, se entiende que es poco lo que conocemos, pero sí que urge la necesidad de desarrollarlo de manera rápida, de manera segura y también de una manera sustentable. Y por eso Chile creó una estrategia, porque Chile entendió esto, entiende que la tendencia no puede estar ajena a nuestro país y que el hidrógeno verde puede ser producido en Chile gracias a varias condiciones naturales que nos permiten lograr un hidrógeno verde mucho más barato, mucho más... no sé si fácil es la palabra, pero mucho más simple de generar, ¿ya? Por eso podemos decir que el momento del hidrógeno verde es ahora. Se nos juntaron varios factores. El hidrógeno verde creemos que es un protagonista para la descarbonización del mundo. Y nuestra estrategia así lo analizó y así lo va a utilizar. Distintos países tienen políticas e iniciativas públicas de apoyo al hidrógeno. No solamente Chile, por supuesto, en Latinoamérica hay varios países. Este es un gráfico que podemos analizar, que es del año 2020, y que muestra, por ejemplo, Australia, que tiene una estrategia disponible. Uno la puede buscar en Internet, analizar y leer. Chile también la tiene. Hay otros países que definitivamente no lo tienen evaluado aún o que están en vías de este desarrollo. Pero en la práctica, hasta marzo de este año al menos, existían 376 proyectos anunciados, de los cuales 146 iban dirigidos al uso industrial a gran escala, como por ejemplo refinería, desarrollo de amoníaco, electricidad, metanol, etc. 100 de ellos también están relacionados con el transporte, para distintos tipos de transporte, trenes, buques, camiones, etc. Otros 60 tienen relación con la economía de hidrógeno verde integrada. ¿A qué se refiere esto? Bueno, a la multiindustria y proyectos con distintos tipos de usos finales. Por otra parte, hay 32 proyectos relacionados con la producción a gran escala, con hidrógeno, electrolizadores para hidrógeno verde, mayores a 1 gigawatt, por ejemplo, y otros proyectos. Y además de 38 proyectos de infraestructura que se relacionan directamente con el hidrógeno verde. Entonces, vemos que cada país está tomando mayor relevancia y está tomando en cuenta el hidrógeno como un factor relevante no tan solo para el cambio climático, sino que además para otros tipos de industria. Y nosotros queremos ser parte de eso y por eso nuestra estrategia está diseñada de esa forma. Además, bueno, de alguna forma esto tiene que ser viable, es decir, no podemos nosotros crear una estrategia si no creemos que el fin que queremos alcanzar no incluya la viabilidad, de manera que la demanda global de energía suministrada con hidrógeno fue analizada, por lo menos desde el año 2015 hacia el año 2050, y nos indica que para los distintos tipos de requerimientos, tanto de generación, de almacenamiento, como transporte, industria, otros usos, etc., para el año 2050 alcanzaría los 22 petawatts. ¿Ya? Y nuestro país tiene considerado abastecer el 13% de esta demanda mundial. Esa es la proyección, esa es la ambición que tiene nuestra estrategia. Entonces, para eso, por supuesto, hay que trabajar bastante, hay que hacer varios cambios, hay que crear una política, etcétera, y eso es lo que nuestro país ha desarrollado con distintos actores, tanto públicos como privados, porque sin duda que la combinación de ambos es urgente y necesaria y prioritaria para alcanzar lo que estamos buscando. También se analizó el costo actual, porque efectivamente hoy día generar hidrógeno y además de generarlo, el requerimiento de transporte, el uso, etcétera, es carísimo, tiene un costo muy elevado. Pero sí se proyecta que las matrices energéticas y economías del mundo, gracias a que buscan lucir más verdes a futuro, se proyecta que a futuro y de aquí al año 2050 existirá una disminución proyectada de los costos de energía renovable y electrólisis. Esto, sumado por supuesto a la necesidad de descarbonizar todos los sectores de las economías, impulsarán un mercado global del hidrógeno verde y sus derivados que fomentará los proyectos, que fomentará la exportación, que fomentará el uso de hidrógeno verde en las distintas industrias. Se proyecta, o de acuerdo a las proyecciones que tiene nuestro país para su estrategia, se proyecta que el mercado de exportación alcanzará los 300 billones de dólares. Y ya en el 2050 se habrá disminuido el costo de electrolizar en un 80%. O sea, la proyección es bastante positiva, es un escenario muy positivo y se espera que así sea. Por otra parte, ¿por qué Chile, además de viendo los números de costos y números de proyecciones, Chile estima que el momento del desarrollo de esta tecnología es ahora? Porque nuestro país, que es una larga, como les comentaba, una larga y angosta faja de tierra, tiene mucha potencialidad en base a los distintos climas que tiene y a las distintas condiciones geográficas y oceanográficas que tiene. Por ejemplo, no se estima, esto fue calculado, se entiende que Chile cuenta con más de 509 gigawatts de concentración solar de potencia. Podemos ver una imagen acá de una planta de energía solar que está ubicada en el norte de Chile, en el desierto, donde la radiación es muy alta, por lo tanto se aprovecha muy bien, y esta energía que se produce acá es la que aporta la mayor parte de sus condiciones para la gran minería, del cobre específicamente y mayormente. Por otra parte, nuestra capacidad en gigawatt de energía solar fotovoltaica es superior a los 1180 gigawatts. La energía eólica, por ejemplo, también alcanza y se estima que supera los 191 gigawatts en cuanto a energía onshore, porque también tenemos y podríamos usar y podríamos analizar lo que pasa offshore o lo que pasa en el mar. Sin duda que eso también es algo que se está desarrollando y que se está estudiando, pero hoy día lo que se calcula y lo que se está proyectando es para energía eólica con base en tierra. Finalmente, nuestra potencialidad supera los 1.800 gigawatts. La energía renovable, sin duda que para nosotros es fundamental y equivale, analizando solamente nuestra capacidad o nuestro potencial, equivale a 70 veces lo que Chile demanda. Nuestro país es un país pequeño, alcanzamos los 18 millones de personas o más, pero siendo un país pequeño, la verdad que no nos sobra todavía, pero se espera que a futuro este exceso de energía o este exceso de potencial pueda ser compartido con el resto del mundo. Un ejemplo de esto es la energía solar fotovoltaica, donde Chile en los últimos 6 años ha duplicado su capacidad de generación. Como les comentaba, y lo que muestra esta foto, es que estas instalaciones han abastecido los suministros requeridos por la gran minería, que tienen un factor preponderante para nuestra economía. Y por supuesto que el costo energético que tienen ellos también es muy alto. En cuanto al costo nivelado de electricidad renovable, también se estima que haya una disminución a lo largo del tiempo. Las estimaciones actuales solamente alcanzan el año 2050, pero analizan el mediano y el corto, mediano y largo plazo, entendiendo largo plazo como el año 2050, donde se dividió esta potencialidad en los distintos sectores, en 3 regiones del país, en el norte, el centro y sur, y en todos los casos hay una disminución constante. Sin embargo, en la región sur, que se instalarían plantas eólicas, la disminución no sería tan decreciente, pero sin duda que habría una disminución para el año 2050. No así en el centro y no así en el norte, donde la disminución se ve un poquito más, la curva se ve un poquito más en mayor decrecimiento. Por otra parte, Chile concentra la radiación solar más alta del planeta, por lo tanto es un factor que nos permite potenciar nuestras capacidades y que también llama a los distintos inversores, a inversionistas, perdón, a poder involucrarse en esto y ser parte de este proyecto. Los vientos del extremo sur, en el otro caso de Chile, de nuestro extremo sur austral, tienen la misma intensidad en tierra y en mar adentro. Y eso es un factor bastante simplificador, porque ha hecho que las tecnologías que se usan hoy día en la actualidad en distintos países puedan ser aplicadas en el sur sin problema. De manera que tener el costo de tener, por ejemplo, un aerogenerador instalado en el mar es más alto que tenerlo en tierra, por lo tanto, eso también haría que los costos se mantengan bajos o relativamente accesibles. Pero ¿qué pasa con el hidrógeno? Pero el costo nivelado de hidrógeno se proyecta también que tenga un decrecimiento desde aquí hasta el año 2050, partiendo del año 2025, porque las proyecciones se consideran a contar de ese año, considerando que ahí ya se espera tener, de acuerdo a las etapas que les voy a mostrar a continuación, se espera tener esta producción que buscamos. Bueno, entendiendo esto, podemos decir que la producción o el costo nivelado de este hidrógeno verde va a ir en constante disminución. Partiendo, por ejemplo, en la zona norte con un costo de $2 por kilogramo producido, hasta el año 2025 a un 0,8 para el año 2050. Esas son las proyecciones que se tienen. Y el potencial, con un potencial final de producción de hidrógeno verde de 160 megatoneladas por año. Esa es la estimación final. El hidrógeno verde que se produce hoy día en el desierto de Atacama y que se producirá y que está en desarrollo en la región de Magallanes de nuestro país, tendría un costo nivelado de producción más bajo del mundo. Eso es lo que se busca, es lo que se está proyectando. Y las comparaciones se hicieron con países del Medio Oriente, con países europeos, con Estados Unidos, donde las tecnologías, por supuesto, que son mayores a las que hoy día encontramos acá. Sin embargo, la calidad de nuestros recursos renovables hacen posible que podamos tener a futuro un hidrógeno verde más barato. Eso gracias a estas potencialidades que les comentaba. En cuanto a la proyección de mercados chilenos de hidrógeno verde, se espera un crecimiento anual de 15%, si bien en una etapa inicial del año 2025 se espera que la aplicación sea principalmente doméstica, o sea, se busca satisfacer primero al propio país, para en forma posterior y mediante el desarrollo el desarrollo de nuevas tecnologías, mediante el desarrollo de más hidrógeno verde, podamos comenzar la exportación. ¿Para qué? Para que el año 2050, nuestra proyección en base a este crecimiento anual, alcance esta capacidad de exportación necesaria y barata, dentro de lo posible, que nos permita ser los líderes que estamos y abastecer este 13% mundial que les comentaba. El desarrollo proyectado de estas aplicaciones de hidrógeno verde busca o tiene su principal desarrollo en base a tres olas o tres etapas. La primera oleada, que busca abastecer o aportar energía al consumo doméstico de gran escala nuestro, es una oportunidad que tenemos en el corto plazo, ¿ya? Y lo que busca, entre otras cosas, es el reemplazo de amoníaco, por ejemplo, que traemos del extranjero. ¿Y de qué manera se reemplazará? Mediante la producción local. Además se reemplazará el hidrógeno gris utilizado en las refinerías de nuestro país, por ejemplo, que les comentaba anteriormente. Para luego ingresar al negocio del transporte. O sea, la idea es que de aquí al año 2028 se pueda abastecer el transporte de pasajeros y cargas pesadas con hidrógeno verde. En forma posterior, una segunda oleada que se verá más hidrógeno en transporte, ese será uno de los puntos relevantes, y además se iniciarán las exportaciones. Y para continuar con una tercera oleada que busca la apertura a nuevos mercados internacionales, en base a la misma experiencia que se vaya ganando con la segunda oleada, con la exportación, se van a buscar mercados de exportación para ir escalando en esta estrategia. Hoy día, la verdad que hay varias instalaciones de hidrógeno verde que están en desarrollo, pero hoy día nuestra principal o nuestra estrategia está enfocada en el desarrollo de proyectos en el sur de Chile. Ahí, como se puede ver en la imagen, en la región de Magallanes, que tiene vientos muy fuertes, con mucha intensidad. Entonces se entiende que ese tipo de energía es fundamental y no se puede perder. De esta forma, para el año 2024 se busca, ya en 2 años más, se busca producir metanol y gasolina verde a partir de esta energía eólica que les comentaba. Asimismo, el año 2026 se espera que se comience la exportación de amoníaco verde, para posteriormente, el año 2028, producir amoníaco verde en otra planta. Ya también habría competitividad, mejorarían los precios, y para ya el año 2030 tener plantas de producción de amoníaco verde y mediante un parque eólico que hoy día se encuentra en desarrollo en esa zona del país. Ahora, ¿cómo se implementará? Bueno, básicamente nuestra estrategia cuenta con 3 etapas. La primera etapa es una anticipación en la práctica del despliegue de hidrógeno verde en 6 aplicaciones prioritarias para el país. Estas aplicaciones son refinerías, uso en refinerías, desarrollo de amoníaco, uso en camiones mineros, camiones pesados, buses de larga autonomía, inyección en redes de gas también hasta un 20%. Por otra parte, ya en una segunda y tercera etapa, se busca definitivamente tener como principal factor de desarrollo la exportación, y en una etapa 2, por ejemplo, se busca apalancar esta experiencia que se gane mediante la exportación para entrar con fuerza en mercados internacionales. Y acá los mercados internacionales se indican como regiones, ¿ya? Por ejemplo, la exportación de hidrógeno verde en el año 2025 no está considerada, sin embargo, ya en el año 2030 comenzaría, con una baja, por supuesto, cantidad, pero ya para el año 2050 lo que pretende esta estrategia es aportar con un gran número o una gran cantidad de hidrógeno verde para Japón, para Corea y también para Europa. Y por supuesto que si existen otros tipos de mercados donde se pueda entrar con esta estrategia, también serán considerados. Y la ambición es para el año 2025 ser el número 1 en inversiones de hidrógeno verde en Latinoamérica. Que nuestra capacidad en gigawatt de electrólisis construida y en desarrollo alcance un valor de 5, además que podamos tener la capacidad de producir 200 kilotoneladas por año en al menos estos 2 polos de hidrógeno verde que tenemos en Chile, tanto en el norte de nuestro país como en el sur austral. Y para el año 2030 la ambición busca ser el líder exportador global de hidrógeno verde y sus derivados, además que el hidrógeno verde sea el más barato del planeta, con un valor inferior al 1,5 dólares por kilogramo producido, y ser un líder productor global de hidrógeno verde por electrólisis. Pero para alcanzar esto, la estrategia incluye 6 pilares que son fundamentales para este fin. Empezando con una política orientada por misiones, donde el Estado será un facilitador, además de un coordinador e impulsor de la misión de establecer esta nueva industria con esfuerzos multisectoriales. Como les comentaba anteriormente, esta estrategia necesita y requiere esfuerzos públicos y privados. No sacamos nada con tener uno de los dos, porque la estrategia así establece y así indica que es la mejor forma. Por otra parte, habrá un uso equilibrado de recursos y territorio, ¿ya? Y el desarrollo de la industria de hidrógeno será coherente con su entorno social y ambiental. Y esto va de la mano con el compromiso que comenté al principio de esta exposición, que tiene Chile sobre y para frenar este cambio climático. Por otra parte, como nueva economía de exportación limpia, el hidrógeno verde habilitará una nueva economía chilena de exportación basada en energías limpias y productos de baja huella de carbono. En cuanto a una ruta eficiente hacia un país cero emisión, podemos decir que nuestro país está comprometido en la transición a la carbono neutralidad. Y creemos que el hidrógeno verde tiene un rol protagónico en esto, y así fue planteado inicialmente. Por otra parte, el hidrógeno verde como motor de desarrollo local establece o nos permitiría que todos estos proyectos de la industria de este combustible limpio generen polos de inversión, de innovación y de actividad local. Y como último pilar, no podemos decir que la apertura internacional que desarrollará la economía del hidrógeno verde nacional y global será a una velocidad o tendrá una velocidad que es la que el planeta requiere para alcanzar esta descarbonización o carbono neutralidad. Finalmente, y para concluir, quisiera señalar que Chile está comprometido con la descarbonización del mundo. ¿Ya? Eso es algo indudable, y creo que cada país también así lo tiene dentro de su estrategia. No creo que ningún país esté en contra de esto. Sabemos que es algo que nos va a afectar a todos y por supuesto que a nuestras generaciones venideras. Los proyectos de desarrollo buscan ser sustentables y sostenibles en el tiempo, utilizando las energías que la naturaleza nos da, que la naturaleza nos entrega de la forma más eficiente y eficaz posible. Y por último, la política nacional integra y combina el accionar público y privado para sumar a esta eficiencia y a esta eficacia los factores requeridos para el logro del objetivo y de esta estrategia de hidrógeno verde nacional. Agradezco mucho su participación, espero que haya sido una exposición interesante y por supuesto que quedo abierto a cualquier pregunta que tenga.
Ingeniero, tiene el micrófono apagado. Aún no se le escucha. Estamos confrontando unos pequeños problemitas técnicos. Vamos a esperar que se conecte nuevamente el ingeniero, el profesor Javier Díaz.
Sí, ¿me escuchan? Sí,
se le escucha.
Unos pequeños problemitas técnicos, pero excelente presentación. Capitán Jorge de la Fuente siempre participando con nosotros a bordo de nuestras actividades de capacitación y como usted bien lo mencionaba, importante no solamente para a nivel nacional, regional, sino es un tema de importancia global que nosotros estamos abordando el día de hoy en esta tarde. Bien, en nombre de la Universidad Marítima Internacional de Panamá y del MTCC Latin America, queremos agradecerle por siempre su participación, su disposición de estar con nosotros y le presentamos este certificado como uno de nuestros conferencistas especiales de esta tarde tocando este tema de la política nacional de hidrógeno verde en Chile. Muchas gracias, capitán Jorge, y bueno, cualquier pregunta adicional, el capitán está dispuesto a contestarla allí en el chat mientras estemos conectados. Muchas gracias, capitán, y un gusto tenerlo, y esperamos seguir contando con la participación de Directemar y de ustedes en todas nuestras actividades. Muchas gracias.
Muchísimas gracias a ustedes y felicitaciones por esta iniciativa.
Saludos, capitán. Dando continuación a nuestro programa de esta tarde, En esta ocasión, pues, nuestro último exponente tendrá la posibilidad tenemos la posibilidad de cerrar con un expositor también que consideramos de la casa y que siempre está dándonos su gran aporte y contribución a todos los proyectos que desarrollamos en el MTCC. El licenciado Alexis Rodríguez Almanza inició su carrera como marino ordinario en buques de servicio internacional, abogado de profesión, obtuvo su título de licenciatura en Derecho y Ciencias Políticas en la Universidad de Santa María la Antigua, recibiendo los honores de magna cum laude. Posee estudios superiores en Derecho Marítimo, Administración Marítima Portuaria, Gestión Ambiental y Puertos y Carbono Neutral por la Universidad EARTH, Universidad Deusto Bilbao y Universidad Santa María la Antigua, recibiendo también honores de summa cum laude. Asimismo, posee un máster en Business Administration del INCAE Business School y un posgrado de Energía Marítima de la Universidad Marítima Mundial, el World Maritime University. Se ha desempeñado como docente a nivel de maestría en la Universidad Santa María la Antigua, en áreas de convenios internacionales, disertando sobre temas marítimos, contaminación y cambio climático. También ha sido profesor en la Universidad Sergio Arboleda en Santa Marta, Colombia. En el sector público, laboró en la Autoridad Marítima de Panamá como jefe de control de cumplimiento y en la Autoridad Nacional de Ambiente como jefe encargado de la Oficina de Asuntos Internacionales. Ha laborado en organizaciones no gubernamentales como Fundación Mar Viva, enfocada en la conservación ambiental, y ha participado como expositor y moderador en conferencias internacionales sobre temas relativos al sector ambiental y marítimo. Actualmente como especialista en protección ambiental en la Autoridad del Canal de Panamá, quien busca fortalecer las políticas ambientales de la organización a fin de impulsar la ruta del Canal de Panamá como una ruta verde para el comercio marítimo internacional. Tenemos el honor de contar esta tarde con Alexis Rodríguez del Canal de Panamá, quien nos va a hablar sobre el tema de Panama Canal Green Connection Environmental Recognition Program.
Buenas tardes a todos. Wow, después de todo, desde la mañana que están en esta conferencia, ¿qué puedo decirles yo? Y que vamos a ver cómo hacemos algo interesante estos 15 minutos que quedan y de tema de cierre. Y vamos a ir explicándole un poco la visión que tenemos en el Canal de Panamá, pero principalmente parte de la experiencia ahí que hemos ido ganando como país durante los últimos periodos. Así que vamos a tratar de conversar brevemente y cumplir con el tiempo para que podamos irnos todos tranquilos. Ok, perfecto. Mire, hoy vamos a conversar un poco sobre básicamente lo que llamamos las acciones climáticas de transporte marítimo internacional. Y algunos de esos mitos, retos y demás que tenemos en la parte del combustible. El combustible, como bien lo he mencionado anteriormente, es uno de los eslabones, digamos, que existen en las metas globales desde la perspectiva del cambio climático, la perspectiva de eficiencia y demás. Entonces, cuando hablamos de un marco conceptual, digamos, de cuáles son las formas de reducir emisiones, y que cuando hablamos de emisiones todas, de emisiones de gases contaminantes como emisiones de gases de efecto invernadero y demás, y más bien las reguladas, porque aquí quiero explicar un poquito de esta parte, tenemos en cuenta que existen diferentes formas. La primera forma es que la más efectiva, la que, por ejemplo, rompe el business as usual, es eficiencia, ¿no? Entonces tenemos muchas de estas medidas de eficiencia cuando hablamos de las primeras regulaciones, particularmente del anexo sexto de Marpol, capítulo cuarto, la regla 18, 19, 20 en adelante, y justamente estas reglas comienzan a tener, digamos, alguna incidencia posteriormente a su entrada en vigor en el año 2013. Y de ahí es como dicen, es el inicio desde el punto de vista de la implementación de eficiencia y medidas regulatorias que han ido entrando, como el Energy Efficiency Index, Design Index, después entró el CEMP, Ship Energy Management Plan, o el Plan de Manejo de Eficiencia del Buque. Posteriormente comenzaron a entrar la evolución o las fases del EEDI, hasta la entrada o la mezcla, digámoslo así, en el año 2020, justamente, cuando en el 2018 se toma la decisión de dos aspectos importantes. Primero, la estrategia de la Organización Marítima Internacional sobre reducción de emisiones, que debe ser revisada para el año 2023, y justamente la decisión que estaba postergada, que era la modificación de la regla 14 del anexo cuarto del anexo sexto de Marpol, capítulo cuarto, particularmente sobre capítulo tercero, disculpe, que era particularmente sobre el azufre, en donde se toma la decisión en el 2018, la modificación de la regla 18, que dice que para el fuel availability, en base al estudio que se realizó en la Organización Marítima, tendría que el IMO 2020 ser en el 2020. Y por eso es que se le puso la palabra IMO 2020, porque no se sabía ni siquiera cuándo tenía que ser. Justamente era una decisión que tenía que darse posteriormente un estudio. Entonces, tenemos ahí dos breaking points en esta parte, el tema de eficiencia y el tema de combustible. La parte de eficiencia, digamos, y esto es un poquito la historia, para ver cómo llegamos al combustible, es cuando justamente se da la situación que en el año 2013, cuando entra este capítulo cuarto, las embarcaciones comenzaron a diseñarse con puesta en quilla de 2013 o en adelante, le aplicaba la norma EEDI. Y se comenzó a ver dos particularidades primero. Los buques de nueva construcción se estaban diseñando con un EEDI por encima del 40, 50, 60% del require. El require es lo que te pide la regla que tuviese que tener el barco. Y el segundo tema era que, a diferencia del ISM, el Código de Gestión de Seguridad, el CEMP, o el manual Ship Energy Efficiency Management Plan, no tenía un método coercitivo. Y comienzan a darse estas tendencias de que uno de los puntos principales de la eficiencia es el continuous improvement. O sea, que mejoras un año, sigues mejorando, sigues mejorando, sigues mejorando. Esto generó justamente una tendencia, la tendencia, digamos, del otro lado, que es el combustible. ¿Por qué? Porque justamente, como lo mencioné, tú puedes eliminar emisiones por eficiencia, o sea, reducción del consumo, o por la fuente. Entonces comenzó esta tendencia de la fuente. Todo el mundo en el año 2018-2019 pensábamos que el mundo generalmente iba a haber complicaciones, fuel availability, o complicaciones desde el punto de vista de especificaciones de combustible, etcétera, etcétera. Bueno, no pasó. Pero justamente eso fue la punta de lanza de darse cuenta, los armadores particularmente, que hay drivers o hay indicadores de gestión en una operación de un buque que no deben ser los dependientes de ese costo, no deben indicarte el costo mayor. Y uno de los temas que del 2018 hacia acá fue el tema del combustible. El combustible, esa transición se dio y casi, o sea, todo el mundo lo pensaba, se iba a parar la flota mundial por el tema de IMO 2020. Al final nunca pasó. Pero dio un buen mensaje justamente de toda la evolución de estos combustibles que hemos ido viendo hoy. Importante porque al final se complementan combustibles alternativos de corto plazo, combustibles más a mediano y largo plazo hacia el futuro, pero todo bajo el paraguas de la Organización Marítima Internacional. ¿Qué pasa hoy? Estamos hablando un poco del tema de la historia y quizás me robo estos minutos para hacer esa cronología, digamos, conceptual, porque todo tiene una causa raíz, una razón de ser. Hoy en día, cuando comenzamos entonces a hablar de combustible, es la fase 2 casi de lo que hablaba de la estrategia de emisiones de la Organización Marítima, que justamente los que conocen y los que no conocen el sistema, cómo funciona la Organización Marítima Internacional aquí presente, saben, les indico que el proceso regulatorio puede demorar de 1 hasta 5 años, justamente que entre o que se modifique una resolución o una nueva regulación que aplica a las embarcaciones, y teniendo en cuenta que aplicará en la mayoría de los casos a nuevas construcciones y que la fase anterior, por ejemplo, que se aplica a buques ya existentes, en materia de emisiones es muy complicada, y le puedo mencionar, por ejemplo, la enmienda que entra el próximo año, el 1 de enero del 2023, que es el EEXI, que es Energy Efficiency for Existing Vessels and Carbon Intensity Index, que van a ser algo revolucionario desde el punto de vista de medición de combustible, etc. Pero no es la materia de hoy. Pero es importante porque al conocer la causa raíz y la génesis, nosotros vamos a entender la rapidez y la evolución que ha ido este sector marítimo, digamos, que nos ha llevado a esta disyuntiva de qué tipo de combustible es, cuál es el mejor, cuál puede ser y cómo puede ser. Entonces, esta discusión, que o por lo menos conversatorios que tenemos hoy en Panamá o regional, no son los mismos conversatorios que se tienen, por ejemplo, en los países nórdicos, en Asia, en Europa. Son totalmente diferentes. Las perspectivas, la visión, la infraestructura va, digamos, diferente. Lo que se habla, por ejemplo, en Estados Unidos también es un poco diferente a estas áreas, y todo tiene que ver con un tema geopolítico desde el punto de vista de la implementación de las normativas. Culminando este marco conceptual, esta idea de por qué hoy estamos hablando de esto, es muy importante que tengamos en cuenta cuál va a ser el futuro de estas conversaciones, porque hoy en día estamos hablando de combustible, hablábamos de eficiencia y de operacional hace varios años. Bueno, los próximos diálogos y conversaciones serán sobre el mercado de carbono, sobre los mercados, cómo se va a comportar el mercado y demás. Entonces, siendo esto, quisiera explicarle un poquito cómo vemos nosotros la perspectiva de estas acciones climáticas y el transporte marítimo sostenible. Ya no como de una perspectiva de flag state, porque no lo somos, pero sí como uno de esos actores dentro de esa cadena de valor que justamente, independientemente cualquiera sea el combustible, cualquiera medida de eficiencia, y que no estamos regulados bajo la Organización Marítima, vamos a hacer ese canal, digamos, que funcione o no funcione, y cuando digo canal es ese paso de situaciones coyunturales que son necesarias para la operación de un buque. Y ahora es justamente cómo vamos a ir identificando esas medidas de independientemente del combustible. Así que la perspectiva que van a ver hoy es una visión de valor a cualquiera, promoviendo cualquiera de esos combustibles dentro de las fases que se va a acomodar y demás. Teniendo algo muy importante, que el movimiento que tiene la Organización Marítima Internacional es muy diferente a los movimientos, digamos, que están promoviendo la industria actualmente. Y eso es importante que lo identifiquemos, porque si, como le expliqué, la evolución regulatoria desde un subcomité, comité, subcomité, nuevamente el comité que se aprueba, que ahora con el tema virtual, etcétera, etcétera, estamos hablando de un promedio de 5 años, la industria está tomando decisiones a otra manera. Y esa es parte de la identificación que tenemos que tener en cuenta, porque nos va a hacer evolucionar la necesidad de acomodarnos a un mercado de oferta y demanda, pero particularmente en bienes y servicios que brindamos. El cambio climático justamente es una situación que que básicamente vamos a hablar de cuáles: SOx, combustible, NOx y CO2. Principalmente uno viene de la máquina, el otro viene de la fuente y el otro es generalmente el proceso integral del consumo. Y nuestro transporte marítimo internacional representa en la actualidad un 80% más de un 80% del transporte global de la mercadería. que mínimamente es un 3% de las emisiones aproximadamente según el cuarto estudio de la Organización Marítima Internacional. Y esto hago hincapié muy importante, a una estrategia global por parte de la Organización Marítima en una reducción de 50% de las emisiones totales anuales en base a la línea base del 2008 para el 2050 y un 40% de la intensidad de carbono del 2030 en base a la línea base del 2008, teniendo en cuenta que estas son, y vuelvo lo menciono, las metas establecidas en la Organización Marítima Internacional. Sin embargo, hay temas importantes que este año celebramos, que año de pandemia, años difíciles, no tenemos en cuenta. Este año se celebran las nuevas tecnologías para un transporte marítimo más ecológico. Es el lema de la Organización Marítima Internacional. Pero bueno, diferentes eventos exógenos han, digamos, cambiado un poco esta perspectiva. Quiero aterrizar conceptualmente en algunos aspectos. Cuando hablamos del tema de combustibles, de sostenibilidad y demás, tenemos que tener en cuenta qué es la sostenibilidad. Porque muchas veces los conceptos son utilizados en cómo nos conviene y a veces hay que ir a la causa raíz o digamos etimológicamente qué significa para poder entrar digamos a esa fase. Entonces tenemos que el desarrollo sostenible según las Naciones Unidas es las preocupaciones ambientales junto con un desarrollo económico. Y es que no hay nada, y esto yo siempre lo he mencionado en la experiencia que he tenido, es en la parte ambiental, siempre lo digo en la UMIP, por ejemplo, no hay nada que llegue al límite desde el punto de vista del MPC, Comité de Protección del Medio Marino, hasta que toque el MCC. Y ya desde el punto que toque el tema del Safety Committee, que es el tema de seguridad marítima, ya se acabó el tema marítimo. O sea, y poniéndoselo un ejemplo muy suave, puedo ponerle la eficiencia más grande al casco, pero si el casco llega al thickness que me compromete la navegación y la seguridad marítima, olvidémonos de la eficiencia. Entonces esto es un tema integral. Entonces no podemos hablar de aspectos ambientales si no vemos tampoco lo relacionamos con un desarrollo económico, viceversa. Entonces ya esta perspectiva ambiental nos quitamos el casco verde y nos ponemos la chaqueta y decimos entonces comencemos a hablar desde el punto de vista económico. Y les voy a explicar un poco por qué de más adelante. Pero básicamente lo que es importante de todas estas medidas es identificar este desarrollo actual que necesitamos hoy sin comprometer el futuro. Y muchas veces, en varios de los diálogos internacionales de lo que he tenido la experiencia es, y viceversa, pensamos en el pasado, qué se hizo anteriormente y después queremos pensar en el futuro, teniendo en cuenta que el futuro es cercano. Entonces, ya sabiendo qué es sostenibilidad, entonces ya podemos hablar de long-term sustainability desde el punto de vista integral. Cuando ya conocemos la parte de sostenibilidad, entonces tenemos que identificar, y esto es una de las cosas, me ha encantado este trabajo hace más de 15 años, vengo realizando, me ha encantado identificación de los actores y las normas. Si bien me encanta el mar, uno de los puntos interesantes es el tema de las normativas, es que si no conocemos los convenios, tenemos problemas. Y aquí es donde viene la diferencia entre ser ingeniero, abogado, licenciado, capitán, lo que sea. Y muchos que me conocen saben que a mí no me gusta ni siquiera usar ningún título. ¿Por qué? Porque la importancia es cómo nosotros vayamos identificando este tema de sostenibilidad y podemos ir avanzando en el tema ya de qué combustible es el que necesitamos. Si yo no tengo una estrategia a corto, mediano y largo plazo de mi modelo de negocio, ni siquiera puedo saber cuál es el combustible que voy a utilizar, porque hay combustibles, como bien han visto hoy, combustibles A de transición, combustibles a futuro. Entonces, ¿cuál utilizo? Pues, try the coin, no lo sabemos. Pero si tenemos en cuenta cómo se van comportando las regulaciones en diferentes aspectos, principalmente Objetivos de Desarrollo Sostenible, Conferencia de Cambio Climático, la Organización Marítima Internacional y algo que muy poco la parte marítima, hasta recientemente las discusiones que han mencionado, que es el tema de los impactos de los estados en tema de desarrollo, es el tema de la Conferencia de las Naciones Unidas para el Comercio y Desarrollo, porque todos los noviembre, octubre, todo el mundo está pendiente de lo que se llama el Review of Maritime Transport, cómo se ha comportado la industria marítima. Entonces, hoy en día nos hemos percatado que para poder hablar de cualquiera de las iniciativas de hoy, tenemos que tener en cuenta todos los complementos de una visión holística. E incluso, lo converso mucho con los compañeros, en reuniones intergubernamentales que hablo de temas, incluso hasta la OMC. Y digo, hey, esto es importante, siempre tenerlo en vista, cómo se va manteniendo el comercio. Porque volvamos a la primera presentación. Si no hablamos de la perspectiva de comercio y si no hay comercio, pues no hay buques, no hay rutas, no hay navegación. Entonces tenemos que tenerlo de un punto de vista integral. Esa es una de las perspectivas que nosotros hemos identificado para poder entonces iniciar esa hoja de ruta, de entender cuáles son las energías renovables, la movilidad, la consolidación de las instalaciones, aumento de inversión en desarrollo sostenible, incluso el tema de la estructura de peajes. Y menciono como último el tema de los equipos, porque nosotros tenemos la misma situación que cualquier armador. 40 y tantos remolcadores, lanchas, dragas, etcétera. La misma condición o la misma situación tecnológica, con el déficit tecnológico, con un estudio que realmente va a ser necesario una investigación y desarrollo de conocer. El tema cuando se invierte en un equipo flotante no es a corto plazo, 5 o 4 años que pensamos, es una visión, una estrategia, identificando cuáles son las necesidades y cómo se va a comportar la tecnología. Y para esto nosotros hemos trabajado en una estrategia de carbono neutral. El Canal de Panamá justamente está pensando en el tema de carbono neutral en el 2030. Y miren la diferencia, que podríamos decirlo el próximo año. Sin embargo, la identificación de qué es ser carbono neutral técnicamente es compensar lo que haces. Pero ¿qué pensarían si hiciéramos una compensación al próximo año? ¿Al final estaríamos mejorando? Pues no, no tendríamos eficiencia. Es tapar un hueco con otro. Y al final esa no es la idea, porque si todo el mundo tapa un hueco con otro, pues no va a pasar nada. Y por eso es parte integral de identificar el tema de operaciones y los clientes y negocios. Y es cómo fomentamos que esos buques eficientes, que esos nuevos combustibles transiten por el canal, una operación eficiente basada en una gobernanza interinstitucional, pero teniendo en cuenta desarrollo sostenible de la cuenca, que justamente es lo que no. Pero aquí es muy interesante, y cuando hablamos de todos los combustibles, siempre me hago la pregunta, el tema. Ustedes saben, y esta es una experiencia que tengo, que las últimas regulaciones que se discuten son las de el STCW. Primero se discuten las modificaciones al SOLAS, MARPOL, cualquier otro convenio, y después entonces que se modifica, se pone y se activa y comienza a activar, a definir las reglas, por ejemplo, de formación o los cursos modelo OMI, etcétera, etcétera. Y eso es una de las cosas que justamente nosotros hemos identificado, el tema de la importancia del capital humano, mantenerlo actualizado. Podemos hablar de ningún combustible si no tenemos, por ejemplo, un capital humano debidamente calificado. Y por experiencia a bordo de embarcaciones, justamente en inspecciones y demás, nos hemos percatado que una de las situaciones que nos indican las mismas tripulaciones es justamente el proceso de entrenamiento que tienen para equipos nuevos. Y nos pasó con la implementación del IMO 2020. Cuando íbamos a bordo de las embarcaciones con scrubbers, en las primeras fases los chief engineers nos decían, justamente estamos en familiarización. Claro, él no tiene la familiarización, él no va a tener la oportunidad de estar en una oficina viendo todo esto, él lo está haciendo en día a día, justamente con los técnicos y demás. Y esa es una parte muy importante, con la segunda, transformación digital, pero lo más importante para nuestra región, investigación y desarrollo. Y ese quizás uno de los mayores gaps o faltas que tenemos en nuestra región. Por eso les mencionaba, cuando hoy estamos viendo una conferencia de esta manera y vemos una en Europa o Asia, están hablando de cosas casi similares, pero la implementación es totalmente diferente, porque están a otra situación y metiendo, digamos, recursos en investigación y desarrollo para poder saber cómo implementarlo. Porque al final la palabra lo dice y lo mencioné, es la sostenibilidad. Y por esto, nosotros hemos ideado una estrategia no solamente de carbono neutral, sino pensando en una descarbonización. Tengan en cuenta algo, la industria hoy en día ya tiene compromisos globales hablando del concepto descarbonización, y descarbonización es cero carbono. Hay embarcaciones que hoy en día, el año 2023, 2025, están siendo construidas para hacer carbono neutral o realizar viajes de carbono neutral con combustibles especializados. Esas embarcaciones no están dispuestas para nuestra región. Y es uno de los temas que cuando hablamos de los forecasts, específicamente de construcciones, puedo bajar una data de HGS, puedo bajar cualquier data de Clarkson y nos las presenta. Y siempre hago la pregunta, ¿cuál de esos barcos va o tiene o podría estar por nuestra región con la debida infraestructura de recalar en los diferentes puertos en una ruta o un servicio? Y cuando hacemos esa pregunta, prácticamente me gusta hacerla mucho y comenzamos a hacer el análisis, se limita 10-20% de esos números que nos ofrecen. Entonces es muy importante siempre tener en cuenta que esto es un negocio global y que las embarcaciones tienen la facilidad de moverse. Entonces eso es la importancia que nosotros hemos identificado en el tema de agregar valor. Por eso estamos hablando de un plan justamente a largo plazo, 2050, que contemple la importancia de poder reconocer, promover que esas embarcaciones que van a tener las partes tecnológicas como de combustible tengan las facilidades de, por ejemplo, estar en nuestra región y pensarlo desde un punto de vista integral. ¿Por qué? Porque se los puedo decir con toda propiedad que las embarcaciones no van a venir, o por lo menos esas embarcaciones de eficiencia no están diseñadas para venir para acá. Están para el Báltico, están para los corredores verdes, justamente, específicamente Asia, la costa oeste de Estados Unidos, que tiene regulaciones más fuertes. Y esa es una de las cosas que nosotros como región debemos promover y ver el valor agregado que vamos a brindar independientemente de la eficiencia o tipo de combustible que tengamos. O sea, eso es muy importante. Y hoy en día, los compromisos internacionales que tienen los navieros, y les puedo decir varias para que lo apunten y lo tengan en cuenta. Uno, el Clean Cargo Working Group tiene compromisos específicos. Los dueños de la carga, específicamente, están estableciendo como meta que para el año 2040 no utilizarán buques ni rutas que no sea cero carbono. El tercero, tenemos el Call to Action to Decarbonization por parte de la industria naviera. Tenemos más de 160 empresas y navieras que se incluyeron en el Call to Action to Decarbonization. Entonces, ¿qué es lo que estamos viendo en el tema de metas? En el tema de metas es que estamos viendo hoy por primera vez, de lo que yo he visto del aspecto regulatorio en la organización marítima, que la industria pide algo diferente a la organización. Y esto es interesante de la perspectiva de verlo, digamos, cuando tienes el tablero lleno y tienes todas, digamos, las figuritas pegadas. Entonces tú comienzas a ver que justamente hoy en día, mayormente, este mapa que vemos hoy en pantalla, tenemos que tener todos los actores identificados, como comportamientos, tipo, infraestructura y demás. Y en la medida que tengamos eso identificado, vamos a ir viendo cómo va el crecimiento. Por eso hay unos buenos estudios de la Organización de Energía Internacional, del World Economic Forum, que justamente te van haciendo mapeos de lo que llaman first movers y te van diciendo los primeros en movimiento y te van dando quiénes van creando esa infraestructura. ¿Por qué? Porque en la medida que vayamos creando esa infraestructura, tenemos que tener en cuenta que los demás lo van a hacer. Entonces, cuando hablamos de combustibles limpios, en el tema de infraestructura, ya particularmente, tenemos que, por ejemplo, lo que es el Cabo Buena Esperanza por intermedio de Sudáfrica, en la COP26, que estábamos en el panel en Glasgow, del UNTAC, presentó que tiene un proyecto inmenso de combustibles limpios. El canal de Suez acaba de firmar hace 2 semanas para la producción de metanol, específicamente asegurándose esos barcos que están saliendo con metanol para que transiten por Suez o estén por Suez. Y nosotros en Panamá estamos justamente brindando el tema de fortalecer valor agregado integral. Entonces tengamos esto muy en cuenta cuando hablamos de regulaciones, porque hoy en día estamos viendo algo que no había sucedido. La parte ambiental, que se está volviendo estratégica, y justamente hay un crecimiento desde el punto de vista de ese wellness por parte del consumidor final, por parte de ese dueño de la carga, que antes no era un actor. Antes él decía, mi carga me la pones en la costa, tal. Hoy dice, sí, me la pones allá, pero con una ruta que sea más baja en carbono, con un combustible tal y demás. Y entonces todos esos factores son los que hoy están influyendo en lo que generalmente nosotros conocemos. La biodiversidad. han invitado por el tema de se va a diversidad el tema generalmente tiene un impacto directo, y se lo puedo comentar a algunos ingenieros de máquina aquí, específicamente sobre la biodiversidad, el tema del marine noise, que está también siendo o entrando a ser regulado, y particularmente otro tipo de regulación. Panamá es un país bendecido, digámoslo en cierto aspecto. Tenemos justamente muchos aspectos ambientales positivos, pero que debemos reforzar. Y tener en cuenta que debemos ir teniendo, digamos, ese avance y demás. Por eso nosotros seguimos promoviendo nuestra ruta como una ruta eficiente, una ruta que por el momento permite una reducción de emisiones en comparación con las demás. Y va a depender de nosotros, y esto quizás cerrando, justamente en la medida que queramos poder como región mantener nuestra competitividad, teniendo en cuenta las inversiones necesarias, como justamente lo planea el canal, pero también las otras áreas de infraestructura, para que podamos seguir brindando un servicio. Porque la física es sencilla. Tienes una distancia que dura un tiempo. Y si quieres reducir el tiempo a mayor distancia, es velocidad. Por ende, olvidémonos en cierto aspecto con otros combustibles que tengan esa potencia, digamos, del slow steaming. Y eso también nos resta, digamos, competitividad como región. El mapa de actores es muy importante. Tengamos en cuenta que cada análisis que realicemos siempre hay un competidor o siempre hay alguien que está haciendo algo. Entonces nosotros no somos solos como región, y justamente tenemos esa situación que siempre lo he manifestado, es la necesidad de trabajar en conjunto como justamente pasa en otras áreas. Pero también identificarnos dónde estamos y en qué nivel estamos. Y hoy en Panamá lo que sí podemos decirle es que el canal, junto con todos sus aliados, estamos en el top main del tema climático. Pero esto puede variar y esto puede cambiar. Así que es la importancia de nosotros identificar desde el punto de vista holístico. No seamos o no cometamos el gran error histórico regulatorio, que es por sesión, como el análisis inicial que le hice. Primero era eficiencia, ahora nos olvidamos de la eficiencia. Nadie habla de eficiencia. Pues entremos a combustibles. Cuando pasa combustibles vamos a mercados y después nos olvidamos del anterior y nos olvidamos entonces del tema de safety. No, esto es muy importante que lo veamos integrar, porque cada medida o cada regulación, que podemos hablarlo en otro momento, impacta o tiene digamos, una incidencia en otras materias. Desde 1914, Panamá, con su canal, hemos sido una ruta que ha permitido el tránsito de diversas embarcaciones con diversos tipos de combustible. Hoy en día les puedo mencionar que por acá han pasado N cantidad de combustibles, todos los que han mencionado hoy, incluso hasta hidrógeno, han pasado barcos con hidrógeno que he tenido la oportunidad de ir a bordo, con fuel cells, etc. Pero la importancia está en cómo mantenernos competitivos, cómo seguir promoviendo este tipo de combustibles, este tipo de tecnología, y justamente trabajar en conjunto como país. Y en parte ese es el trabajo que nosotros hoy en día estamos realizando, de ver a futuro, con una visión a futuro a largo plazo, manteniendo la sostenibilidad, pero justamente no ser solamente la ruta verde que siempre hemos sido, sino el corredor verde natural, que justamente hoy en día vemos que se habla mucho de estos corredores verdes, es como nosotros seguimos siéndolo y manteniendo esta competitividad. Muchas gracias y traté de ser lo más breve posible en mi presentación. Cualquier pregunta a la orden.
¿Aló, me escuchan?
Se escucha.
Muchas gracias, estimado amigo y compañero Alexis Rodríguez, por su excelente presentación. Es un orgullo, créalo, estar aquí con usted y con todos nuestros expositores y los participantes que han estado compartiendo este momento tan importante de esta conferencia internacional. Agradecidos siempre de la mano, ya que ustedes son parte de nuestros aliados estratégicos en los procesos que estamos desarrollando en conjunto. En nombre de la Universidad Marítima Internacional de Panamá, del MTCC Latin America y de todo el equipo de lo que compone esta universidad, del rector y todos los que hemos trabajado para llevar a cabo esta conferencia. Le hacemos entrega de un certificado de su excelente participación en esta jornada que ha sido bastante extensa, pero donde hemos salido muy nutridos con excelente información de última mano y de las políticas y estrategias que estamos desarrollando para la descarbonización del transporte marítimo. Muchas gracias, estimado Alexis. Y bueno, como sabrán, ya hemos estado compartiendo con cada uno de ustedes unos enlaces donde aparecerá el enlace de evaluación de este seminario. Pueden llenarlo, ya hemos visto que muchos de ustedes están llenando y han recibido sus certificados de participación. Creo que eso es algo que hemos compartido y queremos darles a cada uno de ustedes a través de estas herramientas que nos permite la tecnología de que cada uno de los participantes tenga estos certificados de participación y puedan utilizar como marco de referencia en las actividades, en su currículum, ¿sí? Que han estado escuchando de viva mano, de viva voz, de los excelentes expositores que han tenido. Bueno, vamos a hacer un pequeño resumen, ¿sí? De esta conferencia. Creo que sin resaltar todo lo que significa la descarbonización del transporte a través de combustibles alternativos, a través de tecnologías. Tenemos que estar claros que para esto la Organización Marítima Internacional presenta dos puntos de partida, que entendemos que es la reducción del 40% de las emisiones para el 2030 y una reducción total del 70% al 2050. Claro, comparándolos con los niveles de 2008. La industria marítima debe trazar su rumbo y continuar ese camino hacia la descarbonización. Bueno, los combustibles alternativos neutros en carbono son fundamentales para alcanzar los objetivos de la reducción de emisiones de gases de efecto invernadero. Por eso es que debemos trabajar hacia ese proceso. Debe realizarse todo este proceso de descarbonización, como lo mencionaron muchos de nuestros expositores, debe realizarse en conjunto con todas las partes involucradas, ¿sí? Para poder entonces llegar a esas metas que queremos llegar. Las emisiones de bajo emisiones de carbono y llegar a cero. Entre normativas que conllevan al cambio y adaptaciones, ese es el objetivo principal. Queremos darle la gracia a todos los expositores y, por supuesto, a nuestros participantes que han creído y siguen creyendo en ese compromiso de transmitir el conocimiento y la creación de capacidades con toda la industria. Han brindado un excelente aporte entre preguntas y las respuestas de cada uno de nuestros expositores. También queremos indicar que luego de finalizada esta conferencia, presentaremos un informe tanto a la Organización Marítima Internacional, a las autoridades marítimas que han participado y a todas las autoridades marítimas de la región, por supuesto a nuestros expositores que estuvieron el día de hoy con nosotros, sobre los alcances y metas que se han obtenido en esta conferencia internacional sobre combustibles marinos alternativos y los desafíos para nuestra región de América Latina. Se presentará un equipo técnico interdisciplinario para elaborar esta hoja de ruta o este proceso sobre la sostenibilidad del transporte marítimo internacional, enfocados con los objetivos de promover y potenciar a nuestra industria marítima de la región. Por supuesto, con temas referentes de seguridad. No es importante tomar la parte de seguridad. Las nuevas regulaciones y tecnologías, la capacitación, creemos es un punto importante para este tema, ¿sí? Todo lo que tiene que ver con el precio y la cadena de suministro de estos combustibles alternativos. ¿Para qué? Para llevar entonces a la reducción de las emisiones de carbono, ¿sí?, a la atmósfera. Los obstáculos para esta estación también deben ser considerados, involucrando entonces a los diferentes actores en este proceso de transición energética. Queremos agradecerle a cada uno de ustedes nuevamente y quisiera que encendiéramos las cámaras para que presentáramos al equipo del MTCC y a todos los que estamos aquí presentes. Agradecido a cada uno de ustedes, a los expositores, a los participantes, ¿sí? Tomaremos una captura de pantalla. Thank you for everybody to be here with us. Now we want to switch on the screen to see all the participants because we want to take the picture, and after we can share in the final report of the conference. Agradecidos a todos ustedes, ¿sí? Esperamos entonces seguir trabajando en conjunto con todos ustedes, con la industria, con autoridades, con todas nuestras partes involucradas para este proceso, ¿sí? Que lo vamos a llegar trabajando en equipo hacia un transporte marítimo eficiente, sostenible y seguro. Muchas gracias. Nos vemos. Buena mar.
Gracias, Erwin. Muy agradecido a toda la organización. Felicitaciones.
Excelente tarde a todos. Gracias.